It's my pleasure to open the session and introduce our speaker who will be giving opening remarks. My name is Mary Beth Terry, and I'm here at the School of Public Health and the Herbert Irving Comprehensive Cancer Center. This is the first ever CME and nursing credit event here in New York City on environmental carcinogens and cancer. It's the second national event, the first one being in Boston last year, and we're thrilled to host it locally this year. We really want to thank all of the sponsors, including first and foremost the Herbert Irving Comprehensive Cancer Center, who is hosting this event, along with the Weill Cornell Cancer Center. We were able to, through generous support of our collaborators across New York City, also receive support from the Stony Brook Cancer Center, the Montefiore Einstein Cancer Center, the Tisch Cancer Center, and as well Columbia School of Nursing and the Columbia School of Public Health. We also received support from the Cornell Cancer Center for Health Equity and also from the Community Center here in New York City. And we also are supported by the Silent Spring Institute, as well as We Act for Environmental Justice and the Cancer-Free Economy. Because of all that support, we will have no industry sponsors for this event. And so the nursing school for the nursing disclosure wanted me to read out that all participants receiving nursing credits must attend the entire program to earn contact hour credit. You need to complete the evaluation form and return it at the end of the program to receive your certificate. There's no relevant financial relationships with ineligible companies for those involved, with the ability to control the content of this activity. If any arise, an announcement will be made. And again, there are no commercial support for this program. So it's my pleasure to introduce Dr. Anil Rustagi, who will be giving opening remarks. You will have full bios of all the speakers for today. So we're going to keep the introductions of our speakers very brief so we can focus on the content today. But I would be remiss if I did not tell you at least 3 things about Dr. Anil Rustagi. First and foremost, he's an exceptional leader of our institution, and he has headed our cancer center and has the remarkable ability to bring constituencies together. Through his leadership, we have worked more and more with cancer centers around New York City and state. He has supported all of these activities. He's also a committed clinician and researcher and focuses on GI oncology. And finally, and most importantly, he works tirelessly for the communities that we serve. During the pandemic, not only did he head our cancer center, but he was the dean of the entire medical school. He never slept. He was making sure that, as you know, we were really hit very hardly by the pandemic. And he inspires us all the time with his leadership. And he was a remarkable supporter from the very beginning for this conference. So without his support, this conference would not have happened. So please thank Dr. Rustagi.
Thank you so much to Dr. Terry. It's really an amazing symposium, and like you, I look forward to tremendous talks from experts in the field. I would like to thank the sister cancer centers for their co-sponsorship, and on this campus, our medical school, our nursing school, our dental school, and especially the Mailman School of Public Health, which is really the home for us on our campus for environmental health and environmental sciences, and has had a rich history and tradition in environmental carcinogenesis. And I think you'll get a flavor of that as the day progresses. So our mission is bold, but nonetheless necessary. And that's the discoveries that occur here on our campus will contribute to cures everywhere, locally, regionally, nationally, and globally. Very, very briefly, our cancer center, as an NCI designated center, has 260 members that span 35 departments and 6 schools at our university. We also have a category of trainee members where we put the spotlight on undergraduate students, health professional students, postdoctoral trainees. And we have 4 programs that are listed for you here that, as you can appreciate, span the spectrum from fundamental aspects of DNA, RNA, and protein biology, all the way to population science. And these are interdigitated with disease-based teams that are taking multidisciplinary approaches to research and care in breast cancer, lung cancer, GI cancers, brain tumors, and so forth. None of this would be successful, even remotely, were it not for our really exceptional dedication to our community partners through our community outreach and engagement office that's co-directed by Dr. Terry and Dr. Phoenix Matthews. And I'll give purposefully a shout out to the COE staff. They are remarkable individually, but especially collectively, and very influential in our journey. And like you, we have a commitment to diversity, equity, and inclusion in all aspects of academics. So importantly, today's learning objectives are listed for you here to understand how evidence about environmental carcinogens is developed and classified, and to understand the categories of compounds by levels of evidence, including New York specific exposure. Secondly, to identify policy and system level changes that can reduce the burden of cancer. And thirdly, to appreciate the important role of health providers as trusted communicators addressing environmental exposures, and to identify ways that healthcare providers can refer patients to the appropriate resources, as well as drive change locally all the way to nationally. Our agenda is enriched with really amazing speakers representing different backgrounds and levels of expertise. So session one will be about what we know currently about environmental exposures and cancers. Session two, whose responsibility, moving beyond individual behavior to recognize policy and systems level influences. And thirdly, how can we reduce community level risks, how physicians can inform policymakers and contribute to change. So some data that's been gathered by our COE office, and I'll try to provide a synopsis of that. So in this heat map, you can appreciate the gradients for cancer incidence, with red being the highest and dark blue being the lowest. And you can see this, unfortunately, geographic cluster in the mid-Atlantic states to the upper Midwest and parts of the South. And unfortunately, New York State has the 5th highest cancer incidence in the country. Well, if we focus in on New York State itself, then you see this second heat map and sort of gradients as well within the state, where there's variability, geographic variability in incidence, as well as the accompanying mortality. New York State has higher cancer incidence rates across all age groups. So I won't belabor these histograms, but you can appreciate New York City versus on your left in each bar graph, in green New York State, and in sort of dark blue United States. And if you look in pediatrics, ages 20 to 39, 40 to 54, 55 to 69, and a little bit disparity in 70, but you see pattern at higher incidence rates across almost all age groups. And this is a breakdown of New York City and New York State cancer burden, where we're comparing the 5 boroughs in New York City versus New York State. And what's striking here, and it's something we talk about a lot, and our COE office executes quite a bit, is to address not only the higher incidence in men and women across the boroughs, but especially in Staten Island. It's quite striking, isn't it? And so what is environmental justice? Everyone has a right to live and work in an environment that doesn't make them ill, regardless of race, culture, or income. This means that there should be fair treatment and meaningful involvement of all individuals, regardless of race, color, national origin, or income, with respect to the development, implementation, and enforcement of environmental laws regulations and policies with respect to the distribution of environmental benefits. So I will. Check. Okay, I should be doing that. Okay.
The mantra of the environmental justice movement is that we speak for ourselves.
Environmental justice is something that everybody is entitled to. It's a right.
It's a constant movement for healthiness, for a clean environment, for people living longer and happier.
Certain communities are targeted for pollution and do not receive environmental benefits. Those communities are generally communities of color and low income around this country. So environmental justice is the fair and equal treatment of all people in all communities. The environment is in our neighborhoods where we live, work, play, and go to school. For the past 28 years, WEACT has worked with community residents to engage in environmental decision-making that affects their community.
The bus depot has been here since like 1930s. We had buses that were hanging around and just idling.
Diesel is a known carcinogen. It exacerbates asthma, heart disease.
And I want to live to a ripe old age.
The bus depots in northern Manhattan was a prime example of environmental racism, that these communities were targeted.
The task force came together for one purpose, and that was to make sure that they were going to build another bus depot in this neighborhood. It was going to be done right, or we weren't going to let it happen at all.
Everybody got on board and we put the MTA to do all these good things for us.
We were able to get the MTA to invest in compressed natural gas buses and then in hybrid buses.
When they idle the actual buses inside, it goes into a particular piece of equipment. It just purifies it a little bit. If it wasn't for WEACT, we wouldn't have known all of this.
Now every city bus is cleaned up. Every community resident in the city is benefiting.
We control what happens to our community,
There you go.
and that's the best part about it.
Wonderful production. So thank you for attending. I'll pass along that 450 people have registered for this. Some in person, mostly online. So I think that's just extraordinary. And I'll turn it back to Dr. Terry and thank you for attending.
Thank you so much to Dr. Rustige, and thank you so much to WEACT for environmental justice, one of our longtime community partners. Next, I'd like to introduce Kimberly Burke, who is going to introduce the speakers for session one. Kimberly Burke is the Director of Community Outreach Engagement Office and also co-leads the New York State Working Group on environmental carcinogens. And so if you want to know more about that working group, we can let you know at the break. But this is a working group of volunteers from around the state who are working on the next cancer plan for New York State to update the information we know about environmental carcinogens. So thank you, Kimberly Burke.
Thank you, Dr. Terry. So today we're beginning our first session, which is going to be on what we know about environmental exposures and cancers. And we're going to be hearing from 4 different presenters, followed by a panel discussion. And our first presenter is Dr. Kate Guyton. She's going to be presenting on the state of the science and what is a carcinogen. And Dr. Guyton is a senior program officer with the Board on Environmental Studies and Toxicology within the Division of Earth and Life Science at the National Academies of Science, Engineering, and Medicine. She has more than 20 years of experience applying her expert knowledge in mechanistic toxicology and carcinogenesis, and she has been certified as a diplomat of the American Board of Toxicology since 1998. And her prior experience includes service as a senior toxicologist at the International Agency for Research on Cancer with the World Health Organization in Lyon, France. So Dr. Guyton, thank you so much. We're interested to hear from you, and I believe there may be time for a few questions following her talk, but we can also take individual questions for the speakers during the panel as well. Thank you.
Well, hello, everyone. Good morning and good afternoon, good evening to those joining online if you're coming to us from a different time zone. I just want to begin by thanking all of you who are here and especially the organizers for this opportunity to share some perspectives. I am currently serving at the National Academies of Sciences, Engineering, and Medicine, and a special shout out to our many volunteers who may be with us or online. And I'm going to talk a lot about my experience at the IARC, which is part of the World Health Organization. It is the International Science Agency for Cancer. If you all have an opportunity, as I did, to spend part of your career there in France, I can highly recommend it and happy to make connections on the break. So I just wanted to begin by just telling you all I have no financial interest related to the subject matter of my presentation. And what I'd like to do is kind of set the stage, really coming from that global perspective. Where are we with cancer? What does it look like today, tomorrow? And what's some of the progress? How can we identify what causes cancer and really focus on this concept of the key characteristics of carcinogens? So let's just jump right into it. These are some snapshots from the IARC website, and I just wanted to let you know, if you did not, that in 2020, breast cancer became the most common cancer in the world. And you might think, sitting here in the United States, which is a high income country, well, this is early disease, it's treatable. That is absolutely not true across the United States and certainly around the world. So this is really a remarkable shift that we're seeing. You also may be aware that cancers are rising in younger people. So this problem continues to be a very urgent one that certainly is worthy of our attention. Especially in low income countries, prevention is the only option. Treating your way out of the disease is not possible financially and for other reasons. And really, how do we prevent cancer is, first of all, if we could figure out what causes it, then that would be a huge step forward. And how we do that is through authoritative reviews, and these provide the scientific basis for action. So I have this little step. We heard about action, and we act on who we've been watching very closely. They're more on the action end, and I'm more on the evidence. Let's try to figure out how do we provide evidence that can then spur regulations and also actions by individuals. So at the IARC, the first question you might ask is, well, how do we know, how do we identify these carcinogens? And it's really down to 3 lines of evidence: cancer in humans, which is epidemiology studies. You'll hear from some epidemiologists later today. A lot of studies of cancer in experimental animals. These have been the foundation of identifying carcinogens for a long time, and as well carcinogen mechanisms. So let me just get into this a little bit in more detail here. So if you go to the IARC Monographs website, and what we know so far over the history of the program, which spans more than 50 years, here are the number of agents that have been into these different classes. Group 1 is the highest class. These are known carcinogens. You can think about things like asbestos, cigarette smoking. There is no doubt that these agents cause cancer. But, you know, it's a relatively small number when you think about it. When you think about this world of people who are developing all these different cancers, and this is actually what we know. It seems like perhaps a small evidence foundation. So in the IARC system is one of expert judgment. It is a tried and true method, and basically things are put into these classes by looking at the evidence that we have. And I will tell you that for group 1 carcinogens, most of this is based on studies in humans. People who smoked got more cancers. That's how we know it causes cancer. But there are opportunities to use the other evidence streams, and I'll get into that a little bit more in detail, but this is just one of the take-home messages. These epidemiology studies, which take a long time and are basically telling the things after the fact, that is a large part of our evidence base. And I just want to say, you know, you can think about, well, what are these different things that do cause cancer? And it is really a diverse group of things. We think about chemicals, but we can also think broadly about occupations if you're working in the mines, in other shipyards, so forth. Things like fibers, asbestos, I mentioned, metals, pollutants and pollution. Air pollution causes cancer, if you didn't know that. Radiation, some drugs do, and these are in this picture. Viruses, we've talked a lot about viruses in the last few years, but some viruses cause cancer. And we know that, and that is an opportunity for prevention because we know we can vaccinate against those, and lots of activity in that arena. So IARC reviewed all these group 1 carcinogens a number of years ago, and this was published in the 100th volume of the series. If you want to get into those high level knowledge. And another way you can think about this, I don't expect you to read it in detail, and I'm going to zoom in on the next slide, is what do we know about the different types of cancer? What are the causes and how do we prevent? And so this is, I think, one of the most popular downloads from the IARC website, because you can go in here if you're interested in lung cancer, bladder, whichever organ of the body. And let me just zoom in about what's known about across the different cancer types. And I just want to emphasize for lung, we have actually identified a lot of different causes. A lot of this evidence, again, coming from our occupational studies. I started by telling you about breast cancer, how we're so concerned about it and why with the rising incidence. And this is what we know. It's a very, very small number of things that we know. It is mostly coming from dietary studies, medical, pharmaceutical. This is more on the individual action side. We don't really have a lot of evidence to support, to understand what are you exposed to in your workplace, because women may come in, they may come out of the workplace at different times. So a lot of studies, I just say, well, let's just set them aside. We can study the men who have worked now 20, 40 years, and we have a more solid evidence base. So with Mary Schubauer-Berrigan, who's head of the IARC breast program, we published this commentary in Environmental Health Perspectives to say, hey, you know, you can still do a lot, and there's opportunities to get quicker answers in women, even in the occupational settings, if we knew what were the best short-term studies to do. So I also want to now come back to animal data and how we use studies of cancer in animals. These are very traditional studies where animals are exposed over their lifetime. And I think what I want to emphasize to you is the majority of the agents that are classified in group 2B, which in many countries, including in the United States, will trigger regulatory action. It will trigger protection. It will trigger coverage of cancer costs. Most of these group 2B agents were identified from animal data. So this plays a very significant role. But again, it's a long process. You know something to an animal and you may know the answer 10 years later. So if you were looking for speedy action, this is necessarily the fast track. So let me come to carcinogen mechanisms, and I'm really going to drill into this a little bit. And why are we interested in mechanisms? Well, we published this review a number of years ago, but it's still actually relevant today, which is slightly sad. But there is, if you look at just the number of chemicals that are in commerce and the number of these authoritative reviews, it doesn't really take a math major to figure out we have an enormous gap. There are so many chemicals, we have no data, we don't understand their health effects at all. We certainly don't understand how they may impact different populations. So this brings up some key challenges when we're identifying carcinogens. So first of all, if we don't have one of these authoritative assessments, does that mean there's no hazard? And how do we, this ginormous group of things we've never assessed, how do we choose? What are people concerned about? What is most likely to fill in a gap? And can the mechanistic evidence fill in the gaps? And why do we think the mechanistic data offer that opportunity? Well, this slide just shows you the range of different studies you can do to probe mechanisms of carcinogens. It could be a study of cancer in humans. We'll have some speakers later today who really have been pioneering in this area. We have studies in whole animals. We've got everything at our fingertips in terms of modern molecular biology that can really help crack this nut. And as I mentioned during this volume 100 review, this diverse data presents a lot of different challenges. How do you actually tap into it, systematically start asking, well, what could possibly this carcinogen, what types of mechanisms would it have? How do you bring uniformity from cigarette smoke to a particular chemical? How do you get through this pile of evidence efficiently? And how do you avoid bias, which if you're into systematic review is really the name of the game. So coming back to our carcinogens that I showed you earlier, what happened is in some workshops associated with this meeting is Professor Martin Smith, who is just retired from the University of Berkeley, had this spark that said if we could take what we know about the human carcinogens and their mechanisms and look at their characteristics, that could help us with an unknown agent. So this just shows, I'm going to test my technology. For each of these carcinogens, they're kind of sitting next to the mechanisms that they have. So some of these chemicals really bind to DNA, which we know is a vital thing. But other thing are viruses here. They really cause immortalization. They really get those cells to live forever and allow them to proliferate, which is this other key characteristic. Certain of drugs are immunosuppressive. Those are an important tool in our toolbox, but that also enables cancer. So we have to understand this is a broad set of mechanisms that these agents are acting through, and many of them have multiple mechanisms, but we can break down that complexity through this lens of key characteristics. And this is a slightly wonky slide, but bear with me. And really what it comes down to develop a systematic approach is you really have to come up with a question that you're asking. And when you go into a database or a set of databases, we use what's called the PICO question, but that just frames what you're trying to go after. What population are you interested in? What exposure? What's your comparator? What's your outcome? And then you have a very specific method. You can organize this all. If whatever problem you're faced, if you can break it down, you'll get to the answer quickly. And this really can address all these challenges that I faced, that we all face in terms of compiling and analyzing this data. And according to this kind of enabled this evidence-based IARC system to evolve significantly to where the mechanistic data can be pivotal when the human data are not sufficient. So what does that mean? So when you have a carcinogen and you're not certain about those human data, you can actually go all the way to group 1 and say, hey, this is a known carcinogen. Or you could put it in one of these lower classes that are still going to help, that still fill in the picture and may trigger regulatory action that can really protect workers and help those who are affected. So I'd just like to close now with some advice from the National Academies of Sciences. Having worked at IARC and also at the academies, we rely in both of these settings on expert volunteers who are coming from different walks of life and lend their expertise. And I've listed all these incredibly important people here who authored this book and really stimulated. They looked at this key characteristics approach when it was really in its infancy and said, hey, this is a great idea. First of all, we're not drilling down too early in blocking out a bunch of information that we need. And by the way, we could take this and start applying it to cardiovascular disease, same set of problems. Now, a subsequent report gave advice to the United States EPA and said, hey, these things can really help you organize your data, help you identify it and identify gaps. And we just released this report last Friday that just came out of this committee that's really going back to what I said about asking the right question. So when we think about new approach methods, when we think about the future, it's really down to what are the questions you're trying to address with these new tests and assays and this key characteristics approach is really amenable. It's going to help you figure out what do people really want to know. They want to know if this agent causes cancer. We've made a lot of progress with these methods in prioritizing for further testing. That's not a decision. But what we need to get to is a decision in actionable evidence. So I just want to close by thanking all of you. This is a picture of Martin Smith, who I mentioned earlier. Oops, oh dear. Invariably, I mess things up. Martin is here, who had this idea, but this has really been an enormous collaboration with really hundreds of people that we've tapped over the years, including many at IARC and beyond, and many co-authors. And most of all, I want to thank you all for your attention, and I'm happy to answer questions at any point today. I'll be here all day. So thank you. Well, it's a great question. So IARC evaluates agents. They have a priority setting meeting that occurs every 5 years, brings together different individuals from around the world. Some are who are working in public health, some are who are working in different settings, some are scientists working in the lab. And this group of people comes up with, here are the priorities to do over the next 5 years. Now, carbon monoxide has not, to my knowledge, been elevated to that top level, high priority for evaluation. So I think, but again, it's an evidence-based system, so we would really need to see some kind of evidence that could possibly lead to a classification. Not everything prioritized will be classified, but at least it has to, there's no point in spending a lot of time on things that aren't going to help you fill in blanks. One question in the back. That is a great question. I would have to, I can probably pull that up in terms of how much that does represent. It's a really good question. Yep. So that website I showed you earlier is basically tracking all that information real time on a global basis. So I can get with you and either explain how to do it, or I can come up with the answer a little later today. One last question. It's a great question. IARC, one of the most controversial assessments that was done was actually on these kinds of radiation doses that are emitted from cell phones and similar devices. And that at the time was classified in group 2B based on limited evidence from cancer in humans. So people in, studies of people, the studies were not definitive, but at the same time, the risk could not be ruled out. That's the basis of the classification. There's always pressure to look further into this issue, remembering that these studies are going to be retrospective to the older days of these cell phones that were emitting much, much more radiation than today. At the same time, not as many people had them. So it's a changing environment that we're in today versus that. These are evidence evaluations or snapshots in time. Snapshots in time. That's what we knew then. It doesn't mean it can't evolve.
Wonderful. Thank you so much for that. And Dr. Guyton will also be on the panel. So we'll have time to ask questions for them. Great. Great. Okay. Thank you so much. So I'm Mary Beth Terry. I'm going to speak briefly about what we've learned about cancer susceptibility and how that affects the human studies that Dr. Guyton had said are so critical for classifying carcinogens. I have no conflicts of interest to declare. So one of the aspects that comes up a lot in healthcare settings is the question of what I can do to prevent my cancer. So typically, a lot is known about smoking and about dietary influences on cancer, but often healthcare providers will be asked the very vital question about what happens when I don't smoke and what about the environment. And as you already heard, and I'll show you some data in a minute, cancers are actually going up at a very rapid pace in young adults. And these are cohorts that have not smoked. So we need to kind of understand better and listen to our patients when they ask about these other causes of cancer. So as Dr. Guyton just showed, we have very many carcinogens that have been identified in group 1, but there's also a lot of carcinogens that are in group 2. And how do we communicate what we know about these carcinogens to policymakers and to the public? So for better or for worse, and you can make your own judgment about that, I'll show you what happened, is on the right-hand side is probably a histogram that you've seen a lot, as well as data that have been in the public for many years. And these data basically are coming from human studies to kind of understand what are the causes of cancer and how can we attribute these causes to single agents. Well, first and foremost, we know that cancer is a complex disease. Second, we know, and there's many causes for any one individual cancer, but second, we also know that how we measure attribution for cancers very much is different based on the different types of cancer. So as Dr. Guyton just showed you, that the organ system that's involved, there's different levels of evidence for each of those organ systems. So what has happened with the way that policymakers are exposed to this data is they're just given one kind of figure like this where all cancers are put together. And so as a result, you can see circled on the right, that the percent of cancers that are attributed to environmental causes is quite small. So that has led many policymakers to say that this is not a significant problem. However, what we will argue today and throughout the day is based on the evidence, it's one, not small, and two, it's very confusing to put all of those cancers into one bucket. More recently, using that same data, environmental carcinogens have even come out of this, even though it's the exact same data. So these are kind of major issues when we think about presenting this data to policymakers and trying to understand the big scope of what the evidence base is showing. So overall cancer attribution clouds the heterogeneity across these cancer causes. So for example, WHO estimates a quarter of all cancers of the upper digestive area and bronchus and lung, 63% of mesothelioma are caused by environmental chemical exposures. So again, this attribution is also very much related to how we measure things. And so until recently, really, it's been very difficult in human studies outside of the occupational setting to measure environmental chemicals. So it's very hard for people to remember what they've been exposed to outside of an occupational setting. And so we use biomarkers and data linkages to do that. So more and more now we're able to do that in human studies, but in the past it's been very difficult. So what happens as a result are the things that are easier to measure, like smoking, get more of the attribution. And so even though people are exposed to smoke as well as many chemicals, smoking will be then the major factor. So here are the data trends for the US going up to projections to 2030. 30. On the right are cancers in males, on the left are cancer in females. What you can see right away is, as we know, more cancers happen in older adults. So the yellow lines in both of these are for adults 70 and over. And what you can see is across the last 50 years, the major decline in cancers have really only occurred in males over 70. So, yes, at a population level, you'll hear the statistics in the US that cancer rates are coming down and public health has had a big impact. And much of that is because of smoking. But what you can see very clearly is that in adults under 55, cancers have been going up for the last 50 years. And it's been going up particularly in women over the last 50 years. And so what I want to, again, talk briefly about today is how can we then gather evidence in human studies to really look at this more closely? So one thing we need to know about cancer susceptibility is everybody is susceptible, but everyone is not equally susceptible. And so how can we use that knowledge that we've gained to really get much more rigorous evidence on environmental carcinogens? So when I was training a long time ago, most cancers kind of were followed this schematic. And most people had this view that, if for any given cancer type, there's a cluster in red of cancers that are caused by genes. And there's the majority of cancers are not caused by genes or caused by the environment. You may, if you're younger than me, laugh at this kind of simplistic pictorial because we know that all cancers, cancer biologists will tell you this, are genetic. That's because they're either genes that have been inherited through germline or altered throughout your life through different mechanisms, including somatic mutations. So cancer epidemiology, however, kind of split based on this. So if you cared about kind of thinking about prevention and environmental factors, you did these studies of average risk people, in which primarily was where cancer occurred the most in older adults. And if you wanted to identify those genes, you did studies in younger individuals and you looked at families. And of course, many genes have been discovered through that mechanism. And so for a while, that was really great for identifying the high penetrant genes, as well as identifying the really, different causes of cancer. But what I would argue now for what Kate has shown us is what we're up against with this early onset cancer globally. That kind of way of doing study designs, I would say, is inefficient and should probably be thought to focus a different way. So here's what I'll show you then today. So here are the different genes that have been discovered, the different cancer genes over the last 20, 25 years. What you can see is, depending on the organ site, the prevalence of these cancer genes is different. The size of the gene represents the prevalence for those cancers. And so again, putting all cancers in one bucket never made sense when we think about genes. So why do we put all cancers in one bucket when we think about prevention and environmental factors? So again, these genes are important whether or not they are inherited or altered throughout life. So these genes were actually first discovered primarily through family-based studies. So I would argue that that kind of approach is a really good approach to think about for finding environmental factors. So here's a study that came out recently, and what you can see is, of all the cancer genes that we know about, so about 1,200 cancer genes, in pink are the ones that have been shown are germline inherited, and in yellow are the ones that are altered throughout life. They're the same cancer genes. And what's important to know is that what you can see here is that the burden from germline mutation goes down as one ages, right? So we always say that family history is a negative interaction, meaning that as you go through life, you acquire more family history of cancer, but that family history of cancer has less impact than if you had a young family member with cancer. So you can see the proportion of the germline variants are much lower, which in this area, which is where most of the cancer studies are done in humans, whereas the somatic mutational burden using those alterations in those same genes is much higher. And so if the human studies are not capturing this susceptibility, then they're going to be misclassified and it will be hard to detect signals. So another factor that we know, and we've learned over the last decade or so, is that based on modeling, if this is the way cancer curve goes for many cancers, it increases with aging, and your fitness, which is in green, decreases as you age. But what's different is that the mutational accumulation doesn't follow that pattern. So, and in fact, it's been estimated that the mutational accumulation from these somatic mutations in these cancer genes, of which most of the cancers that occur are from these somatic mutations, not from germline mutations at all, those occur before the body fully matures. So before about age 25. So that all speaks to this kind of importance of early life interventions and early life exposures. And so as Kate mentioned, breast cancer is now the #1 cancer in females around the globe. What's even more startling is of all adults under 50, 2/3 of all cancers in adults under 50 in the world are in women. So this is a major gender disparity and has huge impact on not just individuals, obviously, but families and communities, as many women are caretakers for multiple generations. So, so what's going on then with the environment in breast cancer? So then in the last few minutes, I'll just show you that here you can see this is a forest plot that basically there's lots and lots of studies for any given chemical and breast cancer. And they've been inconsistent. So why have they been inconsistent when the mechanistic evidence has been, growing and strong, and the animal data is growing and strong? Dr. Julia Brody and her colleagues, Dr. Ruth Ann Riddell, who are both here today and will be speaking later, what they showed was very compelling, which is most human data is operating outside of these specific windows of susceptibility that we know biologically are when environmental chemicals can most affect the breast. So if that's the case, we have many, many studies that are not relevant to the question of whether or not environmental chemicals are influence the breast tissue during these windows of susceptibility. So in blue here, you can see where most of the studies are done. You can see across the top here, these are all different periods when the breast is known to change in form and function. There's very little data. So, and in fact, most of the studies that have been done in this early childhood period, when we know the somatic mutation burden is changing, have been these animal studies. So what happens, however, when you look at studies that have been, which are the minority of studies, so it's only about 10 or 11% of studies overall have actually asked this question, which is what happens when we look at environmental chemicals during a window of susceptibility. So when the breast tissue is specifically changing in form and function, and there the data are overwhelmingly positive from whether it's organochlorine pesticides or metals or other kinds of exposure and environmental chemicals. You can see that the evidence is much, much more consistent. So we were also interested in this question of susceptibility, not just about windows of susceptibility, but overall genomic susceptibility. And again, because most studies of cancer are done when most cancer occurs, that has a huge influence on this heterogeneity in susceptibility. And so what you can see here is if you have an occupational cohort, then these people are highly exposed and you can characterize that exposure. If you have an enriched cohort, then you know these people are highly susceptible, and then you can look for the environmental chemical signal in non-occupational settings. But this is where the majority of human studies are done, in this lower quadrant, where they're non-occupational studies, particularly for studies of women, as Kate mentioned, because a lot of the occupational cohorts have been limited to men. And you can see that without capturing susceptibility, which they don't, they look at germline susceptibility, but again, they need to look at somatic susceptibility at that point, then you can't characterize it. So we did this in different family cohorts. This is one of our family cohorts where you can see we have a range of susceptibility. And so you're able to look at in people who are highly susceptible, what happens with environmental chemicals. But we also are able to look at, because again, there's family history is not just binary. You have a spread of risk within families. You can see that we have thousands of people that have average risk. So it's one of these ways to kind of look at a study design to capture this kind of underlying susceptibility question. And when we did that for one chemical, now we're extending it to a whole host of chemicals. Then with Dr. Gary Miller, he's been doing some pilot studies. You'll be hearing from him later with his exposome lab. We're able to start looking at hundreds of chemicals. Polycyclic aromatic hydrocarbons is one chemical that we started looking at in Dr. Regina Santella's lab years ago, and she developed a biomarker for it. And what you can see with one of the studies that Dr. Santella led is you can see that there is this association. It's small and modest in these kind of population studies that have primarily recruited people 70, 80, and 90 years old. And you see a little bit of gene environment interaction with different DNA repair. But when you look at a much more enriched cohort, you can see these are individuals who are much higher risk. This is a much smaller study that we did within our family cohort. You see now the signals are 4, 5, 6, 7 with people who are highly exposed and highly susceptible. So all of that is to say that these kinds of studies can be more efficient than trying to do it at a population level, because we can capture who's susceptible and who's then exposed. And so just then in thinking about that hypothesis that we had proposed, we looked at it. Other enriched cohorts, there's another family cohort in the United States, the sister cohort. They've also now confirmed in these higher risk women that there is relationship with air pollution and breast cancer and with dioxin emissions and breast cancer. And then we did a systematic review, and what you can see with the chemical classes that are highlighted on the left, in these family-based cohorts, 80% were overwhelmingly positive and statistically significant associations. But again, there's not that many studies, but the studies that exist support an association. With early onset cancer, which are cancers under 50, you can see the different highlighted chemicals. Those also supported an association. And in gene environment interaction, 74%. So again, a very different picture than that forest plot I showed you earlier, when you look at all the studies, which are overwhelmingly skewed towards studies in people who are in their 70s, 80s, and 90s, where most cancer occurs, but where we can't capture the genetic susceptibility. So finally, I just will summarize that it's never gene or environment, but it's gene and environment. So we have to consider the impact of the underlying and windows of susceptibility, particularly for common exposures that we're exposed to every day, and particularly in non-occupational cohorts. In the case of breast cancer and environmental chemicals, for windows of susceptibility, studies suggest stronger and more consistent association than outside these windows. But again, most studies are outside of those windows. For higher risk individuals, the studies overwhelmingly support stronger and more consistent associations than studies of average risk. So just like we have used family studies and enriched cohorts to find these genes, and these genes, like I showed you earlier in the talk, are just as relevant for people without a family history. There's a direct overlap between genes that are altered through germline, that are altered through somatic mutations. So just like we use special studies to find these genes, we need to think about not using necessarily population-based approaches for finding environment and gene interactions, but finding these enriched cohorts that give us the statistical power to look across the spectrum. So with that, I'll say thank you to my colleagues, and I'll pass it then to the next speaker. Or do you want to do one or two? We're a little behind. Should we do one or two questions, or? You choose. Okay, one question right there. Okay. Oh.
So I have a controversial question. And this reports or rather regarding women who are pregnant and who smoke or they're exposed to extensive marijuana in the streets of New York. We do know that there's a damaging effect on the brains of the developing fetus. The question I have is, are there any animal data or anything in which an animal is repeatedly exposed to that? And since the lifespan of the animal is very small, have we ever seen the increased incidence of cancer in this? Or it's not studied?
Yeah, no, a great question. I'll repeat it very quickly. So we have actually with our colleague, Dr. Rachel Miller, who's at Mount Sinai, we've done some studies of humans and she does the animal studies of kind of replicating what we were doing in the human studies for if the mother is exposed to air pollution that's similar to New York City and what happens then to the offspring in terms of mammary cancer risk. And so she has been looking at that. Other groups around the country have also been looking at that pregnancy window of susceptibility and have found some association in these animal studies. I could definitely send you those references at the break. I'll get those to you. And also you'll be hearing later this day from Dr. Jasmine McDonald, who is specifically doing now a human study looking more at that window of susceptibility right around pregnancy, because what we have seen more recently has been an increase, obviously in early onset cancer, but we also think that that window right after a cancer, so not just being diagnosed with cancer during pregnancy, but that window, the 5 or 10 years after the pregnancy, of that being a higher risk because pregnancy can act to fuel a tumor that's already initiated. So yeah, it's a very important question, but we'll have time more at the panel to talk about that. So great.
Thank you, Dr. Terry. Next, we'll be hearing from Dr. Rachel Zeg-Owens. Dr. Zeg-Owens is an assistant professor of epidemiology and population health at the Albert Einstein College of Medicine and director of epidemiology and the lead epidemiologist for the World Trade Center Health Program at the Fire Department of the City of New York. Dr. Zeg-Owens is principal investigator, co-investigator on multiple cooperative agreements funded by the National Institute of Occupational Safety and Health that examine cancer, respiratory disease, and mortality in World Trade Center rescue and recovery workers. Thank you.
Thank you. Hi, everyone. I'm Rachel Zeg-Owens. So I'm going to just start with a quick overview of the disaster itself and some timeline of everything that followed around there. So on September 11, when the planes hit the Twin Towers and then they subsequently fell, there was a massive dust cloud with blackout conditions. And then what followed were fires that burned through around Christmas of that year. Over 70,000 rescue, recovery, and cleanup workers were exposed to this dust, the fire, and other hazardous conditions, with little, if any, respiratory protection at that time. This includes firefighters, EMS workers, police, construction workers. Also, there were tens of thousands of area workers and residents who were exposed at the same time. The nearest air quality monitoring systems were actually destroyed on 9/11. So what we know about the exposures are from settled dust that was analyzed from that and collected from that area and then analyzed. And if you think of an entire office building that was destroyed and then turned into dust, that's what they were finding. They found pulverized construction material, which included asbestos, glass, fiberglass, many different things within the entire building. And a lot of this are known and suspected carcinogens, such as PAHs, PCBs, pesticides, dioxins. The one thing that was not elevated above baseline levels was radiation. So that's something just to know about what we're seeing. It's also important to realize that the exposures differed across time points from 9/11 onward as the cleanup effort changed and with the populations who were exposed. There's a lot on this slide. I adapted it from a paper by Paul Leoy, which was in 2006. But the main take home is in the first 12 hours, you had the collapse of the tower, the burning jet fuel, the building fires, and the resuspended dust and smoke. And that was exposing a whole swath of people, the rescue recovery workers, the local employees, and residents, the commuters, and the press. As time went on, later in September and then all the way through December, there were still smoldering fires and the debris was being re-aerosolized as they were digging through the rubble. That was though mostly exposing a smaller group of people, still quite large, of rescue recovery workers and cleanup residents. There are also a number of people who I won't touch on in this talk, but who were cleaning up inside the office buildings in the surrounding areas. And also the local residents who were cleaning up their own homes. And they were exposed to the dust that had entered in their homes at that time. So while everybody was exposed, there is no individual level measurement of their exposure. All of their information is self-reported. When somebody was at the site, what their conditions were, if they were in the blackout dust cloud, or if they were farther away from that cloud. And also, as many of you probably know, in the early days, there was no adequate respiratory protection. And while I have a firefighter here and an SCBA, I want to point out that the firefighters did have SCBAs, but those oxygen tanks only last about 15 minutes. So they could wear them and then they weren't good for the rest of the time that they were on the site. They would have had to swap the tanks out and they were also cumbersome to find everything. So protection was not well, they were not well protected. Then knowing that they were being exposed to all these potential hazards, there was a lot of emphasis on the follow-up of the medical screening and the care of those who were exposed. The CDC in 2001 provided medical screening for World Trade Center exposed workers. And in 2002, peer-reviewed manuscripts were published showing that there was an association between these exposures and respiratory conditions and symptoms. Over time, so to date, we now have over 800 manuscripts that have been published on the health of these exposed populations. That's both physical health and mental health conditions that have been associated with it. In 2004, more money was provided to continue to monitor and treat medical conditions following these exposures. And in 2011, the James Zadroga 9/11 Healthcare and Compensation Act was put into place. As part of this act, there was the World Trade Center Health Program, the World Trade Center Health Program. And this provides medical care for World Trade Center related conditions. And that includes respiratory and aerodigestive conditions and mental health. And this is all provided for free. In 2012, thanks to a lot of our research that was starting to happen at that time, cancer was included as a World Trade Center condition. And in 2015, the act was reauthorized for another 75 years. So care can be continued through 2090. So now I'm going to get into the studies. If you recall from a few slides earlier, there were many known and suspected carcinogens at the World Trade Center site. And this leads to biological plausibility, a lot from the IR studies that we just heard about. And some are stronger evidence and some are more based off of some potential evidence. The studies have mostly included two main World Trade Center populations. The rescue recovery workers, which includes firefighters, EMS workers, police, construction, sanitation, and volunteers. And then there are the non-rescue recovery workers who are the local residents and workers, students. There's a number of high schools and other schools in the area, and also commuters on 9/11. Most of the studies that I'm going to talk about today, and also most of the studies conducted, have been on the rescue recovery workers. So in 2011, we published the first World Trade Center exposure and cancer study. This study was on just under 9,000 World Trade Center exposed firefighters. And we looked at cancers from 1996 through 2008. We had to stop at 2008 because that's when the data were complete through while we were analyzing. What we found was that the risk of all cancers among World Trade Center exposed firefighters was slightly higher than the US male population, but this difference was not statistically significant. The risk for thyroid, and so that's shown on the far left of this bar graph. On the right side, you'll see that thyroid cancer, prostate cancer, non-Hodgkin's lymphoma, and melanoma were all significantly higher than the US male population. And the risk of lung cancer was significantly lower than the US male population. And this is likely due to much slower smoking rates that we have at the fire department compared with the male population in the US. So these findings, there's a lot on this slide, so I'm going to walk you through it. These findings were replicated in 2 other World Trade Center rescue recovery worker populations, and also in a study that combined all 3 of these populations together. So what we found was that 2 of these studies actually showed a significant increase of all cancers greater than the general population. If you'll note the far column in green, when we combined all 3, we actually found that the risk was actually significantly lower than the general population, but this may be due to a healthy worker effect instead. All studies pretty much across the board found that thyroid cancer and prostate cancer were elevated. Skin melanoma was elevated in some, significantly elevated in some. And lung cancer in the majority were significantly reduced. And this is probably again due to the lower smoking rates in these populations. Findings using non-World Trade Center rescue recovery workers, so these are the local residents and workers, found similar results for all cancer, prostate, and melanoma. However, is the general population a good comparison for these studies? Firefighters and other rescue recovery workers in general may be at increased risk due to their other environmental exposures, but they may also be healthier and have lower smoking rates. So therefore their cancer rates may be lower. So what we did was we actually compared our incidence of cancer in the FDNY exposed firefighters to the incidence in a cohort in non-WTC exposed firefighters from Chicago, Philadelphia, and San Francisco. And you'll see here that we also are seeing that cancer rates all across the board are increased, and thyroid cancer and prostate cancer are increased. It's important to note that the non-WTC exposed firefighters also had higher rates of prostate and melanoma cancer with lower rates of lung cancer compared with the general population. So these findings all are showing similar things, particularly for thyroid cancer and for prostate cancer. Where we're seeing that they're elevated. But is this a situation where the risk is consistent throughout follow-up, or does this risk change over time? What we did was we looked at that cohort where I said we combined all of the rescue recovery workers together, and we looked at the risk of prostate cancer. We found that the risk of prostate cancer was increased between 2006 and 2007. Prior to that, there was no difference in the rescue recovery workers compared with the general population. But then after starting around 2007, we see that they have about a 24% increase compared with the general population. So these findings may be due to a true latency in time. So in the disease, meaning the time from exposure on 9/11 to the detection of disease, or it could be an artifact of screening. World Trade Center populations are screened a lot more for cancer because they have a lot more monitoring than the general male population. And There are PSA testing involved in that as well, and a lot of that increased around that same time. So more research is needed to fully understand this relationship with World Trade Center exposure and prostate cancer. We conducted a similar analysis with the thyroid cancer cases, and we found that the risk of thyroid cancer was consistent over the follow-up time. So there was no difference, and it was elevated throughout this whole time. So what we've also been interested in is cancer precursors. Can we look to see if there's a marker prior to the actual diagnosis? So about 10 years ago, we started collecting blood samples from the FDNY firefighters and EMS workers who were exposed to the World Trade Center. We created a biobank. So using this biobank, we looked for the precursor for multiple myeloma known as MGUS. We compared the prevalence of MGUS in our firefighters with the general population from Olmsted County. And that because they have a population-based screening program as well. We also then in a follow-up study compared the prevalence of MGUS in FDNY firefighters and EMS, as well as combining them with the general responders who were police, construction workers, and so on. And we compared all of them to the general population from Mayo, from the Olmsted County Mayo group. We found that the risk of MGUS among World Trade Center exposed firefighters was 1.8 times greater than the general male population. And this was specifically or even more pronounced in the light chain subtype of MGUS, where it was over 3 times greater. Then in our follow-up study, when we combined all the World Trade Center exposed workers, we found that the age standardized prevalence was 9 per 100,000 persons. And this equated to a 2-fold greater risk of MGUS in the World Trade Center exposed compared with the general population. And we again are seeing this signal with the light chain MGUS variant of it. We also, using the same biobank, we looked for clonal hematopoiesis mutations. This is a somatic mutation, just as we were hearing about earlier. And we looked to see, so the clonal hematopoiesis is associated with increased risk of hematologic malignancies as well as inflammatory disorders. The overall prevalence of CH mutations was about 10% in our cohort. And we found that the first responders who actually had a higher odds of mutations compared with non-World Trade Center exposed firefighters from a different population. And the odds ratio was 3.14. We also, in the same study, looked at mice who were treated with the World Trade Center dust. And they found that they also developed similar mutations. So what we also wanted to know was, okay, people are getting cancer, but what's happening after? Everybody's getting this free treatment once they get cancer. So what does that mean? We found that among those who have a post-cancer diagnosis, survival was actually greater in the rescue recovery workers compared with the general population of New York State cancer patients. And that's specific to those who are in the World Trade Center Health Program. World Trade Center exposed members who were not in the health program had a similar risk of death compared with the New York State population of cancer patients. And so does the improved healthcare access from the World Trade Center program improve survival? This is something that we're really interested in trying to understand because this could help target future interventions once somebody has cancer. And this is ongoing research is planned around this. So in summary, I just want to kind of wrap up and say that we are seeing that WTC exposed individuals have elevated rates of some cancers and some cancer precursors. We are also seeing that cancer screening and increased care after diagnosis may be improving their survival after that diagnosis. So I just wanted to thank all of the researchers. This is a huge team of New York based and actually US members, and all of the World Trade Center health program providers, but also in particularly all of our participants, because without that, this would. Question.
Thank you. I had a question regarding the cohort that was unexposed to the World Trade Center. I think it was like the Chicago firefighters.
Yep.
And they showed higher rates of the same types of cancer, like thyroid, prostate. And so, and then you mentioned at the end that, you know, some of this could be due to a healthy coworker effect, healthy worker effect. It could be due to latency. But when you see these rates being similar to those that were exposed, wouldn't that discount the exposure being attributed to the World Trade Center exposure?
So.
And then my other question, sorry, is how frequently are firefighters in general screened? So for example, you said that those exposed to WTC were screened more regularly, but I was just wondering, in general, are firefighters just generally because of their work screened?
Those are both good questions. So this table is comparing World Trade Center exposed firefighters with non-exposed firefighters. So this is above and beyond that elevated that we're seeing. I just had a note here that in a table that's also in this paper, but not shown on this slide, compared with the general population, the non-exposed firefighters did have elevated rates of these other cancers. So the screening varies by city. New York City in general does a very concerted effort of annual screening regardless of their World Trade Center exposure. The one difference there is that in the city, in New York City, when they retire, that annual screening is no longer continued. For World Trade Center members, that is continued. And they retire about 20 years after hire, so that's in their mid-40s. So potentially missing a future window of being able to screen. San Francisco has a lot more cancer prevention screening. Every city is a little bit different. So that is something that is always a limitation in our study. Any other questions?
Well, my question is that there was a toxic plume that was circulating over Long Island for some time, and we were told that it was as a result of the fallout from the World Trade Center issue. So my question is, since it went over the high schools and the middle school, would that have been any risk of onset of disease, or, you know, would that be a problem?
I'm not aware of any research that has looked at that. My area is mostly within the World Trade Center rescue recovery workers who are on the site. So I think that that's a potential study if it has not already been done, and I'm not aware of any.
So you haven't even heard of that was actually going, circulating airborne now on Island? And,
I have not, but that doesn't mean it didn't exist.
well,
yeah.
Thank you so much for your data.
Sorry.
Okay.
Thank you so much, Dr. Zeg Owens. And we can take additional questions during the panel. So Next, we'll be hearing from Dr. Steve Stellman. Dr. Stellman is Professor Emeritus of Clinical Epidemiology at the Mailman School of Public Health at Columbia University. He has held scientific leadership positions with the American Health Foundation and American Cancer Society, and was a Fogarty Senior International Fellow with the International Agency for Cancer Research. Thank you, Dr. Stellman.
Okay, all right. So I want to thank the conference organizers, especially Mary Beth Terry and Kimberly Burke, for this opportunity to share the podium with so many distinguished speakers. I'll bring this around to how Dr. Guyton began. Prevention of environmental cancers often begins with research to understand their causes and the way that those causes can be controlled and perhaps eliminated. Today, this research often involves multidisciplinary teams of many numbers of specialists. Nevertheless, many important causes of cancer were discovered by a few individuals who were gifted with unique powers of observation and imagination. So I'm going to highlight just a few of their achievements that could help us deal with present-day environmental behavioral and social challenges. We'll go back about 500 years. Georg Bauer was a physician who lived near the metal mines of Saxony and Bohemia. In 1556, he wrote a treatise on mining technology, De Re Metallica, in which he described mining and chemical processing of silver, gold, and other metals. His name Bauer is German for farmer, which translates to his Latin name Agricola. Now I'm going to tell you just a little bit about a former president. I hope you don't mind. Probably not that former president. You may not know, but Herbert Hoover trained as a mining engineer. He and his wife, Lou Henry Hoover, translated Agricola's book into English in 1912, 16 years before Hoover became president. And even before that, he was the director of what evolved into the FDA. Then it was just the F, the Department of Food that President Roosevelt had created. As a physician, Agricola noted miners' respiratory diseases, but he didn't distinguish lung cancer from silicosis, which is a disease of lung disease of miners, which is not cancer, but which can be equally deadly. His contemporary Paracelsus, who's sometimes called the father of toxicology and who's known for claiming the expression, the dose makes the poison. Paracelsus Paracelsus lumped the wasting diseases of miners into a single category that he called Bergkrankheit, or mountain sickness. It wouldn't be another 3 centuries until Swiss pathologist Herting and Hesse gave an exhaustive description of lung cancer in miners, the same miners who worked in the same Bohemian mines. And then another half century before Lorenz argued that the culprit was radiation, which had only been discovered in 1896. And 5 more years until scientists finally identified radon, the immediate product of radium decay, as the ultimate cause of lung cancer in miners. Well, of course, everybody knows that uranium is radioactive and it causes lung cancer in unprotected uranium miners like the one in the photograph. Uranium mining companies, of course, blamed their workers' cancers on smoking or pollution and not their occupation. But in 1964, Joe Wagner of the U.S. Public Health Service, which then evolved into NIOSH, like when OSHA was passed, Wagner studied 5,000 uranium miners and demonstrated a strong dose response independent of smoking, a latency period typical of cancer biology, consistency with animals bioassays, such as the ones that Dr. Guyton mentioned, and a pathology that was different from most tobacco-related cancers. Taken together, these observations support the conclusion that miners' lung cancers came from their work environment. The most important cause of lung cancer today, as we all know, is cigarette smoking. But our knowledge of how smoking actually causes cancer starts with an 18th century London doctor's study of chimney sweeps. These were invariably young boys who led very short and unhappy lives. Many of them died of suffocation, but others died of a very rare cancer of the scrotum. In 1775, Percival Pott published an article on diseases that he often treated, including cancer of the scrotum. His hypothesis that it was caused by chimney soot is often regarded today as the first identification of a specific environmental cause of cancer. Chimney soot, well, what is chimney soot? Well, chimney soot consists of creosote And creosote is a mixture of coal tar and other organic compounds. In 1918, Japanese pathologist Yamagiwa and Ichikawa painted coal tar on the ears of rabbits and produced cancers in 100%, which earned them a nomination for the Nobel Prize. 35 years later, Ernst Winder replicated their findings using tar isolated from tobacco smoke. We'll come back and meet Winder in a few more minutes. Now, Winder and others showed that the actual carcinogen is not a single compound, but a large group of chemicals collectively known as polycyclic aromatic hydrocarbons, or PAH, which are produced when organic matter is incompletely burned. This giant cotton mill, which was called a mule, in this early 20th century textile mill in the American South, had to be constantly lubricated, usually by teenage boys called mule spinners. And many of these boys also developed the same cancer of the scrotum as the chimney sweeps had several centuries earlier in England. The lubricant that they used was a blend of a mineral oil that contained carcinogen PAH, plus an oil that was extracted from the croton plant. Now, croton oil contains a complex chemical called a formyl ester, which is not itself a carcinogen, but a so-called cancer promoter that enhances the carcinogenicity of other substances. The cancer biochemistry of formyl esters was discovered here at Columbia by Bernard Weinstein, who many of you knew and worked with. And who was director of the Cancer Center and chair of environmental health sciences. Now I'll move on to steel. Steel is made from iron ore and selected metals and a substance called coke, which is produced when coal is heated without air in giant furnaces called coke ovens, like the ones in this plant near Pittsburgh. The furnaces churn out large quantities of PAH plus byproducts in the form of a gooey residue, coal tar, which we just met in the chimney sweeps, and gases that are recovered and sold. Coal tar typically consists of hundreds of distinct chemicals, many of which are PAH. In the 1960s, Bill Lloyd, Anthony Ciacco, and Carol Redmond at the University of Pittsburgh studied lung cancer in 3,500 coke oven workers. Compared to other steel workers, the coke oven workers had more than double the risk of lung cancer. But if they worked near the top of the ovens, their risk was 5-fold. And if they worked top side for over 5 years, it was 10-fold. These workers were heavily exposed to PAH and other chemicals from the coking process. So now we'll move to asbestos, which we've also heard about. Asbestos was known to be fireproof by the ancient Greeks. Asbestos today, of course, comes from mines, many of which are in Canada and South Africa. Over the years, mining and construction practices have changed a lot in Western countries, as shown in these contrasting photos. However, 50 years ago, the American workers operated without any protection, as in the photo on the left. In some parts of the world today, things are no different, as in the photo on the right. Contrast that with 50 years ago, American workers cut asbestos pipe without protection, as you can see as the photo on the right. That is still done in some parts of the world. Contrast that with the protection afforded by today's moon suits worn by asbestos abatement workers. Now, most of you have heard of Irving Selikoff, the pioneer asbestos researcher. Now, if pulmonary physician Irving Selikoff had never studied asbestos in cancer, he would still be known as famous for establishing isoniazid as the frontline treatment for tuberculosis. But Selikoff saw many asbestos workers with lung disease in his New Jersey practice, and he knew that Sir Richard Dahl in England had studied asbestos in cancer. So with the collaboration of Kyler Hammond at the American Cancer Society and the close cooperation of the Asbestos Workers Union, he quantified the relationship between asbestos exposure and lung cancer as two very rare cancers of the linings of the lungs and stomach cavity that are called mesotheliomas. Bill Blott and Joe Framiti at the National Cancer Institute showed a synergistic or multiplicative impact of asbestos in smoking among men who worked in shipyards during World War II, where asbestos was in heavy use for fire protection on warships. And a warship, apart from battle itself, the most serious potential environmental hazard, of course, is a fire. And that brings us back to tobacco. In 1492, many of you may know, Christopher Columbus brought tobacco to Europe. By the end of Queen Elizabeth's reign, tobacco was the rage of London society, but her successor, King James, King James the Bible, wrote a famous so-called counterblast against tobacco physical and moral evils that had very little impact. In 1922, a medical student at Washington University in St. Louis, Alton Ochsner, was called in to see a case of lung cancer, which he was told was so rare he might never see one again in his entire career. By 1939, Ochsner was chair of the Department of Surgery at Tulane, where he observed 8 cases in 6 months, all of them were smokers. Ochsner and a young intern at Charity Hospital, Michael DeBakey, who many of you may notice from a different discipline, reported pathological details on an astounding 79 cases of lung cancer. And they said reported inhalation of smoke over long periods of time is believed to be a prominent factor. And indeed, by 1948, lung cancer had become more common. Ernst Winder, who is still a medical student at Washington University, convinced surgeon Everett Graham to let him interview several hundred lung cancer cases and controls. And in 1950, Winder and Graham's landmark study in JAMA found a strong association between smoking and lung cancer. Similar study by Richard Dahl and Austin Bradford Hill appeared in the British Medical Journal. There are 2 reports that inspired the American Cancer Society's statistical director, Kyler Hammond, to initiate a cohort study of nearly 180,000 men. And then in 1959, to start a study of 1 million men and women, aided by 68,000 volunteer researchers. The upper photograph there. And his study confirmed and extended Winder's and Dahl's finding. That was Cancer Prevention Study 1. The 1964 Surgeon General's report on smoking and health drew heavily on the publications of Winder, Dahl, Hammond, and many others. And it was the first time that the federal government actually took an official active position on the health effects of smoking. Of course, it will not be last. So I'll remind you that, again, what Dr. Guyton told us, that cancer prevention can be facilitated by our understanding of the biochemical mechanisms by which carcinogens do their damage. When Ernst Winder left Memorial Sloan Kettering in 1969 to create the American Health Foundation, he brought with him analytic chemist Dietrich Hoffmann, who then recruited chemist Steve Hecht. Winder and Hoffmann had already shown that the PAH isolated from cigarettes can cause cancer. But then in the 1974 paper in Science, they reported on a new family of carcinogens that came directly from nicotine in cigarettes called nitrosamines that they isolated from tobacco smoke. And they subsequently demonstrated a metabolic pathway leading to direct genetic damage in the form of an addict between this derivative of this nicotine-specific carcinogen and DNA itself. 50 years ago, getting a little closer to modern times now, some 80% of Japanese men smoked cigarettes, while practically no Japanese women smoked. In 1981, Takeshi Hirayama of the Japanese National Cancer Institute reported that women who were married to smokers had 4 times the death rate from lung cancer as women who were married to non-smokers. That single report gave rise to an avalanche of studies linking secondhand smoke exposure to lung cancer. And that series of studies goes on today. So there's a lot of history here, and this is pretty much what we have time for. So I'm just going to finish with the story of a remarkable woman who was not a scientist, but a service representative at New Jersey Bell, who became ill from the cigarette smoke of her fellow employees. Even though Bell Telephone refused to ban smoking in the office, it did prohibit smoking in rooms that had switching equipment on the grounds that it could damage the delicate machinery. So Donna Schiff was kind of pissed off about that. As she sued New Jersey Bell for the same protection, her lawsuit was successful, but it marked the beginning of a grassroots movement that ultimately led to state and local smoke-free workplace laws that has often been a prototype for community organization and action to reduce environmental environmental exposures, and may, in some sense, may be kind of the grandfather or great-grandfather of many of the organizations that deal with grassroots organizing here today. And that's our story for now. Thank you very much. think we're gonna have a panel discussion. Maybe we should get someone- I'll just start with that.
Thank you so much, Dr. Stillman. We're going to take questions for Dr. Stillman during our panel, which we're going to begin now. So I'll ask the panelists to come up to the table and take a seat. And our moderator for the panel is Dr. Ginny Mantello. And Dr. Mantello is the Director of Health and Wellness at the Office of Staten Island Borough President and an attending neuroradiologist at Montefiore Medical Center and Mainline Health System in Pennsylvania. She has launched and co-led multiple initiatives and coalitions, including the medical ecosystem for the Staten Island community organizations active in disaster, and several other coalitions related to cancer prevention and chronic disease prevention on Staten Island. So Dr. Mantello, thank you, and you'll be leading us.
Good morning. Good morning. Thank you so much, Kim, for that very kind introduction. And thank you so much, Dr. Mary Beth, Terry, and Kimberly, and your entire team for inviting me today to moderate this really amazing panel of renowned clinicians, scientists, and national as well as international experts. And before I go on to our introducing our panelists, I also want to thank the Columbia Herbert Irving Cancer Center and Dr. Terry and her team for the amazing collaboration and all the collective work we've done in the past few years on Staten Island, not only to educate our community-based organizations, medical providers about HPV-related cancers, sun safety, skin cancer, and also hoping to increase the HPV vaccination rates. So thank you so much. So we heard this morning from many experts about various risk factors, causes of cancer, attributions, as well as potential cancer susceptibility and layered effects of genetics, lifestyle, and environmental exposures, as well as group 1 and group 2 carcinogens. We also heard a little bit about high cancer rates and cancer burden in New York. So this panel will focus on what we know and what we need to know. But more importantly, are there things we should be doing differently to mitigate or reduce our risk for cancer, either at the workplace or at a systems level, say via policy change? So I'd like to start by briefly introducing our panelists and highlighting a few things in their careers as it relates to their work around cancer research, screening, and environmental exposures. Many or most of our panelists actually have been involved in evaluating impact of environmental and occupational exposures, specifically post 9/11, looking at World Trade Center survivor cohorts. And their full bios are available in the program for those of you that are interested. So after I introduce the panelists, and we have Dr. Paolo joining remotely. So hi, Dr. Buffetta. And welcome. So after I introduce the panelists, I'd like each of you perhaps to speak briefly for 2 to 3 minutes about your work and any specific area of research, screening programs, or initiatives that you might be involved in that might help lead into our discussion of high cancer rates in New York State, as well as potential environmental exposures and mitigation of such exposures. You already heard from Dr. Stephen Stellman and Dr. Rachel Zeg-Owens. So I will take this opportunity to introduce the rest of the panelists, and then we'll go into our panel discussion and questions. So I'm going to get started with you, Dr. Buffetta. Dr. Paolo Buffetta is the Associate Director of Population Science at Stony Brook Cancer Center and full professor in the Department of Family, Population, and Preventive Medicine at the Renaissance School of Medicine at Stony Brook University. He was previously at the Icahn School of Medicine at Mount Sinai as Associate Director of Global Oncology at the Tisch Center Institute. He was also at Columbia University, has been involved with the Cancer Society, the International Agency for Research and Cancer, or IARC, and the German Cancer Research Center. Dr. Buffetta, I know that you were at IARC for many years, and for 22 years, you've been the PI of a large grant looking at occupational exposures in World Trade Center cohorts. Are there any other things that you'd like to highlight in terms of your work around cancer research, screening, and environmental exposures?
Yeah, thanks. And I'm sorry I'm not able to attend the symposium in person today. Well, I've been working on multi-center international cohort studies. I coordinated these studies in multiple suspected environmental and occupational risk factors over the years. But more recently, I started a couple of large projects in Europe trying to implement cancer prevention within the occupational surveillance program beyond occupational cancer and really looking at other preventable cancers. So I think this was something really new that I started with collaborators across multiple European countries. And in fact, the reason I'm not in New York today is because tomorrow and Friday we have the first meeting of a large study in Europe. The idea being that one can try to incorporate cancer prevention into occupational health surveillance. So it tries to give a new point of view, a new value to the occupational surveillance system that are in place in many countries and in many industries. Try to go beyond just the pure focus on occupational exposure, but try to broaden into a larger approach for cancer prevention. I can elaborate on this later, but apart from that, my work has been mainly in occupational environmental cancer epidemiology.
Great, thank you so much, Dr. Buffetta. And that's great to hear. And we heard from Dr. Terry how important that is in terms of looking at preventable cancers beyond just looking at the environmental factors and genetic factors. So next, we're going to move on to Dr. David Prezant. Dr. Prezant is the Chief Medical Officer for the Fire Department of the City of New York and Special Advisor to the Fire Commissioner for Health Policy. He has overall responsibility for the Bureau of Health Services, Counseling Services Unit, the World Trade Center Health Program, and the Office of Medical Affairs. He is FDNY's Senior Pulmonary Consultant. He's also co-director of the FDNY's World Trade Center Medical Program, Principal Investigator for NIOSH-funded FDNY World Trade Center Data Center, and co-director of NIOSH-funded FDNY World Trade Center Clinical Center of Excellence. So welcome, Dr. Prezant. And is there any thing you want to highlight in terms of research or screenings or environmental exposures that you're currently involved with or have been involved since the 9/11 disaster? Not good.
At the fire department between different types of disasters and our use of personal protective equipment. I think it teaches us a lot about human nature and the use of personal protective equipment. With Ebola, we made certain that everybody wore all of the personal protective equipment, and we made certain 1,000,000 times over, because it was thought at the time, and possibly it's still true, that a single drop of body fluid anywhere on your body could kill you within days. So there was 100% commitment and seriousness about developing the PPE, training the PPE, using the PPE. Nobody said, I'm going to be treating an Ebola patient, not wear PPE. Contrast that with the fire department and everyone else's use of PPE and other disasters. COVID, the World Trade Center, where death is not immediately imminent, where many people feel, oh, it won't affect them. And despite all the training, despite all of the constant retraining, PPE is not used in an appropriate fashion. And that tells us a lot about human nature. And it tells us a lot about our emphasis on training. To date, the entire emphasis on PPE, over and above designing it, of course, and certifying it, two very important tasks. But after it's been designed, the entire focus has been on training. Train, 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 train. Retrain. That'll take care of all the problems. And what we clearly have shown at fire is that training is not. It's one part of complex human supervision, training, compliance, education, interaction that really requires an immense amount of effort and immense amount of research on how to do it properly, how to overcome the barriers that are actually.
Thank you so much, Dr. Prasan. So I'm going to next introduce Dr. Mary Reed. Dr. Reed is the Chief of Cancer Screening, Survivorship, and Mentorship at Roswell Park Comprehensive Cancer Center. Dr. Reed is a distinguished professor of oncology in the Department of Medicine and a key member of the Roswell Park scientific team that is collaborating with Cuban scientists on Simovax. As Chief of Cancer Screening and Survivorship, Dr. Reed has worked to expand Roswell Park's pioneering lung cancer screening program and develop other cancer screening initiatives within the Institute and in the communities of Western New York, and also established a survivorship clinical and outreach program. So welcome, Dr. Reed, and thank you for being here. Would you like to highlight and talk a little bit about some of your work?
Thank you, and thanks for inviting me to be on a distinguished panel. I think from our cancer center standpoint and my standpoint as the only designated NCI designated cancer center outside of New York City, we have a vast region of small cities and great swaths of very, very rural populations. And I think the majority of our work right now is to, one, get out of the cancer center and go into the community. We work with all the FQHCs in Western New York with embedded Roswell employees to navigate to cancer screening. Our focus is both on education and also on navigation for early detection, because while we may not be able to directly change the rates of cancer in general, we can definitely change the mortality. And I think both in poor urban areas and in very poor rural areas where veterans don't get screened, where it's 2 hours to get to a CT that will do a low dose CT, where the majority of firefighters are volunteers who have a mixture of training, who go on the fires where they don't know what's in the building. And so we're really pushing to do education, to drive a CT onto the tribal territories where they don't have CTs and they don't have mammograms, and to really start to provide an opportunity to get early detection and then navigate people to where they can have treated. And I think that for the majority of New York State, that is part of the problem, is getting access, providing education, and emboldening the community providers into being able to get their patients into early detection. Recently, we've done a lot with the professional fire departments in all the small cities in Western New York. And I don't need to say anything more than the expert, but I would say there's a huge cultural barrier to preventive strategies, to going to a doctor on a regular basis, to be examined, to talk about things that are bothering firefighters. And so in addition to training, in addition to providing screening, which we are doing
sort of outside the guidelines for firefighters. We really need to help them change this culture of preventive care. And I'll just say one thing about lung cancer. A lot of my research is based on looking at the transcriptome of high-risk cancer, lung cancer. And we don't really understand that transition point. You know, there's a lot of basic science going on in that area about how the role of immunologic factors, but we really don't understand that transition. And we for sure don't understand, in the absence of smoking, what's really driving people to getting cancer. They now represent 20% of lung cancer. Cancer is the major killer of retired firefighters. So I guess when we look at both from the World Trade Center standpoint and people who've been exposed to big events repeatedly throughout their jobs, we really need to begin to look at the science of what that initiation and these repeated hits take, because I think lung cancer is emerging more in the later stages after many years of exposure in these non-smoking firefighters.
Thank you, Dr. Reed. You all have already had the opportunity to hear from the remaining panelists, Dr. Kate Guyton, Dr. Rachel Zig-Owens, as well as Dr. Stellman. So I think we're going to go right into our panel discussion and questions. So we know that New York State ranks high nationally when it comes to overall cancer rates. In fact, it ranks 5th in overall cancer rates. And we heard early on also about the cancer burden in New York from Dr. Anil Rusky. So we also know that in particular, certain cancers remain higher on our list than others. And you talked about prevention. I mean, even looking at Staten Island and the culture and the very low vaccination rates, for example, in HPV, as well as the higher rates of HPV-related cancers, and why it's so important to focus on those, education pieces and preventive strategies. But we also know that some of the cancers seen in New York State may be related to environmental exposures, and role of environmental toxins is certainly plausible. Research in this area, however, has been challenging, as you heard from Dr. Marybeth, to say the least. And a lot of the studies have really not sort of teased those cancers as well as to different exposures. So for our panelists, in your expertise, knowing what we know, are there ways we can prevent, eliminate, or reduce exposures or mitigate our risk of exposure to environmental toxins? And I think we talked about this briefly. Dr. Prasad, you covered some of it. Should there be more stringent environmental controls in the workplace? Should we be using safer alternatives, perhaps say chemicals is one example? And then the second part to that question, and we can get to that after we answer the first, is that in regards to personal protective equipment, do we need to train workers and require its use, for example, in certain high-risk groups that have higher exposures and certain cohorts? So, going back to, and anyone can start us off and others can chime in, after and add to the discussion. So knowing what we know, are there ways we can prevent, eliminate, or reduce exposures or mitigate our risk of exposures to environmental toxins? Dr. Prasad, did you want to get us started specifically as it relates to FDNY? You kind of started that discussion a little bit already.
Thank you. So at least for firefighters and EMS workers, which is my area of expertise, it's very hard to use the primary control, which is environmental control. And clearly that's the most important, especially since PPE is never 100% adequate and never used 100%. So clearly environmental control is where we have to start. But in a fire, of course, that's a difficult thing to do. So I'm unfortunately going to have to skip to the PPE portion, but I hope the other people here will talk about the environmental aspect, environmental controls. In terms of PPE, I think as I started talking about before, we've learned a lot. And I think the same is true in terms of vaccination. Training / education is only going to get us so far. We cannot allow, at least in my opinion, history to be rewritten. Many people with, for example, the COVID vaccination are saying how so many high percentages of people have received the initial first 2 doses. People cite numbers like 98%. Having trouble with boosters, but 98% have been fully vaccinated. That's just not true. Initially, what got everyone from roughly 40, 45, 50% to that 98% was making it mandatory. Education only got you to 45%. Some people have said, well, that's not really true. A lot of people would have gotten vaccinated, but they didn't have equal access. There wasn't health equity. And I can't comment about that for the entire city or state or country. I wanted there to be health equity, but I can't comment on that. But I can say for FDNY, across all races, across all levels of the organization, there was 100% complete availability of the vaccine, all initially. And yet, to get from 45 to 100%, we had to make it. I think the same is true for PPE. You can educate, you can train, but unless the individuals are really committed to wearing it and wearing it appropriately, it's not going to be used, or it's not going to be used correctly. Now, there are some barriers that we can remove over time. And that is PPE has to be incredibly comfortable. It's not. You have to be able to communicate through it easily. Right now, there's some barriers. Because you can't see through it, there's a barrier also in just terms of recognizing facial expression. Very, very important. Also important with people that don't have complete literacy around a language, right? But even in people who speak the same language very, very well and they're adults. Yes, my dad used to wear sunglasses all the time. It used to drive me crazy because I could never tell whether he was joking or whether he was yelling, So, the same is true with PPE. Facial expression is really critical. So we have to do that. And we have to train better. But OSHA says that the entire responsibility for wearing PPE is the employers, not the employees. That has to change. Not because I'm the company doctor, but it has to change because it won't work. There has to be co-shared responsibility. I don't care whether it's 50% or something. But there has to be supervision and there has to be co-responsibility, or else it's never going to be done. And we saw at the World Trade Center that initially, as I go and said, the SCBA ran out, and then it took us a few days to a week to get adequate out there. But there wasn't the necessary supervision. There wasn't the necessary commitment. We got comfortable, so nobody wore it. And we have to do better in that respect.
Thank you, Dr. Person. Sure.
Just slide.
Slide.
All right, thank you.
Ginny, can I say something?
First, personal protective equipment.
We'll get to you in a second, Dr. Buffetta.
Okay.
Right.
I'll yield to Dr. Buffetta, who I can work with.
Go ahead, Dr. Buffetta.
No, they wanted to continue on the PPE story, so it's okay. I have a slightly different point, so I can go later.
One basic principle in occupational health is that there's a hierarchy of prevention strategies. The topmost strategy is removing the substance from the environment. And really, for firefighting, where you go into an unknown environment, that is not an option. So PPE is a fallback. But in general industry, all of the plants that I mentioned, coke oven, asbestos, etc., the the basic principle which works is to enclose the process, particularly chemical processes, so that nobody is exposed. Now, this is very expensive, and now we get into the economics of setting up factories. It's basic economics, but certainly there's no arguing about the principle that if you impose a chemical manufacturing process, it works. This worked, for example, remember in February this year, the crash of the train derailment in East Palestine, Ohio. Remember what the chemical involved was? Vinyl chloride. Vinyl chloride has been around for a long time, but the health hazards of vinyl chloride were actually discovered in Italy by a couple of toxicologists, Weill and animals. And almost immediately afterwards, a single clinician in Louisville, Kentucky, John Creech, noticed 3 cases of one of the rarest liver cancers that any physician has ever seen. Angiosarcoma of the liver. It's not just liver cancer, it's cancer that affects the arteries of the liver. And there were 3 workers who worked at that factory that manufactured vinyl chloride. The company put in a big fuss about changing its environment. These workers were actually supposed to go into the tank cars and clean them out without the protective equipment. Exposed. But within a year or two, Goodrich and many other companies completely re-engineered their manufacturing processes. Today, practically no workers are exposed on the job in the floor. Environmental hazard that happened in this Palestine. But the principle is here. The industry being processes.
I think that also touches on the first point that part of the question, should there be more stringent environmental controls, whether it be in the workplace or outside the workplace, and should we be using safer alternatives? And I know Dr. Guy wants to comment.
This one live. So just I wanted to make a brief comment and then I'll perhaps yield to President Feta. But just coming back to environmental exposures, and since we're in New York, I do want to remind people that very recently, New York City experienced the worst air pollution in the world, which is actually remarkable when you think about how bad air pollution is in some cities, India, China, where people cannot see down the block and have been wearing masks for a long time because they simply can't breathe. So I also want to remind you that IR classified air pollution as a group 1 carcinogen, okay, a number of years ago, 2013. And as we look ahead, this is an environmental exposure. It's going to touch everyone. I think I live in Washington, D.C. It was not hazardous, but it was unhealthy, not great. And, basically our mayor said people wear, you have your N95 masks. It's a good time to get them out and wear them outside. So, we have some tools, but this is a really changing situation in terms of environmental exposures. We have the fire, just talking about wildfires for a moment, where we have our firefighters who are on the ground exposed, but those plumes of smoke are affecting many people in different areas. So I think thinking about how some of these exposures can affect people, whether they're in the worker situation, whether they're in their homes in their cities, it is a little complex. And I want to come back to East Palestine and the vinyl chloride. There were some colleagues who were actually part of a group of people who were looking at what were the exposures in that community. And one of the highest exposures was an aldehyde called acrolein, which rhymes with East Palestine. Acrolein was classified as a group 2A carcinogen by IARC. This was kind of the leading contaminant that persisted in the air. It's going to be formed anytime there's smoke. It's in cigarette smoke. But again, these types of highly reactive compounds that our firefighters are exposed to whenever something is burning, but also can be occurring when there's this type of disaster, but is also going to be around when you have combustion from, automobiles and the like. So it's part of that big mixture of air pollution, and just one of the things to keep in mind that as we think about environmental exposures as well. So thank you for that.
Thank you so much for bringing that up, Dr. Guyton. And it really is incredibly important. And part of the goal of this discussion is so that physicians, clinicians, primary care providers, and others, get more comfortable with these topics and know how to guide their patients, for example. And I'll use the air pollution that we had recently experienced. And as the public health clinician, physician for Staten Island, for instance, immediately there was, an incredible sort of response from parents that were concerned and others, and they asked for, we hosted sort of a webinar to just answer questions. But it's important that we as physicians are comfortable and know how to guide our patients and our communities. So thank you for bringing that up. Dr. Buffetta, we're going to come back to you. I know you wanted to refute some of the PPE discussion, so please feel free, go ahead. The floor is yours.
No. In fact, I wanted to bring a slightly different point of view. And I obviously agree completely with Steve Steinman on his sort of, when he was stressing, the hierarchy of preventive actions. One aspect to consider, however, is that prevention of occupational cancer in the traditional high-risk industry has been quite successful. Not completely, obviously, but we have been able to control and introduce preventive measures and maybe some screening also in the traditional industries. And many carcinogens have been banned, etc. So in a way, there has been a shift, I think, which is not very well recognized, a shift from these traditional industries of asbestos, coke oven. I mean, Stephen gave a very nice review of some of these, classic situations of high risk of occupational cancer into a more diffuse setting. And this is more difficult to understand, to quantify, and also to prevent to some extent. There is one very nice example, which is about mesothelioma from occupational exposure to asbestos. The group of Julian Peter did a few years ago a very, very nice study in Great Britain, and they showed that the majority of cases of mesothelioma occurring in the UK now are not from people who were employed in the classic asbestos industries, but are in workers who were employed in something that we can consider medium risk or even low risk. A lot is about construction workers, but then there is a very large number of other industries. So we should really, and this, refers to mesothelioma, which has a low latency, etc., etc. But I think this is quite true in other settings. If we think about high exposure to PAHs, for example, or a number of other chemicals. So I think we should obviously keep a focus on specific industries where we know there is a possible risk, and we've been talking about firefighters is clearly one very, very good example of this. But we should also have a broader view and try to identify new circumstances of exposure that may lead to risk, which may go beyond, what we used to identify. We know the story of these high-risk industries because it was relatively easy to identify. Stephen mentioned vinyl chloride and all these cases. But today, probably we are in a situation where exposure is at lower level, but is more diffuse and still, may cause a number of cancers that are more difficult to identify. That was my main point. The other thing, unfortunately, I need to leave in about 5 minutes because I have this other meeting that I need to take care of. And I thought that, the panel was ending at 11:45, so I will disconnect in 5 minutes, unfortunately.
Really appreciate it, Dr. Mafetta. So actually that leads us into the next question, and maybe you could get us started on that. And you kind of touched on it a little bit. So given that none of these environmental strategies and PPE are going to be perfect, and exposures occur, and as you mentioned, we should be thinking about, those that have a higher risk, but even having a broader view. So we know that these exposures occur. What are sort of the cancer screening tools that we should be using? And then we can, touch on next in terms of higher risk occupations and whether or not they should have more different screening protocols than the general population. But before we get to that, really thinking about, the fact that none of these strategies are perfect, and PPE is not perfect. We heard from Dr. Prasant, there's definitely barriers to using PPE. Can you sort of touch on what are cancer screening tools that we should be thinking about?
Sorry, you, it's me, you say, Jeannie. Okay,
Yes.
well,
I figured out how you
I'm
start.
a little bit skeptical about cancer screening, apart from lung cancer, and obviously one can elaborate a lot, on whether protocols for low-dose CT scan should be, adapted to workers exposed or potentially exposed to lung carcinogens. But beyond lung cancer and possibly skin cancer for workers with a high exposure to UV, but the evidence is not terribly strong. I don't think we have any validated screening for other occupation-related cancer. And the most, how can I say, tragic example is mesothelioma, because really CT scan doesn't work for mesothelioma. So, for example, for workers formerly exposed to asbestos, and asbestos has this very long latency, so we still see cases of asbestos among people who were exposed, who stopped exposure maybe 30, 40 years ago, and still they get mesothelioma. And yet, there is no screening that works. So I think the screening area is more, the whole screening story is more an area for research, to identify early markers of mesothelioma, of occupation-related bladder cancer, etc. In terms of application, I think we should really restrict our attention to bladder, which is the only one which has strong evidence.
Great, thank you. Anyone else? Dr. Reed?
So I think in terms of screening, especially around occupational, we have to kind of get out of the box that we're in, because the guidelines right now have been based on, like for breast cancer, on the general population risk. And we're still debating how frequently we should do mammography. And we're definitely different than what they're doing in the UK and the rest of Europe. And so I think we need to step back, and we will do this with lung. I think there's a lot of a push among the people who are doing lung cancer screening to really look at risk as the indicator. We do, if you have a strong family history, you can get a mammogram earlier. We moved the needle for colon cancer to 45, and you can start to get colonoscopy much earlier if you have a family history. So we know we can do this based on risk, and we will do this with lung cancer. There's 2 bills in the state Senate. One of them is being debated. We hoped it would be voted on this next term, for professional firefighters, where our recommendation was to lower the time where you start screening based on occupational, how much time you've been on, if you've been in any sentinel exposures, like the chlorine fire on Niagara Street in Buffalo, where we've seen 3 glioblastomas among that one house that responded. So I think we need to move the needle and kind of get out of the silo where prevention people who do community outreach and screening don't really interact with the people who are looking at cancers among occupational cohorts. We need to really talk more and start to use it on a risk base. Because, you know, I honestly think that if we wait, if we do wait for another big study, and there is one in process out of the Harvard group and Jacob Sands looking at risk for lung cancer screening, but it's going to take a long time. We should start screening retired firefighters on a more aggressive basis. We should really educate them on symptoms of cancer. And I know it's going to come up whether we should use some of these blood-based screening tools. I have mixed feelings about them, but I think, you know, that's the next generation of cancer screening, where we put people really into risk buckets based on their on the risk they show us in their blood. That is probably the next generation. But we have to get out of our comfortable little silos and start working together, because otherwise we're going to miss cancers that we could have picked up earlier that don't put people's lives in jeopardy.
I think, yes, that's really, really important points. The screening world is based on a lot of parallel streams of technology that aren't always moving at the same pace. But on the other hand, I'd like to kind of elevate this a little higher in EPI 101 or Public Health 101. Screening is generally referred to as secondary prevention because it, with a few exceptions, it picks up cancers that have already happened and does not prevent cancers that haven't happened yet. Primary prevention is preventing cancers that will never happen. And we have a tremendous number of laws on the books already, environmental and occupational, between EPA and OSHA. The problem, one of the problems today, is many of those existing laws are being degraded politically by lack of enforcement or crippling the agencies. When Ronald Reagan was president, he put into OSHA, the OSHA director, Thorne Octor, was probably one of the most brilliant managers I've ever encountered. And he effectively dismantled much of the pieces of OSHA that had been painstakingly put together since it was founded in 1969. And as the political regimes in Washington change back and forth, you can see the ping-pong match between increasing and decreasing some of those protections. So we should not only improve our laws, but enforce the laws that are that exist.
Yeah, just a brief comment. I really appreciate this perspective about screening and where it can really be effective. And in a past life, I worked on colon cancer screening for people of average risk. And a lot of the advocates who were there in the room said, you know, what's so great about colonoscopy is it's see and treat. By the time you wake up, if you have a polyp, it has already been dealt with. Okay, mammography for breast cancer is a long way from that. So I just, you know, do we have, you know, how can we get better tools that really address that? And especially as you go into low middle income countries, if your patient may have traveled from a long, long way to some rural center and they're never coming back. So this is your chance to do whatever it is. So how do you, even if it's giving them a vaccine for something unrelated. So, you know, physicians have a very different perspective on, you know, how can we really do something right now for this person I'm looking at? And I think cancer screening, bridging that gap of these different communities is what it's really, really about, and really advancing. So we could be, colonoscopy is a fabulous, fabulous tool. And for many other non-epithelial cancers, we just don't have that.
Even though I represent the firefighters and EMS workers and their healthcare needs, I think we're here to talk about not just occupational cohorts, not just the highest risk occupational cohorts, but the general population that's exposed to items that should have never gotten out into the environment, but that are because of what you said, or get into the environment because of accidents, some which could have been avoided and some which cannot. Fires, air pollution, et cetera. So we're talking about everything. And yes, we would like to do primary prevention, but we also will always need secondary prevention. And you know, your points about colonoscopy being at the very highest level of diagnosis and treatment at the same time is really a unique perspective that I not thought about. And I thank you for that. The other ones can't possibly get to that level right now because of it's just so totally different. But I think what we need to recognize is that in America, where with the Affordable Care Act, all of the U.S. Preventive Task Force screening tests are for free. There is no copay, there's no deductible. There are some hidden costs that can sometimes happen, but they're not supposed to. And therefore, anybody should be able to have, if they meet the various different risk parameters, they should be able to have free colonoscopy, free mammography, free low-dose chest CT screening, et cetera, et cetera. We can argue that whether it should be at an earlier age, whether it should be at a greater frequency, whether others should be added, like prostate PSA. We can make those arguments, and they're all very, very scientific arguments. But the one thing that we have to come back to and recognize is that even with navigators, which are critical, these tests are dramatically underutilized. 30–50% of the population is participating. And we see that, you know, in the fire department where people feel that they're at the highest risk. And yet only about 50% of those people that qualify are participating in our low-dose CT screening program. I can't remember the exact number, but it's something like 70% or so at most are participating in colonoscopy. I think it's really actually a lot lower than that if you really look at it carefully. So how do we get people to do this? Right? How do we educate better? How do we make these more accessible, even more accessible than just the financial constraints? How do we educate our providers to be able to convince their patients to do this? And then how do we reduce the risks of false negatives and false positives by adding in risk-based equations or risk-based additional tests, clonal hematopoiesis that might identify somatic issues? All of this needs to be put into the mix so that you don't have the stories that true or untrue that circulate in the community. Oh, I had a colonoscopy. I know somebody who had a colonoscopy. They removed the polyp and then he died. You know, I know somebody who had low-dose chest CT screening. They found something. Yeah, low-dose chest CT screening is for free, but then he had to get operated on. He's now paying off a bill of $150,000 co-pays. And by the way, they didn't even find cancer. So we have to work on all fronts to improve our entire screening process.
Great, thank you so much, Dr.
Sure.
We're gonna we're running behind because we got started a little late, but sure, please go ahead, and then we're gonna wrap up with perhaps one
I just
question.
wanted to point out that as we screen more, we're going to also detect more. So that if we are screening in certain subpopulations, we have to make sure that we're comparing to appropriately screen or similarly screened populations when we're talking about elevated risk. This is something that I kind of touched upon, but I just wanted to throw that out there before we say that high risk populations then it's going to be a cyclical process that we're going to be self-fulfilling this look.
Great, thank you for pointing that out. So the last question was going to be about moving sort of from individual, you know, what we could do as an individual to really policy and what we could do at a systems level. But I know we're going to touch upon that later this afternoon when the second session will talk about who's responsible, moving really from individual behavior to recognizing policy and system level influence. And so we've had some effective policy level work. You know, we talk about tobacco and smoking all the time and lung cancer burden. So I know we'll be touching on that this afternoon. So I'm just gonna thank everybody and sort of wrap us up with one question, and this could be for anyone on the panel. The question is, thyroid cancer and prostate cancer are hormonal cancers. While I know the majority of FDNY are male, have women's cancer been able to be examined? And then in the same vein, have those with in utero exposure or those born from those World Trade Center exposures, have they been examined in any way for increased risk? So I said anyone, but I'm looking at Dr. Prasad.
I think the problem is not that we're only interested in men. I'm actually more interested in women. That was a joke. But the problem is that we don't have a lot of women in the fire service. So and we don't have a lot of women as general responders in the first place. So the studies that have been done, the very careful studies by Dr. Zygones and others, really have not been able to comment yet on whether there's an increased risk of breast cancer or ovarian cancer or the like. But we have to say to ourselves that we have to watch out very carefully for that, and we have to presume always in the favor of the patient. But as more and more women are welcomed into these workforces, as they should be, then we will be able to do the study. Hopefully by that time, we will have adequate PPE and other regulations so that we can say that they're not at increased risk because of all the other things that we've done.
Thank you. And Dr. Reed, last word. Oh,
I just wanted to say that there was a very nice study of breast cancer risk among San Francisco firefighters. Females, they have about 20% of their force are females, and they showed an eightfold increase in risk of breast cancer for women of comparable age, and the majority of those are under 40. So I think, again, we got to really get out of our silos and start talking to each other, because there's clear exposures that those female firefighters had during maybe critical times in their lifespan that they initiated these cancers. And so there's a lot of work that we can do, and thyroid is another one where we see an excess in women. Thank you.
I think one of the other things, Dr. Reed, I know you kind of alluded to this, but firefighters in outside of New York State, for example, are largely volunteers. So do they even have that, the health insurance coverage and the ability to get, their screenings on a routine basis and so on and so forth, coverage in terms of insurance. So, these are multiple things that we have to take into account.
So just to clarify, the majority of firefighters in New York State are volunteer.
Are also volunteers.
So,
Okay.
But there are two bills. One covers cancer among professional firefighters, and the other covers some cancer costs. It's hard to get your paperwork in for volunteers. And again, we're still working on enhancing the screening, but I think it's so insurance dependent, and that of course drives coverage for all of us, for everything. So.
Well, I really want to thank you all once again. I continue to personally learn so much, and I want to thank you all for being here and for all your expertise and guidance in these areas. I know the panelists are going to stick around, I hope, for lunch. And so if people have questions, feel free to come look for them during the lunch break. I'm going to hand it back to Dr.
Thank you. And thank you so much to the panelists and to Dr. Mantella. We do have lunch for all of you on the 4th floor. There's bathrooms on the 4th floor and on the 1st floor. It's a delicious, healthy salad lunch. So please do go up and have lunch. Unfortunately, because we are also online, we need to stick with the schedule. So When I was in high school, we had 22-minute lunches. So I'm sorry about that, but we do have to resume because of the recording and because a lot of the attendees are coming back at 12:30. We'll resume at 12:30. So please do, the elevators are right over here. The lunch is on the 4th floor, and please do come back. All of the questions that we couldn't get to online or by postcard, we will answer and send to everyone by email, so they'll have answers to the questions. So please do continue to fill out these cards, and the ones we don't get to by the end of the day, we'll give back to you by online. Thank you so much. Thank you for all of those joining us online. I'm sorry we're running just a little bit late, and I'm sorry you missed our very delicious lunch. But it's my privilege to introduce the leader of our medical school and the dean of the Vagelos College of Physicians and Surgeons, as well as the CEO of Columbia University Irving Medical Center, Katrina Armstrong. Oh, okay. All right. She's an extraordinary leader, and she is humble and has really been a renegade in health disparities research and environmental justice, and a leader of changing healthcare in our communities. So I will keep it brief because she is so humble and doesn't like long intros, but please do read the bios online.
Oh, Dr. Carey. I have to say, I'm really here as a fan of Mary Beth Terry. How many people in the audience would like, yeah, come on. I will say that. I also say that if we're a little behind, I want to keep all of that short. It is such an honor to be here with you all, to be part of hosting the 2nd annual national conference here to think about cancer and the environment. You know, there's so many reasons that this is critically important. I think it's part of our commitment to taking on issues of environmental justice and equity here at the medical center, what Mailman has been leading through the public School of Public Health in these efforts, what our cancer center stands for under the Irving name. And I just want to say how great it is that we're hosting this and how excited I was to be invited. You know, one of the things for me, I spent my career, as Meredith knows, as a cancer disparities researcher. And I came to that fundamentally from caring for patients in East Baltimore. So I was a medical student, a resident at Hopkins. And I can tell you that the burden of disease of cancer in those communities was just extraordinary. And so for me, trying to understand how we in medicine and in public health can take on these extraordinary disparities, figure out levels of intervention at every level, at interventional level, at the medical level, at the systems level, has just been my passion ever since. And I will say, as a primary care provider, the issue of being able to talk and understand the data we were just talking about is about the exposures, the environment, how that influences cancer was some of what I spent my time on. You know, understanding the critical issues about how we at the system level, and we're going to hear about this, can influence that relationship, how we can address the fact that cancer remains the #1 cause of premature mortality here in New York, and how we know now that, and I think the data here suggests that IARC has classified over 100 agents, as you know, as carcinogens. How, as healthcare providers, as public health professionals, that we can take this on. So I just want to congratulate Mary Beth and the team, Dr. Terry, for having this conference. I wish I could say for the whole thing, but I'm delighted to be able to hear some of these talks. And thank you guys again for being here and for having me. Thank you, Mary Beth.
Great. Thank you so much, Dr. Armstrong, for all of your leadership and for sponsoring this forum today. I'm going to introduce Susan Lloyd, who is going to kick off the afternoon session, and we'll be introducing the speakers. And we do have a very short video that will be first. As you're coming up, Susan, I'll just say a little bit. Susan Lloyd is the co-lead of the New York State Environmental Carcinogens Working Group. Again, if you'd like to volunteer for any of these New York State groups, see us at the break and we can give you some more information. Great. Thank you.
Yes, so first we'll have a short trailer for the video Unacceptable Risks.
I went into this with a number of preconceived notions
I learned an enormous amount. I thought that all chemicals were tested before they were put on the market. Turns out not to be true. I thought that anything that's known to be a carcinogen would be regulated, also not true. And I thought that if there were regulations about something, that the regulations would be enforced, which is also not necessarily true. So that was a huge eye-opening experience for me.
Okay, I am pleased to introduce the presenters for session 2 today, whose responsibility moving beyond individual behavior to recognize policy and systems level influences. Our first presenter today is Dr. Phoenix Matthews. Dr. Matthews is a professor of behavioral sciences at the Columbia School of Nursing and a clinical psychologist with more than 25 years of experience in examining determinants of cancer-related health disparities with a focus on racial and ethnic minorities and other underserved populations. Their research focuses on the use of community-based and culturally targeted health promotion interventions to reduce risk factors associated with cancer disparities, including smoking cessation treatments. Dr. Matthews today will be presenting on tobacco and policy failure around menthol and flavor ban. Dr. Matthews.
Good afternoon, everyone. It's a pleasure to be with you here this afternoon. So this is one of my first conferences as it relates to environmental influences. What I've learned thus far has been really, really eye-opening. And I hope that I can continue the conversation as we think about moving from beyond individual risk and individual responsibility to look at the role of public policy and helping us to reduce cancer and to move us more towards health equity as it relates to cancer. So those of you who are here, who are from this very famous School of Public Health, you'll know this definition quite well. It has indeed, throughout our history of humankind, that public health has done more to, and public health policies have done more to improve health and health outcome than many of the things that we can think about. And there are a list of some of the public policy successes that we've seen over time. The most effective public policy is based on evidence, right? And we've heard some fantastic conversations this morning about the evidence as it relates to environmental risk factors. However, as we know that policies are often live and die in the hands of politicians, there are important instances where science and the wisdom of public health practitioners are ignored as it relates to one of the most pressing issues in our time right now, especially in my home city of Chicago, that's gun violence. If policy was led by violence, by data, we'd have half the gun-related violence that we have now, but unfortunately, that's not the case. So what happens here when there's a breakdown of the connection between science, public health practitioner, and actually what gets legislated is what we refer to as politicized health policy, in which public health policies become informed by things like individuals' career preferences, political affiliations, and big lobbyist groups. And we've seen that in many forms across time. Some of you will be aware of some of these differences in policy and legislation. Crack versus cocaine sentencing, treatment versus incarceration as it relates to drug-impacted mothers, and most recently, the politicization of public health policies around COVID-19 prevention. I want to talk with you about tobacco policies and the ways in which politicization comes into play or doesn't as we think about moving the needle towards environmental equity and tobacco control equity. So the Surgeon General's report was described earlier. Thank you for that historical background, Dr. Spellman. Since that time, the needle has moved tremendously as we think about smoking behaviors. And that report was the impetus for a range of important public health policies. And you can see on this timeline what a tremendous influence that has had. Since the time of the Surgeon General report, where smoking rates were about 45% to where they are currently at about 11% of the US population. That's tremendous success. And that's what public health and public health policy can do for us as a health of a nation. But we also know that we have higher rates of incidence of tobacco use and tobacco use exposures across a variety of underserved population. And as we've also heard, smoking continues to be one of the leading causes of premature death. When we think about equities and inequities as it relates to smoking related burden, we have something that's really interesting as it relates to what's called the African American smoking paradigms. What that is that we know that Black smokers smoke at equivalent rates of other groups, smoke fewer cigarettes per day, are less likely to be daily smokers, and start smoking at much later ages. Despite that, African Americans are much likely to be impacted by smoking-related illnesses, especially lung cancers. So from this slide here, you'll see that Black men in particular, African American men in particular, are much more likely to be both diagnosed with and to die from lung cancer, despite what I just was telling you before about overall lower exposure to cigarettes. Again, much of what we have been learning about speaks to the dose response relationship between exposures and health outcomes. And here we're seeing something very, very unusual. So let's talk about the ways in which politics or health policies have been politicized in the context of tobacco prevention and control, keeping in mind the Black smokers paradox as we do so. So in 2009, Congress passed the Family Smoking Prevention and Tobacco Control Act, a very important piece of legislation that was aimed at reducing initiation of tobacco use among young people. Many people aren't aware of this, but tobacco addiction is an addiction of youth. Most the smokers start smoking at a very early age and will continue into adulthood. So this ban was specifically did a number of important things. Was aimed at reducing youth smoking, put a ban on all flavored cigarette products, as well as giving FDA regulatory authority over the tobacco industry. There was one curious thing that happened as a part of that act. It was something that's called the menthol exemption. So all flavors from combustible cigarettes were banned. Cherry, Fruity Tooty, all those, but with the exception of menthol. And so although it wasn't banned at the time, the FDA put into place a period of review and scientific review to determine whether or not it would be to the public's benefit to also include menthol in it. So let's look at the evidence. Policy should be driven by evidence, right? Scientific evidence. Let's look at the evidence as it relates to this policy decision to exempt menthol from all the other flavoring bans. Well, if you want to reduce youth smoking, especially as it relates to flavored products, one would think you would start with the flavoring that was most preferred by youth, right? So data suggests that the vast majority of young people who start smoking use a mentholated product. And we see that there are some racial ethnic differences in that. And to an astonishingly high level, Black youth smoke menthol. 71% of Black youth who smoke cigarettes use a mentholated product. And the research is showing us that youth, regardless of their racial ethnic background, are most likely to transition, who start up with a mentholated product, are most likely to translate it into smoking as older adults. You see that same pattern of high rates of menthol in adults. So showing that trajectory from youth initiation to among Blacks and to continued use at high rates among Black adults. So we also think about market share. So we could look at other indicators of evidence. So after 2009, when the Tobacco Control Act was put into place, menthol cigarettes had a very large proportion of the market share. When you look at flavors like bubble gum and cherry and other types of flavors, they don't even register. So again, thinking about sources of evidence. Here's the most interesting one. Menthol cigarettes have been associated with much higher rates of addictiveness than non-mentholated cigarettes. So if you think about what products youth are smoking, what the levels of addictiveness and market share, the prevailing evidence would have said, we'll start with menthol. We can leave cherry alone too, really well, but we better start with menthol. That hasn't happened. When we think of the implication for lung health, as well as other tobacco-related illnesses, we see some interesting findings. African-American smokers, Black smokers, are much more likely to report an interest in quitting, to have a past year quit attempt, but much less likely to be able to quit smoking. Now, what have we learned about Blacks, adults, and product use? Upwards of 80% use a mentholated brand. Menthol is associated with higher levels of addictiveness. So we start to begin to understand the increasing importance of regulation of mentholated tobacco products. So let me shift gears a little bit and say why. Why is it the case that African Americans, Black smokers are using menthol products at such a high rate? A lot of that has to do with tobacco industry efforts. In low-income minority communities, advertisements are 10 times those of rates in the other communities. Exposure normalization is the impact of advertising. We also see a history of predatory targeting of Black children. This is a case that was adjudicated that a son sued on behalf of his mother, who was given free cigarettes when she was starting at 9 years old. She traded them for money and candy until she was 13, when she started to smoke and died at the age of at an early age due to lung cancer. So there was not only advertisement, there was this predatory targeting for addiction of young people. That continues, especially around mentholated products with price reductions, tobacco realtors, as more shelf space, as well as manipulation of prices around minority serving schools, so that those convenience stores, the cigarettes, the mentholated cigarettes cost significantly less. What do we know about youth? They're very price sensitive. What do we know about lower income communities? Very price sensitive. So these are calculated efforts to addict Black communities by the tobacco industry. And it's been effective. This is Chicago. These darker areas here have some of the highest rates of current cigarette use and tobacco related morbidity and mortality. Those all, if you had another map that showed the racial ethnic distribution of Chicago, guess where the alignment would be? Almost a one-to-one relationship between darker areas that are impacted by tobacco use and residents of racial segregation of Black and brown communities. So with all that evidence, strong public health and other types of evidence, what has the FDA concluded? Very wisely, in 2011, the FDA advisory board said removal of menthol cigarettes would benefit public health. They doubled down in 2013, doubled down on this. Likely that menthol cigarettes pose a public health risk above that seen with non-mentholated cigarettes. Slam dunk, right? Slam dunk. More than 10 years later, after the FDA has determined that menthol cigarettes pose a higher level of risk, we still see inaction and a failure to regulate menthol in the same way that other flavors have been regulated with combustible cigarettes. Now, the FDA has been very active as it relates to e-cigarettes, and that's positive. Anything that moves us towards improving the health of the nation is a positive thing. But what we see, so this is relates to the action that has indeed been taken around e-cigarettes, and that's very good. However, when we think of equity and equitable tobacco policies, we see another, and again, the impact here will not help us with the e-cigarette regulation. It won't help us with what we're seeing with Black youth or Black cancer rates, lung cancers in the Black community. Because such a relatively lower percent of Black youth are using e-cigarettes. Again, policy in this area is brilliant, but what communities are we leaving behind in our efforts in our inaction? So FDA is getting really serious now. 2021, they said, okay, we're going to do something. We're really going to do something now. Now it's 2023. We see that there's been some really smart scientists have looked at what would have been the impact if menthol would have been banned at the same time as other flavorings. And they estimate that over 600,000 lives would have been saved had there not been the politicization of menthol in earlier policy and the continued politicization and FDA inaction. And the vast majority of those lives saved would have been in the Black communities. So failure to ban menthol is evidence of the ways in which politicians, the prioritization of industries like the tobacco industry stand in the way of effective public health policies, especially policies that have abilities to move the needles on what we're seeing in cancer-related inequities. The same thing has the potential to occur in environmental science, environmental exposures to cancer, and where some of the communities that have the strongest political and social voices are consistently able to block themselves, protect themselves from a lot of environmental risk. The same isn't true for other communities. And we have to do all as a community of scientists, activists, practitioners, and scholars, we have to make sure that public policy in this arena has to be done in an equitable way, and to think about and monitor the policies as they're moving through, making sure that community activists and others are at the table when these types of decisions are being made. And most importantly, when we see evidence of differential harm that we have. Thank you. I guess there's time.
That was great, Phoenix, thank you. There was a bill that was going through New York State legislature to ban menthol. Do you know what happened to that? Because it did not get passed, or it didn't get voted on this session.
The tobacco industry happened to that. Not to be flippant, but they have very deep pockets. They have a long-standing relationships with many of our public officials, and we've seen it at every level. And so undoubtedly, it's caught up in advocacy and money. Yes.
Thank you very much for your interesting presentation. I have a fundamental question. What is the role of celebrities in avoiding or in guiding these individuals in the Black community? For example, sports people. For example, the people who are in power. For example, the entertainers. So what have they done? These are our people.
It's an interesting question, in that marginalized communities have a long history of resiliency and a lot of internal supports. But at some point, we have to hope that the same protections and laws and policies that would protect all of Americans would also be inclusive of those who have the least voices among us. So yes, celebrities play a lot of the role in terms of influence, but we heard very strongly from the individual who did work with the firefighters that we can only get so much with education, training, recommendations. It requires public health policy, requires mandated change. And one that we could start with is mandating the restriction of menthol and all types of nicotine. So there is a role for community. Community is very strong and powerful, but legislators need to do the right thing.
I'll keep that to myself just for a second. One of the things that has happened over the years, and I'm trying to remember, I think this mostly came out of issues of fast food and kids in schools and what was being sold in these little, what people had access to, right? But if there ever been an attempt to try to get somebody, and I don't know exactly who that is, to figure out whether we can incentivize the stores to do something different in these neighborhoods. Now, I'm all for what you're suggesting. Does that make sense? It's just that people are dying while we're waiting for them to do the right thing. And I've always wondered, I know there've been efforts around that to think about that with food. And I don't know if that's been done for this particular initiative.
There was a lot of work that was done right before, about 3 to 4 years ago in Chicago. We've had a lot of work and advocacy in regulation of menthol. And one of the things that we were working on was trying to remove the sale of cigarettes from gas stations, because that is one of the few things that are across all the different communities. And there was one gas station owner after another, mom shop as they were trying to portray themselves, that was saying that we would lose 80% of our business on a day-to-day basis if we remove tobacco as one of our products. And that's kind of interesting as we think about whether their product should be gassed, right? But they're recognizing just how profitable cigarette sales are in those communities. So again, further ups, because of those profit margins for them, it would be a very, very difficult sell. And I don't think that there would be the political will to use public funds to offset that. Yeah. Well, thank you all for your attention. Good, hope you enjoyed it.
Thank you, Dr. Matthews. Our next presenter today in session 2 is Dr. Jasmine McDonald. Dr. McDonald is an assistant professor of epidemiology at Columbia University Mailman School of Public Health. Her multidisciplinary training in infectious disease, breast cancer epidemiology, and molecular epidemiology provides her with a unique perspective for understanding and examining the complexities of cancer across the life course. Today, Dr. McDonald will be presenting on personal and household level exposures. Dr. McDonald.
Well, thank you so much for the organizers for inviting me to speak, and also for the audience remaining for the afternoon session. To jump into my session, I want to first start off by grounding us in a concept that helps us understand how factors so distal from cancer can help us understand the risk for developing cancer. So I apply this framework in this discipline of life course epidemiology, and it helps us understand how the lived life throughout one's life can impact cancer. If we apply it to the context of what I specialize in, which is breast cancer, I like to consider the critical window theory. And this is the concept that the lived life of the breast undergoes periods of time of dynamic growth and development. These are times where the breast tissue is highly proliferative, and we consider this in utero, puberty, during the pregnancy period, postpartum window, as well as the transition into postmenopause. Now, breast cancer is also a very good disease to look at when it comes to environmental exposures in a life course perspective because of the sheer dynamic problem of breast cancer. We know it's not only a global problem, but it's a national problem. And we see that there are also inequities in how the disease presents. We see that in Northern America, as well as in Australia, a much higher incidence of disease, but we see in parts of the continent of Africa, much higher mortality. And while we would consider breast cancer or any cancer to be an age of older disease, we see that in the United States alone, 1 in 8 women are diagnosed with breast cancer in their lifetime. And we also see, using population-based seer registry data, that is no longer a disease that's only plaguing older women. There's been shown that there's an increase in incidence of invasive breast cancer for young women under the age of 55, especially women under the age of 40. However, this is not equitable across all race ethnicities. We see that the annual percent change, that is the amount of percent that your incidence will increase every year from 1992 to 2009 was 2.7%. That's a 2.7% increase every year from 1992 to 2009 for non-Hispanic white women. And this percentage was 3.5% for Black women. And however, when we think about this, this is not in general for all types of breast cancer, as we have seen that it is subtype specific. Recent data suggests that for non-Hispanic white women, as well as for Hispanic women that are under the age of 40, there's a rise in hormone receptor positive breast cancer. And we also see that non-Hispanic white women are seeing a rise in Herceptin enriched breast cancer. But I would be remiss if I don't note the long-standing disparities that exist when it comes to Black women. We know that breast cancer inequities in the US deal with incidence. We see that Black women develop breast cancer at younger ages, have more advanced stage disease, more aggressive tumor features, and even survivors have a higher burden of comorbidities and a poor quality of life. And when starting my career within breast cancer, I would always tout the fact that white women have a higher incidence, Black women have a higher mortality. But for the first time in history, we now see that Black women and white women have equal incidence of developing breast cancer, but Black women still have a higher mortality rate, with 40% higher compared to white women and twice as high as compared to Asian women. Why do these inequities exist? What's causing this inequity? Well, while we ponder that question, we're going to take a brief interlude into a proof of principle. I think it's important for me to prove that when we're considering environmental exposures and the lived life, that something so distal from developing cancer can have an impact. And not just your lived life, but the lived life of your ancestors. And so I'd like to take an interlude and discuss the DDT legacy. Fun times. So when we think about DDT, it was a pesticide that was banned in 1975. But this was not before the food was contaminated. This was not before children were able to create a game about chasing the fog truck. And this was also not before, for all of our social media fans know, that a dramatic picture is worth oodles of likes. But nevertheless, having these exposures take place at different periods of your lifetime impacts your breast cancer risk. So Dr. Terry and co-authors looked at the exposure of a particular pesticide, DDT, across birth periods. And what's really critical here, as highlighted in the red box, is that those women who were exposed in utero, those girls who were exposed before age 3, had a higher odds of developing breast cancer before age 50, a 5.4-fold odds, suggesting that it's not only your exposure within utero, it's the exposure of your mother, but also being exposed at this younger age creates such a distal increased risk. Such young age, such high odds. Now, when we think about the lived life, we go through several of exogenous exposures, and we can consider them as I've been talking about with the different life stages and how they're important. But there's many, many, many different nuances when we're thinking about exogenous exposures across the life that I won't have time to delve into today, but they do deserve discussion when it comes to those who are living with cancer and still being at increased risk, how low doses impact disease risk, cumulative exposures, because nobody's just using one product or using one pan, and then mixtures, because we're using different products and different household chemicals. But what I'd like to do is really stick to the idea of the lived life and a discussion of inequity. So sound data suggests that structural racism that contributes to racial and social inequities create obstacles to cancer risk reduction, especially breast cancer risk. Nancy Krieger has shown that the risk of ER-negative breast cancer subtype was 41% higher for Black women living in Jim Crow states compared to white women living in those same states. She fertilized the field to apply a historical context within the analyses of racial and ethnic inequities. So let's apply this to something that we all have experience with, which is personal and household level exposures. Now, personal household level exposures are vast. We're talking about thinking about the pans you use for cooking. We're talking about the furniture that you buy, the toys for your children. There's many, many different levels of exposure, even household cleaning chemicals. And while green chemistry has moved to be the front line of what people are trying to buy, even chemicals that are used for household cleaning that are termed green still have volatile organic compounds or semi-volatile organic compounds within them with fragrances of chemicals of concern. So we know that while we're trying to strive for this less exposed life, that there are just things that we're always constantly using and we are all using. However, not everyone uses the same type of beauty product. And we know that beauty products is a source of a multitude of different chemical exposures that are cumulative and chronic. We're talking about parabens and phthalates and flame retardants and heavy metals, and that these are coming into the form of different beauty products, from hair products to makeup, to different cosmetics, to perfumes, for feminine sprays. And we also know that these products have been associated with a host of different diseases, including cancer. Now, what I think is important to note when I say the inequities of the use of beauty products is that not all of us use the same beauty products. And the Taking Stock study actually looked at different exposure inequities. And when we're thinking about exposure inequities, it's important because we need to consider the concept of the environmental injustice of beauty. This was coined by Dr. Ami Zoda. It is a conceptual framework linking intersectional systems of oppression, sexism, and racism, and to the racialized beauty practices that lead to inequitable exposures and adverse health outcomes. If we think about it, we all may use shampoo, but we're all not going to use skin lighteners that contain heavy metals. and we're all not going to use hair relaxers that contain formaldehyde. So when they did the Taking Stock study, they looked at a diverse STEM identifying population based in California, ages 18 to 34. And what they found is that Black women reported using a higher number of hair products and more menstrual intimate products, whereas Hispanic, Latinx, and Asian women reported using more cosmetics than Black and white women. And 70% of women preferred scented products for their products over unscented. And we know that fragrance is just a code word for a mix of chemicals, usually phthalates, that have also been linked to harmful diseases. But I mean, why are these chemicals even in there? Like, how does it, like, what are they used for? Well, mainly it's to make the product more desirable, it's to make the product have a longer shelf life. I'd like to go into the idea of hair products specifically, because while we don't always use the same beauty products, we also don't always use the same type of hair products. And that's because of the texture or the curl pattern of one's hair. Now, when we think about some of these hair products that we list here, some of you may have never even heard of it, may never even use it, like pomade or edge control. But many of you might have used leave-in conditioners. Has anyone used root stimulators? And there's different products for the different types of hair that you have and the desired look. Well, racialized beauty norms suggest that the beauty standard is long, straight hair. So the chemicals that are within these products to produce certain effects are quite concerning. They're considered endocrine disruptor chemicals, where it does exactly what it says. These chemicals disrupt your natural endogenous hormone production, which can lead to hormone-related health issues. Breast cancer is a hormonal disease. They also contain carcinogenic compounds, which can impact the cellular growth and cause epigenetic modifications. And we know that uncontrolled cell growth is a hallmark for cancer. Now, we also know that based off a study done by Silent Spring Institute, Dr. Brody and Dr. Weill, who were speaking today in this session, that beauty products marketed to women of color contain some of the most toxic chemicals used by the beauty industry. I love the study because it surveyed 18 products across 6 categories of hair products that Black women use. We're talking about root stimulators, hair relaxers, and what I found most impressive is that even the product that we consider the safest to use for Black children, no lie, hair relaxers, contained chemical that has been banned by the European Union Cosmetic Directive, which has much stricter guidelines than the United States. Now, hair relaxers is very important, as many studies have researched hair relaxers as well as permanent hair dye and the relationship to cancer. The sister study, along with many other studies, have shown that any straightener use, as well as the personal use of permanent hair dye with a higher association with darker hair dye, is associated with increased breast cancer risk, and that this risk is greater for Black women. But let me kind of get you to the idea of epidemiologists are often tied into this. The exposure must cause the outcome. But in the incidents when we're thinking about hair products, I want us to realize that it's the preponderance of the evidence that suggests that hair products are associated with an increased risk of hormone-related diseases, including hormonally driven cancer. The underlying biological systems are also associated with this possibility that hair products are associated with increased risk of hormone-related diseases. What's sad is that these diseases have a higher prevalence and incidence among Black women and other marginalized populations. We see higher rates of fibroids, worse breast clinical pathological features such as larger tumor site and worse grade. We see greater breast cancer specific mortality. And recently, we're seeing that ever and frequent use of hair straighteners and relaxers or pressing products is also associated with uterine cancer, with even higher rates for endometrial cancer. And this is not a problem that's specific to women. We have also seen through the alpha tocopherol beta carotene cancer prevention, or the ATBC study, in this prospective study, that personal hair dye was associated with increased prostate cancer, another hormonal cancer. So when do we say, all right, there's enough evidence such that we need to move beyond and have action? So what I want to do is just set you up with some areas of action that's taken place in this area, and kind of set this up for the rest of the afternoon. And I will not delve deeply into any of these topics. So from my research with my colleagues that include We Act for Environmental Justice, who you saw the video of earlier, as well as my other colleagues, we looked at the idea of the postpartum window being a sensitive window of exposure that could impact not only the mother, but also the child. And so we developed an educational intervention for pregnant women of color in Northern Manhattan, with the hope that it would allow them to have agency in changing their behaviors as it relates to the products that they use. We also know that personal agency has been helped with the use of different apps where you can scan your food products, your household cleaning products, and anything else to make sure it's a safer choice. There's advocacy around leveraging and uplifting those who are most impacted, such as Black women. The beauty industry is $100 billion, where Black women spend $7.5 billion of it annually. And Breast Cancer Prevention Partners created the Black Beauty Project with the hope of creating a list of non-toxic beauty products, which they did. But what's special about this is that these are beauty products that are sold and owned by Black companies. There's been legal ramifications as recent lawsuits for ovarian and uterine cancer for those who are manufacturers of relaxers. There's policy that promotes the ability to move away from the racialized beauty standards and be able to work without discrimination in how you wear your hair. And then lastly, since 1938, this is Ella Scott Fitzgerald time, there has not been a change in the Cosmetic Regulation Act. But in 2022, the Modernization of Cosmetic Regulation Act, or MOCRA, is the most significant expansion of FDA's authority to regulate cosmetics. While it does kind of underpin individual states' ability to regulate, many reforms were made to strengthen FDA's ability. With that being said, I'd like to just emphasize that the lived life throughout one's life really does impact such distal factors such as cancer. But we also have to realize that that lived life is not lived in an equitable manner. And so we have to think about marginalized populations as it relates to these exposures. Thank you.
Thank you very much for giving such a lucid presentation. As an OBGYN, what I would like to know from you is, at a molecular level, how does these relaxants act, and for how long a period of time is it necessary, and at what age?
So how do these relaxers act? So they are endocrine, the composition of a relaxer has many different chemicals. And some of these chemicals are endocrine disruptor chemicals. And so these chemicals impact the proliferation of certain cells. They can cause epigenetic modifications that can lead to uncontrolled cell growth. They can also impair DNA such that you have uncontrolled cell growth. So that's one thing. They also have been shown to impact the movement of mammary cells. Now, when it comes to the length of time, the fact of the matter is that beauty regimens are usually consistent. So, for example, there are literal perms for young children that are utilized before the age of 10 to straighten their hair or to make their hair more manageable. If you begin using a perm relaxer, oftentimes you continue to use it because the rest of your hair looks quite abnormal if you don't use it regularly. So, and then the idea is that you will have not only a one-time exposure, but you'll have a cumulative and chronic exposure. And studies have even shown that the frequency of use is associated with worse outcomes. And also when we think about you getting your hair done in the salon or getting your hair done at home, there's been shown studies led by Dr. Adena Llanos that the tumor pathology is worse when you have dual application. If you get it done at the salon and you get it done at home. This may be due to frequency, this may be due to different levels of exposure, but the fact of the matter is that these are persistent behaviors. So we don't think of them as one time.
It was a very interesting thing. At the same time, you mentioned about endocrine disruption. What cells are we talking about in there?
So I work on breast cancer, and so studies in vitro and in vivo have shown mammary cell disruption.
No other. You also mentioned something about uterine cancer.
Yes, and so yes. And
so
so there's
fibroids, they increase in size with the estrogens.
exactly. And so in general, these chemicals are estrogenic or they can be androgenic. They work in different ways. And so there has been an association with uterine fibroids. In the sister study, it wasn't based off of cellular data. It was a population-based study using the sister study, where these are women who have a sister who has been diagnosed with breast cancer. And in this study, they were able to look at uterine cancer and a subset of endometrial cancer, and they found this association. So pretty much the premise is that it's a hormonal cancer, and are there associations with these products? Because it wasn't specifically like saying, we want to look at phthalates as it relates to uterine cancer. What they did is they said, we want to look at hair relaxer self-reported use and uterine cancer. And that's where that came from. But the premise of that came from biological studies that have shown that these individual chemicals impact biological cell patterns. So that's like phthalates and parabens and formaldehyde and all of those different chemicals that are present in hair relaxers.
Just the last question. Were they able to reproduce the same results in animal model because there may be genetic predisposition as well as the environment?
No, I don't think that this would say that they would have genetic information, but because the sister study is a higher risk cohort, because their sisters had breast cancer, they are at a higher risk. But that just reflects also what Mary Beth Terry was saying in the beginning, is that you're able to see these impacts, but there's no gene that's deterministic for breast cancer. There's no gene that's deterministic for cancer, period. So when we think about even having that higher susceptibility, if there was no exposure or environmental exposure, we wouldn't say that they were destined to get cancer.
We have a brief question from the online audience. It reads, is there any science linking EDC chemicals in hair and beauty products to early puberty in Black girls?
Yes. So we've done a study and others have too, and shown that the use of hair products and childhood is associated with an earlier age at starting your period. And that is a risk factor for breast cancer.
Only time for one more question. It's from Cheyenne.
Thank you so much. First of all, thank you so much, Dr. McDonald. That was really, really well. Like the storytelling aspect, the explaining the intersectionality is something I think a lot of people, I see a lot of people of color, myself, coming from that background, it's very deeply resonates with me. I had a question regarding something maybe a little bit far from not so much like public health, but maybe more like healthcare policy, because a lot of cases, as you mentioned, these are very heavily pronounced in places where people of color live, such as Harlem, the Bronx, Louisiana, like Baton Rouge, there's a place called Cancer Alley. So what kind of practices and policies can be implemented there to help the healthcare systems do like early detection of these types of cancers and to help people treat them, especially because these incidences are so much higher in those areas?
Yeah, it's a very tough question because I feel like it has to come from different roots. For one, the individual has to be aware, but then again, the individual shouldn't be, the onus shouldn't be put on the individual to be able to select a clean product. And so in that case, there should be a default safer option that's available across stores. If we think about Johnson & Johnson, they had to remove all of their talc-containing baby powder. But if you hear We Act, one of their workers had to go to Harlem and go to each mom and pop type store because they were still selling talc contaminated baby powder. So it's going to take grassroots, it's going to take policy, and it's going to take more awareness.
Just one more quick. Fantastic. Fantastic. As a psychologist, I want to ask you from a different perspective. However, I saw that you have many projects, referred to many projects that were included community members. What's the community response? What are women, what are families saying to this type of evidence and this type of increased awareness of environment and products as a social justice?
Yeah, so what's really incredible is that the intervention study really came from the community asking, what are we supposed to do? So once we came out with the evidence that there was a earlier age of menses from early childhood use of products, they were like, well, I don't even know what this pH word phthalate that you keep, I don't even know how to spell it. So how am I supposed to do anything about it? And so what we realize is that with greater awareness, there is the knowledge to make a decision to act. And so when we found for our postpartum group of women that there were some who made the decision to act on the behalf of their child. So they made the decision that they weren't going to use certain products. But then there were certain women who said, well, you know what? I'm not dyeing my hair that often, so maybe I can dye it less. So it was them. I feel like I'm not trying to tell people what beauty regimens to do, but providing them with the agency to be aware that they can do something else. I think that that's what's really important. And then providing them with the tools, like we had the apps, but also letting them know this is not something that you can just wake up and do. Products cost money. And so it's really about starting small. What is that product you can't live without that you must use every single day? And so giving them also the agency that it's possible and it's not an overnight solution.
Thank you, Dr. McDonald. Our next presenter is Ruth Ann Rudell, who is the Director of Research at Silent Spring Institute, where she leads exposure and toxicology research programs focusing on hormonally active chemicals and biological mechanisms by which chemicals may influence breast cancer. Her research focuses on analyses of chemicals that cause mammary tumors, alter mammary gland development, and activate biological pathways in breast cancer. Today, she will be presenting on chemicals that increase estradiol and progesterone steroidogenesis as likely breast carcinogens.
Hello, everybody. Nice to see you. And I'm definitely, as Dr. Armstrong said, part of the Mary Beth Terry fan club. So, I want to thank everyone, many of whom I have to imagine, and sitting on the other side of a computer somewhere, maybe trying to stay awake or not read their email or something. Can you hear me? All right. Yeah. So yeah, thank you for being present and caring about this. I've been studying how chemicals can cause breast cancer for over 25 years. And today I'm just going to show one example of what that evidence looks like. And I'm sharing the evidence so you can consider what a proactive cancer prevention plan, or whether a proactive cancer prevention plan should restrict exposures that likely increase risk, even if we don't have proof in humans. Currently, there's a very high evidentiary bar for government action, and health professionals may be unknowingly perpetuating this by dismissing evidence from experimental animal studies or mechanistic studies in cells. So today, I'm focusing on one mechanism by which chemicals can increase breast cancer risk. So we take the same methods that drug companies use to find drugs to prevent breast cancer, or treat breast cancer, and we apply them to identify chemicals that might cause breast cancer. For instance, aromatase inhibitors are among the most common therapies for breast cancer because they block the aromatase enzyme, lowering the production of estrogen and depriving breast cancers of the hormones that they need to grow. And we've discovered environmental chemicals that increase the production of estrogen or progesterone. So if we want to prevent cancer, these kinds of chemicals need to be thoroughly tested for safety. But this is not how things are done in our current sort of regulatory system. So the bottom line is that we do have opportunities to act on information, and there's really no reason not to do these things. So to figure out which chemicals might increase breast cancer risk, we're really joining research from two different scientific universes. The first is cancer biology and etiology, focused on the question of how breast cancer develops. What are the important pathways and mechanisms that lead to the disease? For example, aromatase enzyme produces estrogen. Estrogen induces hormonally induced cell proliferation and increases cancer risk. The second universe is the field of toxicology, especially this new international effort known as Tox21, aims to get better at predicting toxicity. Dr. Guyton talked about it a little earlier in terms of we have so many chemicals and a lot of them we don't have any information about. So Tox21 uses technologies borrowed from pharma, like high throughput molecular screening, to screen thousands of chemicals in cell-based assays to show if they activate a particular biological pathway or mechanism. And this screening can find chemicals that act on worrisome biological targets. Since many common chemicals aren't tested for safety, this information can help us prioritize chemicals that may cause health problems. Now, when we bring these two kinds of information together, boom, we can make inferences about chemicals that may affect specific diseases. And these approaches are the foundation of Tox21. So we applied this approach in a paper which was recognized by NIEHS as one of the top papers of 2021. And we identified chemicals that increase synthesis of estradiol and progesterone in a cell-based assay. And we inferred from that activity that they may increase breast cancer risk. An invited commentary from IARC associated scientists, including Dr. Guyton, explains that our approach is an example of an application of the key characteristics of carcinogens model for identifying potential carcinogens. So Dr. Guyton showed this slide earlier today. The key characteristics framework recognizes that carcinogens act by a variety of mechanisms beyond damaging DNA to cause cancer. And our study identified chemicals that fit into characteristic 8, modulates estrogen, modulates receptor-mediated effects. because the chemicals we identified increase production of estradiol or progesterone, altering the process of steroidogenesis. So steroid hormones are synthesized in the body from cholesterol. No need to memorize the pathway here, just relax. But we use data from EPA's Tox 21 related testing of 2,000 chemicals in this H295R steroidogenesis assay. And the assay basically exposes the cells to the chemicals at several doses, and then measures each of these 11 hormones in the cell culture to see if the chemical exposure causes an increase or a decrease of the hormone. And so we use this data to identify chemicals that increased estradiol or progesterone. And we focused on these two because they play an important role in most breast cancers. For example, women at high inherited risk may choose to reduce that risk by removing their ovaries, thus reducing the hormones. And many studies have demonstrated a similar dependency on these hormones in experimental animals. It's also established that estrogen and progesterone hormone replacement therapy increases breast cancer risk. That women with a gene for elevated aromatase, which results in more estradiol, have a poor survival for hormone receptor positive breast cancer. And finally, treatments for hormone receptor positive breast cancer to prevent recurrence interrupt the estrogen pathway in the breast using tamoxifen or aromatase inhibitors. Tamoxifen blocks the estrogen receptor, while aromatase inhibitors block production of estradiol. So they work in different ways. It's always helpful to see what the data actually look like. So here's an example. This is the assay data for a chemical you might have heard about called DMBA. DMBA is a PAH family chemical that happens to be especially good at causing mammary tumors in experimental animals. It's been used since the 1960s to do that, so scientists could study breast cancer. It's like how you create a model. And the estradiol concentrations in the H295R cells are increasing in the y-axis with increasing concentrations of DMBA on the x-axis. The values in red are above a significance threshold, although you can see the increase begins even at lower doses. This mechanism of increasing estradiol may explain why DMBA specifically makes tumors in the mammary gland. Now, EPA did this kind of testing for 2,000 chemicals, and we used the results to identify 300 with the strongest effects. And we mapped these chemicals out to help see which ones have the highest effect at the lowest dose. So the riskiest ones are going to be in the upper left corner, and other ones on the graph will also have important effects, especially with widespread exposures. So we plotted the list of chemicals onto this chart, which I know you can't read unless maybe you're looking on the computer. But the list includes the strongest, again, are in the upper left corner. And it includes pesticides like atrazine, diazinon, and malathion, which patients might use at home or at work, or which can contaminate drinking water. Includes industrial chemicals like xylitol, air pollution like cresol and other PAHs, and includes commercial and consumer chemicals like phthalates and benzophenone from sunscreens. Includes natural products like clove oil and DMBA. So there are many important questions, so based on this, there are many important questions that need to be answered about these chemicals. We don't know yet the biological mechanism that leads to this effect. We're curious, what's the downstream result of these changes? How much exposure is there? Where does it come from? Are the effects of multiple exposures additive? And we produced a similar risk map for chemicals that increase progesterone synthesis, and hope you'll look for it in the paper. And then so we made this list, we prioritized them by how strong they were, and then we also wanted to add information about how people are exposed. And to do this, we used EPA's new exposure forecasting database, and it provides information about if the chemicals are in pesticides, in food packaging or additives, drinking water contaminants, in consumer products, pharmaceutical formulations, or used in industry where workers and local communities can be exposed. You can look in the paper for a lot of details, but the bottom line I have for now is that many of these in the hundreds are common sources of exposure through these diverse uses. And now in drug testing, the next step after cell culture tests would be testing in experimental animals, also called in vivo testing. And using the same logic, we went to the literature to see what effects have been reported in experimental animal studies. We searched the strongest estrogen up chemicals for effects that might be related to increased estrogen synthesis. And consistent with our hypothesis that this is an important mechanism of endocrine disruption, we found strong signs of endocrine effects for many of the chemicals, including effects on mammary gland and lactation. So our search was challenging for two important reasons. One is several of these chemicals are pesticides, and the studies, the animal studies, aren't actually publicly available. They're protected often by confidential business information, and so we couldn't actually look at all the studies we wanted to look at. The second one, which you might not believe, but it's really true, it's kind of unbelievable though, is that the mammary effects are not checked very well in the studies. We found that testing protocols don't examine the mammary gland sufficiently to detect changes. Mammary gland effects are not reported consistently, and often effects that are observed are dismissed. So a key takeaway for prevention is that we need to do a much better job detecting chemicals that affect breast development, lactation, and cancer, because current approaches are really missing many effects. We just recently published a review on this by my colleague, Dr. Jennifer Kay, is the first author. And I really think this is it's a very important issue in toxicology and environmental public health and women's health. So how can we fill these knowledge gaps and use the information to prevent cancer? I think there are many ways all of us can use this list. Knowing about this biological activity provides useful evidence for existing and forthcoming chemical risk assessments. So thinking about causation, we can be more confident that breast cancers or mammary tumors that are observed in an epi study or in an animal study are associated with the exposure if we also know that the agent has a biological activity that's coherent, consistent, and with that mechanism and would be expected to lead to that kind of tumor. I think it provides some very, very important validation. And we've published concerns about some pesticide risk assessments where the EPA pesticide office dismissed mammary tumors that had been observed. And if we show that these same pesticides also increase synthesis of the hormones that increase mammary tumors, it supports a decision to reconsider those pesticide registrations. Also, as I mentioned, chemicals on this list that haven't been tested yet in experimental animal studies ought to be with careful examination for effects on the mammary gland. In addition, some manufacturers and consumers might prefer to avoid exposures, even as questions remain about health effects of people. This list provides a guide for chemicals to avoid on a precautionary basis, especially the ones that also show relevant effects in experimental animal studies. The list can also focus the design of future breast cancer epidemiologic studies by providing a rational approach for selecting exposures to study. Sometimes in epi studies, it's not, people have to pick a few things to measure exposure to, and we're when they're anyway, and so it can sometimes the limitation in the study might be that you didn't pick the most important things, or that they need to be added together, or that some important exposures are being missed. And so I think this is an important tool. And in fact, in the sister study, I think they're actually trying to do non-targeted exposure assessment, and they are using our lists to focus which chemicals they're going to look for. And then we've used this list as a basis for developing computational models that can use chemical structure to predict chemicals that are likely to increase estradiol or progesterone, even without the testing. Two more thoughts to consider. Mixtures. We are exposed to many of these chemicals at the same time. Research shows that even as singular low doses of endocrine active chemicals sometimes don't cause an observable effect, when they're mixed together, they do. And in addition, all of these chemicals are not necessarily carcinogens. Just because a chemical can make more estrogen or progesterone in this cell culture doesn't mean it definitely causes breast cancer. For example, some chemicals may not be easily absorbed in the body or are rapidly metabolized, or they don't distribute to breast tissue. Some of them actually have additional biological effects that sort of counter these effects. But despite the uncertainties, the fact that the chemicals can increase these hormones definitely raises concerns that should be the basis for evaluating the chemicals more rigorously and considering exposure reduction, especially when in vivo studies show effects. So in concluding, we found over 300 chemicals that increase production of estrogen and progesterone in vitro, and these hormones strongly influence breast cancer. In fact, they're so significant in breast cancer that reducing them is the primary focus of treatment to reduce recurrence of breast cancer. There's still important knowledge gaps. We really need improved experimental protocols for investigating how chemicals affect the breast. And we need precautions to limit widespread exposure until we know more. And I just wanted to wrap up by sharing my hope that this work helps health professionals better understand the nature of available evidence and highlights where there are opportunities to acknowledge these risks with patients and colleagues and in your communities. And I encourage you to continue to learn more about environmental health, to advocate for more coverage on this topic in medical and nursing education, and in related licensing exams and boards. And we hope you can integrate this new information into your practice. And by collecting workplace exposure information, for example, on your patients, and by seeking information resources that you think could be helpful for patients who want to take precautionary actions. I applaud all of you for being here and want to recognize the power that you have as trusted communicators. Thank you.
Oh, there is a question. Hold on.
Okay, I just read on my phone that the NIH was approving the chemical toluene 2,5 diamine sulfate, which is inherent. So I wanted to know if, this is like to me complete, like shocking news that the NIH was saying that it's okay to have that chemical in hair dye. So I was wondering what your opinion would be on that.
But I don't know, let's follow up on that. I wouldn't expect the NIH to be approving anything like a chemical in hair dye that.
I mean,
are they more dismissing concerns about it?
Yeah, I mean, if you Google it, that this is what comes up. Actually, I first read about this at home, and I figured I would wait until this conference in order to bring this to the forefront. But I was really shocked to see that the NIH was agreeing that toluene 2,5, that conjugate was okay in hair dye. Just saying, everybody could look it up like I did.
Yeah. No, that's I don't know enough about that, but chemicals in hair dyes, actually, many of the when we looked at chemical structures that tend to be associated with enriched among the chemicals that increased estradiol and progesterone. Aromatic amines are coming up a lot within that group, and a lot of dyes, a lot of aromatic amines are in dyes, or dyes often contain aromatic amines. So it's definitely a group of chemicals that I've been keeping my eye on, and I think are very important for breast cancer.
Thank you, Van. Our next presenter is Dr. Julia Brody, who is the Executive Director and Senior Scientist at Silent Spring Institute. She's a nationally recognized expert on environmental chemicals and breast cancer, as well as a leader in community-based research and public engagement in science. Her current research focuses on reporting back to people who participate in environmental health studies to inform them of their own chemical exposures. Today, she will be presenting on communicating about endocrine disrupting chemicals, cancer, and uncertain health effects. Dr. Brody.
Hi, everyone. So how and why are we going to talk about all this amazing science that we're hearing about today? I'm going to take us back for a moment to the very beginning of this session. We saw the trailer for the film Unacceptable Risk, and it's still available, by the way, at the Cancer Free Economy Network website if you want to see the whole thing, which I highly recommend. So you heard Dr. Margaret Kripke, who's a distinguished cancer scientist, a former president of the American Association for Cancer Research, tell us that when she began her year on the President's Cancer Panel studying environmental cancers, she had some significant misconceptions. She thought that all chemicals had to be tested before they could go on the market in products that we use every day. She thought that known carcinogens would be regulated. She thought that the regulations would be enforced. She thought that probably environmental cancers were just a small fraction of all cancers and not a big deal. And she is not alone in thinking those things. I did a survey of a nationally representative sample of Americans last year that found that 82% of Americans think that chemicals have to pass safety tests before they could be used in products in the US, which is not true. And moreover, 2/3 think that more than half of your cancer risk is inherited in your genes. Also not true. So to make progress on cancer prevention, we're going to have to change that story to incorporate the science that you're hearing about today. And I'm going to further play out the example of breast cancer to propose a framework for more transparent communication that clarifies what we do know as a basis for action. Of course, we expect the industry to be telling us that their chemicals and their products are safe, following the tobacco playbook for flame retardants and for other chemicals in our environment and in products. But I've become passionate about cancer communication because so often I hear dismissive statements about the environmental causes of cancer from doctors and cancer organizations. A red flag goes up for me whenever I hear statements that start out, there's no proof that XYZ, such as antiperspirants, for example, causes cancer, or there's no evidence, which often means there's no clinical trial. Of course, there's not. These statements may be well-intentioned, and of course, we all want to worry less, but the frequent framing of evidence in terms of proof can be misleading and a barrier to cancer prevention. And that's a problem because breast cancer is the most common cancer worldwide. Dr. McDonald laid out the gravity of this disease. And that's not just true for breast cancer. This applies to other types of cancers as well. Good news, though, is that the past 20 years of research about environmental chemicals in breast cancer shows an alternative way to consider the evidence to support prevention. Dr. McDonald also talked about this, about how individuals may be making decisions. You think about how you make decisions in your own life for yourself and your family. Suppose you're considering a sunscreen and you know that one of the ingredients in that product causes breast tumors in animals or makes or mimics estrogen and makes breast cancer cells grow. There's never been an experiment to prove that this ingredient causes cancer in people because we don't do experiments that intentionally expose people to harmful chemicals. So there's no proof that it causes breast cancer, but there are alternative choices like sun protective clothing or mineral-based sunscreen. There are other considerations too, not necessarily a right choice, but there is an obligation for us as health professionals to clarify the decision so that people can decide as individual shoppers or through their voice in their communities based on what scientists do know about chemical links to cancers, while also understanding the uncertainties. The Institute of Medicine report on environmental breast cancer puts it this way: it may be prudent to avoid or minimize exposure because the available evidence suggests biological plausibility for exposure to be associated with an increased risk of breast cancer, or there is suggestive evidence from epidemiology. So they're talking about plausibility and suggestive evidence, not about waiting for proof. And at the end of her year of study, Dr. Margaret Kripke was the author of this President's Cancer Panel report, which said, an environmental health paradigm for long latency diseases is needed to enable regulatory action based on compelling animal and in vitro evidence before cause and effect has been proven in humans. So why did they say that? I'm going to step back and review some of what you've heard today at a high level, reviewing what we do know about breast cancer. So we do know that most risk is not just due to inherited genes. I don't want you to think that this is contrary to what Dr. Terry said about it's not either genes or environment, it's both. But based on this study of twins in Northern Europe, in this population, about 1/3 of the risk, which is not to say 1/3 of the cancers, were due to inherited genes, including ones that we haven't identified yet. We also know, as you heard, that breast cancer is influenced at many stages of life. There are established risk factors before birth, during puberty, during a first full-term pregnancy, and at menopause. These are the times when the breast is changing and more vulnerable to external influences from chemicals. And we know that there are multiple biological pathways to breast cancer. You just heard novel research about chemicals that may stimulate the production of estrogen or progesterone. There also are established pathways to breast cancer that follow this key characteristics of carcinogens approach. For example, chemicals can alter breast development, making the breast more vulnerable to carcinogens. The pharmaceutical DES is an example of this. It was given to women in hopes it would prevent miscarriage, which it did not do. And we learned later that it increased breast cancer risk in both the moms and the daughters. This is parallel to the work you heard about for the pesticide DDT. Oops, sorry. And we know that there are chemicals that mimic hormones, including estrogen, which causes breast cancer cells to proliferate. An example of that is combination progesterone estrogen hormone replacement therapy. And we know that there are classic carcinogens that damage DNA and can start a tumor. Ionizing radiation is a well-established example of that, especially when exposure is early in life. And we do know that in the US, you don't have to test chemicals for these kinds of effects to prove that they're safe before you put them into products. And so it is not surprising that exposure to these chemicals is quite widespread. So chemicals that cause mammary gland tumors in animals are found in gasoline, in auto exhaust and air pollution, in paint removers and solvents, in some pesticides and some water disinfection byproducts. And chemicals that mimic estrogen are found in many kinds of consumer products, including cleaners, personal care products, fragrances, chemical sunscreens, and plastics. We've become familiar even with some of the names of these chemicals over the past 20 years, like bisphenols, BPA, phthalates, oxybenzone, benzophenone 3, those are UV filters, parabens and PFAS, per and polyfluoroalkyl substances, which have become very common drinking water pollutants across the US. And you've heard in more detail that not everyone is equally exposed. This is just one example of exposure to methylparaben in the National Health, in NHANES, the National Health and Nutrition Examination Survey, a representative sample of Americans showing that Black women have higher levels of parabens than others. And perhaps this is due to the composition of their hair products. So you've heard today about some extraordinarily powerful epidemiological studies showing links between chemical exposure and breast cancer. But when you think about what we do know about breast cancer, you can see how difficult it is to study so many of the chemicals that are of concern, because you would need to measure exposures decades before a diagnosis and early in life, before birth even. And these relevant exposures are complex. They're mixtures, they're not just one thing, and they often can't be self-reported. So yes, people can tell you whether they use hair relaxers, but we really don't know what's in most of the products that we use, or in our air, or in drinking water. And furthermore, many of these exposures are so widespread that there isn't a clear unexposed group for comparison, which is a typical epidemiological design. So thinking about this, as I was getting ready to testify at the President's Cancer Panel, I thought about, well, what kind of evidence should drive our research agenda? What kind of evidence do we need for action? And I propose to you that we need to find this biological evidence, such as you just heard, using in vitro and in vivo tests, looking for those pathways and key characteristics of carcinogens. And if we find chemicals that are activating those pathways, then we want to know how people are exposed. And when we have both of those pieces of information, we have a basis for action to begin to reduce exposures. That's the gist of what the Institute of Medicine report is saying. So you heard in the previous two talks examples of how to fill these two bins that are the evidence for action. And what it means is that when we talk about cancer prevention, we're talking about a continuum of actions from consumers, from institutions such as hospitals who are making major purchasing decisions, from retailers and manufacturers who are deciding what to sell, and increasingly developing their own criteria for ingredients in the products they put on the shelf. And when we have the political will, we can remove these chemicals and decrease exposures quite dramatically through regulation. Here's an example. In the household exposure study on Cape Cod, led by Ruth Ann Rudell, we found that there were higher levels of brominated flame retardants, which are thyroid disruptors, in homes on Cape Cod than there were in Europe, where these chemicals have been phased out. When we went to California to see whether Cape Cod was typical or not, we found extremely high levels of these flame retardants in California homes. And that was because of a flammability standard there that was driving the use of these chemicals in furniture foam and other types of foam. When this study was published, the state changed its flammability standard so that you can now buy couches nationwide that don't include these chemicals. And the really good news is that it turns out that these chemicals are not necessary for fire safety. So you can reduce toxic exposures without sacrificing fire safety. So we'd like to see that as a health promotion strategy that can be used across many different exposures. So as you heard that, my own experience talking about this comes from reporting back to people who've been in exposure studies. And it's not comfortable to tell people that we found chemicals in their body that we're studying because of concerns about their health effects. I don't want them to be overly anxious or worry about the wrong things. So I understand the impulse to reassure. But after hundreds of interviews with people before and after they received their chemical exposure results, I know that false reassurance is not what people want. Transparency builds trust and it enables people to act on their own values. And doctors and nurses are already well trained to share bad news, and you can incorporate this into your practice. We created Detox Me smartphone app to make it easier and hope this will be a time saver for anyone trying to talk about these issues. We wanted to share with the broader public the information that we were sharing with study participants. And you can go through tips one at a time in a sort of game like fashion and win badges, or you can quickly look for the top 10 tips or search for a topic of concern to you. We are including messages about how to become engaged at a level above your own family and your own decisions. We found in our exposure studies that leaders do emerge. In fact, in one of our studies, members of our study began coming to public hearings with their study results, and they ultimately won a court decision to limit a Chevron refinery. But not everyone has to be a leader at that level. Everyone can play a role in public policy decisions by voting, by telling family, friends, and decision makers you may be in contact with something that you learned. We do have to give up the false reassurance, though. So here's an example from the National Cancer Institute website of a statement that's true, but misleading and not helpful to energize action. It says, even if a chemical is shown in a laboratory test to cause cancer, this does not necessarily mean it will cause cancer in people exposed to that chemical in the environment. True, but the next sentence needs to say, often chemicals that cause cancer in lab tests also cause cancer in people. US EPA and FDA use this information to make decisions to keep us safe. Another example, individual chemicals are likely to cause only a small increase in risk. This may be true or false, but the next sentence in any case needs to say, still we're exposed to many chemicals every day and the risks can add up. Besides, small risks can add up to many people in the US getting sick. We actually can see this in the case of breast cancer. When the Women's Health Initiative released its results, showing that the expected benefits of hormone replacement therapy weren't really there, many women went off the drug. And you can see a dip in breast cancer incidence. The breast cancer risk associated with HRT for an individual woman is not large, but when you add it up across the population, this study publication resulted in an estimated 22,000 fewer breast cancers per year and savings of $35 billion in just the first 12 years after the study was published. So I see here an opportunity to take on other exposures that may have similar risks, but be very widespread in the population. And I appreciate the chance to engage you all in thinking about this.
Dr. Brody, we have a question from online. It reads, how would you approach a community to change behavior over choosing fragrance-free projects?
That's a tough one because people love their fragrances. But I think as people begin to understand that fragrance is a mixture of many chemicals, they're not identified for you as the consumer, and they may be estrogenic. I think people may change how they feel about those fragrances. I know when I'm like walking around my neighborhood and I smell the dryer sheets coming out of people's houses, I'm like, God, it doesn't smell good to me. Or when someone passes me on the sidewalk and I smell their fragrance from their wash. So I think we can change how we perceive fragrance chemicals to think that's not a great smell, that's chemical smell.
I did have a question. First of all, thank you so much for the wonderful presentation. It was really wonderful visuals, and I love the fact checking and like the fix that for you part of those. That's really cool. You mentioned one part of your slide about air pollution and how that can increase risks of, I think we know like lung cancer, that's very well known, but also breast cancer with respect to that. And recently, if many of us are from like New York City, we saw the recent smog that basically overtook the whole city, and it caused a lot of acute health issues like breathing difficulties. But with climate change becoming more and more severe and incidents like those becoming more and more frequent, what should we really expect with respect to other kinds of cancer becoming higher in frequency and so on? And what can we do about it?
Oh, right on. You have heard that there is a pretty substantial evidence of association between air pollutants, products of combustion, and breast cancer. And thinking this morning about, yes, when you have a cloud of smoke, you can put on your N95 mask, but we do know that the upstream cause of wildfires is climate change. And we do know that there are actions that can be taken across that whole spectrum of individuals, institutions, industry, and government to change the trajectory, and it's urgent that we do that. And I do wonder if we can make it part of the conversation that climate change is going to influence fire smoke, and that is going to influence breast cancer. That's a lot of people affected.
Thank you, Dr. Brody. In the interest of time, as I introduce our moderator for our next panel, if I could ask Laura and our 5 panelists to make their way down. Our moderator of this panel is Laura Weinberg. She is the president of the Great Neck Breast Cancer Coalition and a member of the Town of North Hempstead Ecological Commission. She has assisted in the implementation of organic pest control for the Town of North Hempstead buildings and in creating an integrated pest management system for the Great Neck Public Schools. She was a part of the implementation of the 48-hour pesticide notification in New York State counties and the New York State Green Purchasing Act. Laura also has collaborated with the Silent Spring Institute for conducting programs on breast cancer risk and the environment. Laura Weinberg.
Thank you to Dr. Mary Beth Terry and to Kimberly for asking me to do this honor. Really, really thank you. Okay, so we have 5 women, and they are going to talk about different issues that they came across regarding environmental health. And Patricia Bax, is she here? Oh, hi. Okay. I'm glad you're here. Okay, so Patricia Bax, she represents Smokers Quit Line, which provides phone counseling and information in order to become tobacco free. Sarah Evans, Dr. Sarah Evans, Assistant Professor in the Department of Environmental Medicine and Public Health at Mount Sinai Icahn School of Medicine. Great answer. Okay, Eileen Fuentes, physician affiliate group of New York, self-help care activist. As a young survivor of breast cancer, Eileen provides opportunities and resources for patients in underserved communities taking an active role. And then Micaela Martinez. Micaela, great. She's Director of Environmental Health at WEAC for Environmental Justice, currently leading WEAC's Beauty Inside Out campaign, which seeks to remove toxic chemicals from beauty products. Then Bobby, last but not least, Bobby Wilding, Clean and Healthy, regulation of consumer products, dedicated environmental advocate for over 20 years. So I have 3 questions regarding whose responsibility moving beyond individual to system solutions. And going to ask the panelists these 3 questions. And so let's start with Patricia Bax. For all panelists in respective area of work, please address the question broadly. Whose responsibility is it to address exposure to carcinogens and harmful chemicals? And please share your rationale and experience. Thank you.
Thank you, Dr. Terry and Kim and all the staff and sponsors for this fabulous conference. Before I start, I know we've been sitting for a while, so I want to do a very, very quick exercise. If you would like to raise your right arm up in the air, just give yourself a little stretch. Your left arm up in the air, stretch, and reach behind your head and give yourself a pat on the back. Pat Bax is my name, Pat Bax. All right. I thought we needed a little stretch here, a little physical activity. So, all right, this is a great question. Whose responsibility is it? I think when we think about tobacco use, and I am the marketing and outreach coordinator for the New York State Smokers Quit Line at Roswell Park Comprehensive Cancer Center, where Dr. Reed is also located. And when we think about it, we have to think about that tobacco use is not just a health issue. It's an environmental issue. We know that smoking leads to disease and disability. It's the #1 preventable cause of death. Dr. Stillman and Dr. Matthews did an excellent job laying the foundation of that information. But we also know that tobacco products impact the environment. How many times when you look around, maybe at a bus stop or you look around at a corner store, how many cigarette butts are around? You know, and just ask yourself, look at how our environment is impacted, and they're not biodegradable. What about the plastic cartridges from e-cigarettes now, from vaping products that are now going into our water, our land? You know, it's the pollutants. We know that combustible tobacco products contain 7,000 chemicals, over 70 that are carcinogenic. The product that I wanted to highlight, Dr. Guyton said, and that is acrolein. I think you had mentioned acrolein as one of those chemicals. Ammonia, carbon monoxide, formaldehyde. We had Dr. Michael Cummings, who was the director of our program, used to say there's urea in cigarettes. So he'd say there's a pea in every puff. So there are definitely pollutants in tobacco products, combustible tobacco products. So whose responsibility is it? It's every single one of our responsibility. As a nurse and a healthcare professional, It's our responsibility as healthcare professionals to educate ourselves about all the aspects of tobacco use and educate patients, parents, family members about the harmful use of tobacco, but also educate them about the free resources here in New York State. And I like to say that New York State has one of the best tobacco control programs in the country. And we have an incredible quit line, not just because I work there, but I did bring some materials during the coffee break. Please come up and help yourself. But educate yourself on what's available. The quit line is free, evidence-based. We give away free patches, gum, lozenges. We have a text program. We have a vaping text program called the Drop the Vape. This is quitting. We have information for parents, downloadable fact sheets, all types of resources, online ordering for NRT. We give away patches, gum, lozenges, and so much more. For our communities, get involved. We heard a little bit earlier about advocacy. Become an advocate in your community, and you can visit tobaccofreeny.org to get involved. For parents and educators, be sure to stay up to date with scientifically based information. And we have a newsletter. We have 2 newsletters at our quit line, and you can sign up at nysmokefree.com. Sign up to get those newsletters. For legislators, educate yourself on the deceptive tactics of big tobacco. One of the reasons the menthol law did not pass was because big tobacco, as Dr. Matthews said, was behind it. And clearly there were a lot of mistruths, and a lot had to be debunked. And how about for those who use tobacco products, combustible or e-cigarettes, vaping products? Take control of your life. Make that decision to quit. Big tobacco companies don't care about you, so take that control back and do the best thing that you can do for your health and for the health of your loved ones. You're not alone. Free help's available. Call 1-866-NY-QUITS. We're here to help. Thank you.
Well, that was beautifully said. And you had that fabulous not photograph, but artwork of what you've been working on. And I told you that I thought it should be on a billboard on the road. So I honestly do mean it because it's so powerful. It's very okay. So next we have Sarah Edmonds. She's PhD, assistant professor in the Department of Environmental Medicine and Public Health at Mount Sinai Icahn School of Medicine. And I've worked with Sarah over the years, and she's another terrific person and researcher. So take it away, Sarah.
Thank you, Laura. Can you all hear me? Is it on? Thank you so much for having me. Thank you so much to the organizers. So I am an assistant professor of environmental medicine and public health at Mount Sinai. And so I do some research related to early life exposures to endocrine-disrupting chemicals, which you've heard some about today, and child outcomes related to cognition and behavior and reproductive development. But I think what I want to speak to really on this panel today is work that I do with a coalition of pediatricians, pediatric health providers in general, scientists, as well as community members and advocates to really translate the research, much of the really complex and fascinating research that you heard about today, into action and policy to promote safer communities. And so I want to kind of flip this answer on myself to say that who's responsible? I'm responsible. I think, all of us in this room who have the privilege of acquiring the education that we have, the expertise that we have related to these really complex topics, have a responsibility to bring that research out of the scientific literature and out of our academic institutions and into the communities where it's really needed. We heard today a lot about how long all of this takes. these research studies take forever to conduct. We're not going to get to a point where we can identify the precise cause of breast cancer for everyone. But we have a lot of really good ideas about what some of those risk factors might be right now. We also heard about FDA regulatory processes, also EPA regulatory processes take many, many years for individual chemicals to be reviewed. And so we don't have time to wait for that when we see the burdens on our communities right now, not only from cancer, but other environmentally caused diseases. And so I would say that some of the ways that we are tackling this at Mount Sinai within our institution is through a few organizations that we have. And one is our Pediatric Environmental Health Specialty Unit. So we are the Region 2 PACU. This is a national network of federally funded, specially trained health providers in pediatric environmental health who counsel families and communities, but also importantly, educate health providers. We also are really fortunate in New York State, many of you may not know, we have a state DOH funded New York State Children's Environmental Health Center network. So those are 7 state funded academic medical centers across the state of New York with special training in environmental health. And so we're able to treat, recognize, prevent, and diagnose diseases of environmental origin in children. Also work with a number of community organizations to create safer, healthier environments and educate communities. And so that is that's an organization that was funded in 2017 and just received 5 more years of funding. So those are 2 areas where we work to also educate clinicians. We have an environmental health scholars program. We have one of our scholars here in the audience today, one of our new scholars at Mount Sinai. She's actually a nurse who will be training with us and doing special projects related to learning about environmental health and bringing that back to the clinic. We also have a summer program in environmental health that trains students from high school all the way through medical school and graduate education in principles of environmental health, as well as how to advocate. And so we're really invested in training. We have a prescriptions for prevention program and environmental health screening, which really puts information into the hands of clinicians that they can hand to their patients to help their patients access information about environmental exposures, which many clinicians do not receive education about that during their training. And so we try to make it easier for clinicians to counsel patients and direct them to evidence-based actions and local resources. And the last thing I want to say about responsibility is that I think it's also the responsibility of our funders as well as our institutions to support all of us as scientists and clinicians to do this work. So we need more funding around implementation science. We heard a lot today about endocrine disruptors, tobacco smoke, other things that we know are linked to cancer, but now we need more funding to get out into communities to educate and implement effective interventions. And we also need to be recognized for academic scholarship related to this work. So when we go out into the community, advocate, educate community members, that also needs to help us to further our academic careers. So that, I guess I will end with that and pass the mic.
Okay, thank you, Sarah. It's such a comprehensive speech. Thank you. Okay, next is Eileen Fuentes, physician affiliate group of New York self-health care activist. As a young survivor of breast cancer, Eileen provides opportunities and resources for patients in underserved communities taking an active role.
Thank you. It's so funny to hear another institution affiliated with my name because I was here for 21 and a half years. So it's nice to be back home. Anyway, yeah, so you know, whose responsibility? I wholeheartedly agree. In summary, I'll jump to the end of the question to say that it is the institutions that serve the communities. You know, one of the privileges that I had was to sit on the community advisory board because I literally walked here. I live in the community. And so, you know, there's a lot of things that we can do. You know, there's a lot of privilege that comes with having the ability to be able to, you know, join all these different institutions and sit on a lot of the boards that I sit on. So just to give you some background, I identify as a patient advocate. I had breast cancer almost 15 years ago. I was one of the young groups that Dr. McDonald talked about that did all the things to my hair until I got tired of it. I'm a mother of 3 daughters that has to navigate those breasts and that hair also. And so, it's really interesting because after my own diagnosis, I joined, SWOG Cancer Research. I sat on the NCI steering committee. I am a patient advocate for the Society of Integrative Oncology and the DEI committees there. I sit on the New York City Nutrition Education Network and also on the National Health Equity Collective, which is a newer organization. And so I do everything I can to amplify the voices. I identify as racially Black, ethnically Latina, and of Washington Heights from the moment I was born. So I think, I do all that I can, but most people in my community don't have the privilege of doing all this work on boards and to sit alongside the colleagues that treated you. And so, I really look to those colleagues to amplify our voices, to let us be in the room when those conversations are happening. Now in this new role that I have, I oversee H&H. I staff the public hospital system, which is the largest in the United States, and also the correctional health services at Rikers Island. And so, these are communities that can't make decisions on their own because they don't have the privilege of language. They don't have the privilege over their own bodies at Rikers Island. And so there's all these structural and institutional barriers to getting the care that they need, especially when it comes to things like cancer. And so how do we bring those communities in? Well, you bring us into the room, and I'm grateful that I'm here today. But then there's also the ability to have these institutions be more inclusive of the communities that they represent. And so that may look like indigenous practices, that may look like ancestral ways of healing, and those things all have an environmental impact and impact overall outcomes. And so when there's things that are, and I was happy to see a lot of these apps that I started quickly downloading are also in Spanish, and there's all these other languages that we don't see in these spaces. And so I think when the outside of the institution, and when I talk about Columbia, like it's immediately on this block because I grew up right on 181st. It's bringing those same practices and those modalities into these spaces. And I know it's really, really hard to even imagine that, but I used to sit in the room when people were diagnosed, and I know that it could happen. And so, I think that that's a good start.
Hey, thank you so much for your, thank you. Okay, so the next question is for Micaela Martinez. And the question is, are there successful examples of communities or regions that have implemented systemic solutions to address environmental health issues? If so, what lessons can we learn from their experiences?
Thank you. So there are lots of good examples, but I thought I would just bring up a recent win. So at the federal level in the United States, we've been trying to get the Safer Beauty Bills package passed, where we've just reintroduced it to Congress this year to tighten up the laws around fragrance disclosure, around exposures for women of color, especially salon workers, and then also trying to ban the dirty dozen from cosmetics. But it's very unlikely to win at the federal level. And there have been some states that have been doing really great work locally to essentially do these very same things. So the most recent win was in the state of Washington, and this came out of grassroots organizing from Women's Voices of the Earth, and then also Toxic Free Futures, that convinced the state of Washington to give money to their Department of Ecology to study which products were being most used by people of color in the state, and then which harmful chemicals were most present in those products. And very surprisingly, even though we hear about formaldehyde all the time in hair straighteners, it turns out that there's a lot of formaldehyde in lotions, curly hair creams, or shampoos and conditioners, nail polishes. So it's very, very ubiquitous. And using some of these data just within the last several weeks, the state of Washington has now instituted a formaldehyde ban. But I use this example to really highlight the kind of pushback that we get from the industry. So in this particular case, Procter and Gamble writes a letter to the governor of Washington saying, please don't sign this bill. We see that same kind of thing happening at both the federal level with the American Chemical Society lobbying Congress. We see this over and over again. So we do have some of these grassroots wins at the state level. Unfortunately, they're going to be less and less common now that we have federal preemptions of states being able to actually tighten up toxics control and cosmetics. So it has happened, but we still have a lot more work to go.
There's always more work to be done on this subject matter. There's no doubt about it. I myself have been doing this for 26 years. Okay. So. Okay, so now, last but not least, is Bobby Wilding, who I've known for 26 years. I've worked with her. So your question, Bobby, is how can we ensure that vulnerable populations, such as low-income communities and communities of color, are included in the development and implementation of systemic solutions for better environmental health? Thanks so much, and thanks to all the organizers of this event. It's been really, I really appreciate hearing from everybody throughout the day. So I'm Bobby Wilding. I'm the executive director of Being Healthy, and I have the privilege of working with a number of the people and organizations that are here, including Laura and we act for environmental justice in the Just Food Partnership. We also work collaboratively with the Let Food Kids Work Coalition and nationally work on making progress through a campaign for getting ready for baby. But Clean and Healthy's real focus is on building a just and healthy world where toxic chemicals are something thinkable. And I actually was thinking about answering the question number one, so I'm going to take the liberty of having the mic in my hand to do that. Because my answer is different than anything I've heard today. It's the people who make and release those toxic chemicals that are responsible for those chemicals. It's fundamental. And as I think about how we work to make change and how we collaborate with so many different organizations, designing all of them, health centers, and so many different pieces. Oftentimes where it starts is when people doing scientific research identify the problem, right? And so that's the place that we start from. And what often happens is when you're talking about a problem like a method of production that releases toxic chemicals, or releases air pollution, we're talking about a product like personal care products that have come up so often that cause health problems, including cancer. What you have often starts happening is that someone is like, hey, I can do that better. And they come up with a solution that doesn't have better, right? And so the way that we organize and the way that I really focus is I firmly believe that individuals need to be educated, but I also know that people who are most disproportionately impacted are very busy doing things like living their lives, making sure that there's food on their plates, that there's a roof over their heads, their children are cared for. And so as much as it's important to me for folks to have their voices heard, I think that asking them to become amateur toxicologists does them a disservice. I think that it's really important for us to remain focused on making the change with the people who are actually causing the problem. So once you have the problem identified and you start seeing where there are solutions, then you can start using institutions and procurement to actually start, driving those solutions forward. And then when we work in that space in New York State has a really increasingly robust set of green procurement specifications for how the state needs to purchase. It would firm incorporation of toxics and climate change principles in that process. And then you start seeing like the market starts to shift, and there are campaigns that aim at retailers and manufacturers. We've seen slides about that throughout the day.
And then public policy, right? All the way at the end of that spectrum is public policy shifting to hold accountable the companies that make these products. So when I think about how we take a systems approach, how we look for solutions that genuinely solve for what we want without all of those things that we don't feel. It's important to hear from communities here in New York. We last year, React and many others took the lead in advancing a bill that requires taking into account the cumulative impacts in a community before a new facility is sited. And we moved a significant progress on adding more public engagement at the beginning of the conversation about siting of facilities, rather than waiting until most of the decisions have been made and putting out a draft decision. And usually what ends up happening is governments end up defending those positions instead of actually listening and going back to the drawing table. I think those are key ways that we can ensure that we are protecting everyone and we're actually achieving environmental justice where everyone is not just like equally harmed, right? Because you could look at it as like we want equality, but that's not what we want. We want everyone to be healthy. And so I think that the work that's being done to identify where the most significant impact is occurring in and with Black, Indigenous, and other people of color really helps us get to a place where we center that in the choices we make and which campaigns we push collectively. And I also think that there's a real, I just want to say, I think there's a real opportunity for everyone in this room to be part of that change, right? If we're all calling on, the Senate and Assembly health committees to, for example, ban menthol cigarettes, right? That pushes back against the American Chemistry Council. That pushes back against the tobacco industry, right? That pushes back against the people who have the financial interests. And we do win over and over and over again. And I think we actually are gaining traction. Washington has a lot of victories when it comes to this. Minnesota has passed a whole slew of environmental health protections, banning PFAS and many, many products and setting forth a trajectory to get them out. I actually have a lot more faith in state-based policy and market shifts to reach the kind of transformational change that we need in the federal government right now, because we've seen them fail repeatedly. But I do think there's a real opportunity here for us to look at who's creating the problem and keep our eye on that. Thank you, Bobby. Okay, aren't these women amazing? Let's give them all a round of applause.
We have a question from online.
Okay, the fun continues. So we have a question from this young lady. And
Yeah,
take it away.
thank you. We have a question online, and for background, they cited an article regarding cytostatic pharmaceuticals as water contaminants, and more specifically, how anti-cancer drugs can influence natural water reservoirs. They go on to say as much as 90% of common cytotoxic drugs infused or injected into a patient are excreted in their original active form through the patient's sweat, vomit, urine, and feces. Part one, why are no efforts made to contain these chemicals to prevent their excretion into our environment and drinking water supplies? And part two, why are outpatient cancer patients treated with phytostatic chemotherapy and/or radiotherapy not prepared and equipped to prevent uncontrolled excretion of their toxic waste, leading exposure of their families, contamination of their homes, and contamination of our environment and drinking water supplies?
All right, who wants to answer that? Very detailed question. Who wants to take that? Come on. I do not have any direct knowledge of that in particular, but I think that one of the things that it's really important to think about is that there's a lot of stuff we allow to go down the drain. whether it's medications that we take and all sorts of different medications, right? You know, the hormones that we take, many pass through our bodies and end up having disruptive effects in waterways. And I think that that is a real challenge that goes beyond any particular example, and that's an important one. Because I was just in a talk about PFAS and the sewage sludge, and you know the fact that we want to apply sewage sludge to as a fertilizer, and if sewage sludge is not toxic, then you end up with a problem. And I think that it really speaks to the need. In the case of these kinds of medications, of course, you would have to find a way to contain it. But I think there's often in other situations when we focus on how do we contain it instead of how do we find solutions that are simpler. I think that's not, I'm not trying to say that about medications in particular, but I do think that it's much broader than that. Okay. Any other questions? Okay, voting we are. So I guess nothing much I wanted to direct this because you're actually all of you really active in the legislative side. And it's a skill, I mean, it's very intimidating when you're professor in the cancer center to make a statement. But I feel there's support to teach the community to get more involved in this way, because I think we should advocates, I think people who are really knowledgeable about subjects have a huge impact on legislators. Because you don't only represent the constituency, but you really represent knowledge. So, I don't know, you just felt inspired to do this. It's remarkable, but how do you spread that? Yeah, so at WEACT, we have quite a large membership. So I think about 950. But our members are incredibly active when it comes to voting projects. They go up to Albany on a regular basis, and they are at events with our organizers all the time, speaking to people, whether it's at the city council level, the state level, and even at the federal level. So community members, they know what's done, and oftentimes actually are very, very invested, much more invested than that in states like these people get credit for. There was the one comment earlier I wanted to push back on a little bit about, people are too busy to become amateur toxicologists. And I think you're right that people shouldn't have to be amateur toxicologists, but in my experience, many of our community members are incredibly informed and invested in their health and their well-being and that of their families, and really to spend time and effort and money working on these issues. And so, tonight we'll have our Beauty Justice Working Group. I expect to have 100 community members on Zoom being very actively engaged talking about skin nightmares. And so what I find is oftentimes community members know more than what we know and are like much more on point with things. Like, I was asked at a community group a few months ago, like, why haven't we tested eyelash bleed? Because so many women wear eyelashes from Manhattan. I'm like, okay, yeah, we should have done that. And the thing is, people know best. And so for me, it's very motivating to see that how powerful our community members are. And there are actually a lot of youth that are very active as well. Not just at WEACT, but another organization I would really like to highlight is the National Action Network. They take youth to the Capitol on a very regular basis in DC, and they're doing a lot of justice advocacy as well. And so, yeah, it's a very rich.
I also wanted to highlight a recent success in New York City that ties into exactly what you're talking about. Some of you may know that New York City 2 years ago on Earth Day passed a ban on synthetic pesticides in New York City parks and public spaces. And that legislation was initiated and probably ultimately passed into the kindergarten. And a kindergarten teacher at PS 290 in Paula Vergoven, who taught her kids about tomatoes, and they kind of wanted to know, well, how do you grow a healthy tomato, and it led to a conversation on pesticides, which brought them to their local legislator as kindergartners to ask him to pass a law to make their parks safer. And that passed 2 years ago, and we actually have several demonstration parks set up around the city now that are pesticide free and working with the Parks Department. And so I, as a research scientist, was involved in that. I went to City Hall. I stood alongside the kindergartners, but honestly, the kindergartners who are in high school now, by the time the bill passed, they're in high school. That's not how long it takes. I totally credit them, and I often have the experience in a community where the community knows some of the science even better than I do, and I'm there to lend support, but they are really.
I just want to bring up one thing. So what is your name? Yeah. Mary. When I first started doing this work, this advocacy work, I felt so much passion about it. And I brought my passion to the legislators. And believe me, at that point, they start to listen to me because they really do want to help. And it behooves them to do so because they like, I hate to say that, the reputation. But aside from that, most legislators who I've worked with were very, very, very much on board with what we were doing. And I went by myself sometimes and collectively. So they really do want to hear from you and try not to be intimidated by the things like other legislators. But, I'm not being disrespectful. I'm just saying that all of you who have not done this before, this is what your passion is. Go for it and don't be afraid to talk to others. That's my 2 cents.
And if I could say, so when you're born and raised in a community that you live in for over 40 years, this is who you went to school with, starting from kindergarten. And now my kids are going to school with their kids. And so when they were running for office or in office, it's not an introduction for me. It's somebody that I've known my entire life. And so, those discussions happen even when they're thinking of running for office. And so it's really easy for me to have a conversation with someone I've been seeing my literal entire life. And so, when it comes to those things, then now they're coming after me instead of me coming after them. Because they know the work that I've done in this community and beyond. And also, like I remember when there was an empty seat on the Community Education Council, I got the call from the Manhattan Borough President's office to get that seat. And so I didn't have to do anything. And so I think when you do the work long enough, you light fire under there, you know what? Eventually, like now your voice is more important than them. And so, and everyone benefits, including their kids, including their family members, and many of them all live in this community. And so even when I go to Fort Tryon Park, or when I'm dropping my kids off when they were in PS 187, their kids are there, their moms are up there with us fighting the school lunches, and we're all building, urban gardens together. And so it really is just an extension of your own family. And so it's really easy to have that conversation when there isn't that like fear that this person is an authority figure that won't listen to you.
I have a few logistical notes, but if we could give a big thank you to our session to the moderators and speakers. We will be taking a little coffee break and reconvene here at 3:15. I believe there are some beverages back up on the 4th floor for us. At this time, elevators are this way and there's stairs this way. Thank you.
Staying and your commitment to listening online and also in person. Just to remind those people who are in person, we will be having a reception on the 4th floor immediately following this. So if you are able to stay, we would encourage you to stay for networking, and there'll be more food and even I think a few more sweet things, and also some wine and cheese and things. So please do stay if you can. I'd like to introduce my colleague who is going to introduce all the speakers for the last session. And so my colleague Nicole Bain was a nurse for 10 years before she came to the School of Public Health to get her master's of public health degree. And she also now is the director of the director of research for our community center, which is a multi-institutional initiative here in New York City to reduce multiple chronic diseases. So Nicole Bain, thank you.
Thank you, Dr. Terry, and thank you all for being here with us for session 3, reducing community level risks, how healthcare providers can inform policymakers and contribute to institutional change. I'd like to introduce the first speaker for this session, Dr. Polly Hoppen. Dr. Hoppen is a research professor emeritus in the Department of Public Health, University of Massachusetts Lowell, and director of cancer and environment initiatives at the Lowell Center for Sustainable Production. Her work focuses on the environmental, occupational, and social contributors to chronic diseases, with a particular focus on asthma and cancer. She has served as principal investigator, lead author, and facilitator in a range of disease prevention projects, with a current focus on developing collaborative networks to advance understanding of environmental contributors to disease and to catalyze systems change. And she'll be presenting today a systems approach for integrating environmental chemicals in cancer prevention. Dr. Hoppen?
Thank you all, both online and here, for your attention. Another shout out to Mary Beth. The brownies are really outstanding upstairs. I'm so glad to be here. I'm actually coming home. I realized when I saw the address for the center that it's at 104 Haven Avenue, and I was born and raised for my first year at 92 Haven Avenue, which I think is in the space where you can now see sky. And you used to see quite a dilapidated building, which required a 5th floor walk up for my parents, ages 25 and 22. But my dad was a medical student at PNS when I was in my first year here at New York. So it's great to be back. I want to spend some time picking up on a lot of themes that you've already heard. It's just been a wonderful conversation so far. And the word systems has been mentioned often in terms of the larger context in which we all make our daily choices as human beings living our lives and also as professionals. So my job right now is to take a bit of a step back from all that we've heard and talk about systems thinking as an approach and as a tool for thinking about how to prioritize actions and engage, depending on sort of where we sit within the system. I'm going to describe an initiative that is now about a decade old. It's grounded in systems thinking, and a wide range of organizations participate in it, from companies that are manufacturing safer alternatives, from a group called Beyond Benign, which is looking to green chemistry education in elementary schools, to fence line communities that are most directly impacted from whom you've heard today, to cancer organizations, just an enormous array of organizations that have come together toward a common goal. And we generated this about a year into the project. Here's the goal. Within a generation, we want to reduce the burden of cancer and other diseases by driving a dramatic and equitable transition away from toxic chemicals in our lives, our communities, and our economy to safe and healthy alternatives for all. So there was a lot that went into that, as you can imagine, and it's for another day to tell you the stories about that. But I do want to emphasize the word equitable in that statement. It needs to be an equitable transition from the perspective of the people that are impacted by the toxics, as well as the people who are doing the jobs that may be lost as we move to safer and healthy activities, healthier activities. So I'm going to spend just a moment geeking out on systems thinking and then begin to talk about the insights from this experience that might be especially relevant to people in this room. But first, just a moment on the Lowell Center for Sustainable Production at the University of Massachusetts Lowell. We're comprised of health scientists who are public health researchers and practitioners with a lot of depth on environmental health and occupational health. We have a sister organization, the Toxics Use Reduction Institute. And those faculty and staff are predominantly chemical engineers and policy people. And so we have the health scientists understanding what's going on in terms of impacts of these things, and then people working on solutions. The premise of the Lowell Center is that our systems of production and consumption are not only the root causes of our environmental and health problems, but also significant contributors to solutions. So this framework that you see here will look familiar to those of you that are public health trained. We've adapted the public health framework to add another element that you see right under there, and that is strategic engagement for systems change. And we see that as the bridge between systems thinking, which I'm going to talk about for a bit, and then to action. So it's taking an approach to understanding complex problems and moving it into implementation of interventions that have the potential to address those complex problems. So as been said many times today, and we all understand that public health recognizes that people's health is determined not just by their own biology, but also by the larger ecosystem in which they live. And this strategic engagement for systems change is our approach for understanding and then galvanizing effective action on that ecosystem. So we had an amazing presentation from Dr. Matthews earlier about one piece of the cancer and tobacco battles over the years. But just to lift it up here, if you haven't encountered the term systems thinking before, you've certainly encountered the concept of it. And tobacco is a great example. You know, there have been public health crises that have been solved by simple 1 or 2 actions, like the notorious John Snow removing the handle of the pump to curtail that cholera epidemic. But most of our big wins in public health, the great strides that we've made have been a result of multiple actions in a whole range of arenas. And the issue of the success with tobacco control and the resulting declines in cancer rates, we understand from this morning that there's complexities there, but no doubt it's been a huge success. But it took decades after the science was very clear. So the science being clear was not sufficient. The communicators of the science were doing a good job. That was not sufficient. It took changes in public policy, changes in research, clinical practice, public health, cultural realms, just an array of actions that took place before finally there was a groundswell and we started to see some real change. So one question that we ask in systems thinking is, if you, rather than just understanding what took place, what if we proactively had a group of really diverse organizations, all those that I've mentioned, looking at this problem when it began to emerge in the science and being intentional about where, if we understood the system, we could put some pressure in a few key high leverage areas and really have the potential to catalyze change in that system. Might we have succeeded in actually reducing tobacco use more substantially earlier and saving thousands of lives? Systems thinking is especially helpful when we're dealing with wicked problems. And I think you have an intuitive sense of what wicked problems are. These are those that are complex and they're interconnected and they often seem unsolvable. And I won't go into the details about what makes something a wicked problem, but I think you can come up with some ideas. Dr. Matthews mentioned gun violence, education, healthcare, cancer, environmental challenges. These are all wicked problems because there are so many interconnected forces that contribute to them and therefore need to be understood and intervened on. There's a concept here of rebound effects. So here's an example. You're trying to address the climate crisis. You develop more fuel efficient cars and pass public policy to incentivize that. Well, then people are driving their more fuel efficient car and they think, oh, well, it's cheaper and I'll just drive more miles. So there are ways in which something will come back and sometimes even undermine the success that has been established. Other concepts of the phenomenon of a system or strong economic interest in a system actually depending on the problem persisting. And we see that in cancer issues as well as obesity and other chronic diseases. So I've mentioned some of the characteristics of system thinking already. We want to understand how all these parts fit together, how a whole system has interrelated components and creates patterns. But it's really an approach to thinking, but then again, it's very important to move that thinking into action. So it's a tool, and I'm going to spend a little bit of time on the tool aspects of systems thinking and invite you to think about how you might apply this tool to what you're working on. So the first step here in systems thinking and action is to define and diagnose the system. Systems can be huge. We decided early on in this network project that I'm describing that we would limit it to this nation, even though the global chemical industry is a reality. They are influenced by regulation in Europe, but we needed to bound it according to the resources that we had and the people that were able to be around the table. The first step in defining and diagnosing the system was to just start with a gestalt of what we knew. And we all knew, and this was beginning with a group of about 50 people in multiple meetings over the course of an initial year. We knew when we started that the system we wanted to study is stuck, producing massive amounts of toxic chemicals, as we've heard, that contribute to cancer and other diseases. And then the same system is stuck taking care of people who become ill because of those contributors to their disease. In that system, there are also real glimmers of hope, and we'll talk about some of those in a minute. And they are glimmers, however, and so the challenge of this system is to get it unstuck so that it stops doing the things that are going in the wrong direction and it starts elevating those glimmers of hope to go in the right direction. But beyond having a gestalt about what this system is, the systems thinking process asks questions like these. What are the organizations and sectors that are active in the system, and what is their relative power? What is going right in the system? What's going wrong with regard to reducing environmental chemicals that cause disease? What are promising levers or opportunities for interventions in the system that, if they were carried out simultaneously, again, by many different stakeholders and actors across the system, might shift those system dynamics so that it better advances health and well-being? And which constituencies, institutions, individuals could collaborate to most effectively catalyze change? Should they all be around the same table? Should they be our network connected informally with another network that's working with another bunch of stakeholders? Lots of practical ramifications of these big questions. So we worked with systems analysis consultants over the course of a year, and there were key informant interviews and there were multiple convenings. We listened to people's stories, we had discussions and exercises, and a couple of things came out of this phase of diagnosing the system that I wanted to just lift up for you. We decided to categorize environmental exposures that the system is producing in three ways, three buckets. One is legacy exposures, like those at Camp Lejeune in North Carolina, where there have been many cases of cancer that have resulted from exposure to solvents on that naval base. Places like Cape Fear in North Carolina, places like Love Canal many years ago, Woburn. And then there are ongoing exposures, like air pollution has been mentioned a couple of times today and will be discussed a little bit later in this same session. In St. John the Baptist Parish, which you see here, of the top census tracts, the top 10 census tracts for cancer risk from air pollution in the country, 6 of those census tracts are located in St. John the Baptist Parish in Louisiana. So there are places where the assaults on people's bodies and their health are extraordinary and disproportionate and unfair. PFAS is an example of ongoing exposures. And then there are future exposures, and some of those are exposures that are ongoing in some places, but they're just being brought to a new place. So an ethane cracker in Beaver County, Pennsylvania, which is coming online to be able to turn natural gas into feedstocks for chemicals. That is a new exposure to it for a technology that has been ongoing. But then there are also some materials that are being developed to try to solve other problems, like the climate crisis, new kinds of batteries or ultralight materials, because we want to reduce fuel use. Those themselves can have high toxicity problems. So figuring out how to anticipate those. But this is the category of exposures that could be prevented to begin with and avoid a familiar scenario of regrettable substitutions. You remember when BPA was finally banned as the lining in cans, it turned out that the alternative was also problematic. So needing to figure out a way to do some preventive work at the design stage of materials and products. And as I mentioned earlier, there are organizations and initiatives that are looking to how to design molecules and materials to be non-toxic and then incentivize the protection of human health as a primary priority in the materials and the technologies that we design. So over the course of that year, we came to understand that the system we're working to change does go way beyond the traditional bounds of public health, even taking into account the social determinants of health perspective. It includes the companies that produce and use toxic chemicals to make furniture and airplanes and food, and the government that regulates the companies, as well as the public health infrastructure, the advocacy groups, the cancer charities, the cancer prevention entities. One of the things that we did in a diagnosing stage of the system is to look at key trends, and some of these have been elevated already here. But the value of looking at trends is to consider which ones, they're not inevitable. We need to understand them to consider whether or not we can turn them around. You can see some highlights of the trends. This is not all of them that emerged in the course of this. But one that I did want to elevate that I don't think has been mentioned here today is, in addition to increasing rates of non-smoking related cancers, which we've heard a lot about today, being associated with environmental exposures, there's also very steep increase in childhood cancer incidence, although we're getting better at treating it. And then there's emerging evidence on the impact of environmental carcinogens on people who've already been treated with cancer. And I think that's a really important bridge for all of us in the healthcare world. So an oncologist within his or her day job now really needs to pay attention to environmental exposures because it impacts morbidity and prognosis for patients. So one of the really fascinating aspects of systems analysis and thinking, I think, is feedback loops. And these are the things that keep a system just churning away in the way that it does, even if you looked at it objectively and said, well, why is it doing that? That doesn't make sense. That's not what we collectively want. But these feedback loops perpetuate those kinds of behaviors within the system. And so if you understand what those feedback loops that are keeping a system stuck, and on the other hand, what are those feedback loops that are going in the right direction, but they're just not amplified or potent enough yet to kind of catalyze the system's change, this can be really powerful. So we're starting here on the upper left of the slide. U.S. chemicals policy, as has been mentioned, and if you listen to that great Margaret Kripke video, it's only 15 minutes. She'll talk more about this. But U.S. chemicals policy does not require the testing of chemicals before marketing them, in contrast, as someone else mentioned, to Europe. And that lack of testing requirement means that there is minimal investment in testing and research on health impacts relative to other things that are studied. So moving over toward the right-hand side of the slide, this allows industry to claim that there's a lack of evidence about harm of toxic chemicals, and that bolsters their case for opposing regulation. There's little evidence of harm, so why get in the way of technology, progress, of jobs? You know that familiar narrative. Now, here's where we all come in. Scientific norms here on the right-hand side teach us all to be skeptical. They teach us to look for certainty in conclusions about risk. And we're reluctant to say something is proven. That's just sort of in the DNA of scientists. We're reluctant often to make recommendations for action based on science, because at least historically, there's been a real firewall where people have felt nervous about walking across that bridge between science and policy. That's beginning to change and obviously needs to be done responsibly. And then clinicians often share those same tendencies, partly because they're scientifically trained, but also because it's a very real dilemma that when you're in your office with a family and that child's got leukemia, it would be, first of all, scientifically inaccurate to declare that that child's leukemia was caused by their exposure to air pollution. And it also wouldn't be the right thing for the family, probably. So if you suggest that a patient's leukemia might have been caused by air pollution, there's the possibility of the parent feeling like they're to blame, just all sorts of things that for the clinicians that we've spoken to doesn't seem usually like a good idea. But that same clinician might live in a community and know scientifically that some of the childhood leukemias in that community are caused by the air pollution there. So how does a clinician hold both of those realities and also both of those roles? Because they are clinicians in clinical practice and they're also community members. And they may be asked to speak at a school board meeting when you're talking about, proximity to a cell phone tower. Or there may be a bunch of other opportunities where we can talk about this more on the panel, where clinicians are trusted messengers in certain contexts and could lift their voices up, but they need to find language that works both in the clinical setting and in these other settings. So continuing around our little feedback loop here, This results in trusted messengers, especially for legislators. The clinicians are very trusted in the realms of policymaking, at least. And these things are changing rapidly in our current political climate, but overall, we have an outsized voice. And if they then are aligned with an industry narrative that environmental chemicals are a small problem, that we really don't have to prove, then no wonder the public throws its hands up in despair and says, well, I guess cancer is just bad luck after all, and we're just going to accept these health risks as inevitable. So then the public doesn't organize to put enough pressure on elected officials, regulation remains weak, starts the feedback loop all over again. So you just see how that works. And there have been so many great examples today of pushbacks against that. And there is tremendous work going on that does not align fully with this, but as a large society-wide phenomenon, this is what it looks like. But again, understanding a problem creates an opportunity. So every single place around that feedback loop, wherever you're located, there's an opportunity to disrupt it. So those of you who are clinicians and all of us as health scientists, we can change our language about environmental chemicals. I think Dr. Brody had some great ideas about how that might be done to convey what we do know, to convey the seriousness of the concern, the opportunities for prevention without being inaccurate or compromising, the scientific standards that we have. And the words that we use can help the public and people directly impacted begin to see their own power in engaging in solutions and calling on elected officials. And I think the points that various people on the most recent panel made about community voices is also really important. Those are, that is lived experience that is absolutely valuable and also will be heard loudly by people. So these narrative changes can translate to community folks as well. So I'm not going to talk about this feedback loop just because of time, but it's a positive one. It's driving progress in the right direction. It talks about evidence of solutions, then generating additional demand for those solutions, those more sustainable approaches, which then leads to production. And that all goes well, but it's small right now in the context of the larger system. So this is only half the slide I hoped it would be. Let me see if there's something else. Oh, yes, there is. Look at that. This is just a little example of one of the many meetings that took place in the course of doing these systems thinking and analysis. In the course of it, in addition to learning stuff through the analysis, we were also building relationships, again, with a wide range of organizations and sectors. And so we were beginning to lay the foundation through that process for ongoing work together to apply the insights and to learn and iterate in our effort to catalyze change. So we identified, you'll see all those sticky notes on the right-hand side. That's people going up to the systems map, which was emerging out of the analysis, and putting themselves and their organizations onto that map. So we began to understand, where did we have around the table power in that system? What was missing? And how might we gather some engagement by people in those areas of the map that were not as well populated? We looked at who had power in different arenas, who were decision makers. We looked at our influencers and our targets, all that sort of campaign strategy that some of you are steeped in every day. And we looked at who we needed to work toward engaging over time, but also who we might not want to engage. And that is a really important aspect of this work as well. The goal that I read in the beginning for the Cancer-Free Economy Network began to be developed actually at this phase, about a year in. And developing goals and objectives is really important because it defines success. It's where you're headed collectively. It also allows people to be brought in who weren't part of the process before, because they can see where are the common interests and do they belong. So here is what really emerged that I think is maybe relevant for thinking about your roles in this going forward. This color coding essentially shows 4 high-level leverage points. You see, shift the market there on the left, change the story to the right, strengthen capacities and build influence on the lower right, and expand a prevention agenda. So those are the high-level levers that this analysis suggested. If we were to put a lot of energy into each of those 4 areas, we really could have the potential to catalyze major change in the system. But there's lots that we can't directly impact about what goes on with those in those 4 arenas. And so we began sort of backing off from that. And the concept here is that if you start at the green level, those are very concrete projects that we can directly design and impact. And we have confidence based on the systems mapping process that those in turn will influence the orange tier of activity and change. And then those in turn will influence the gray. So it's a imperfect, but a systematic approach to thinking about what the projects are that we work on and how they contribute to these larger high-level shifts or the levers that we want to be able to pull to catalyze systems change. So now I'm just going to spend a minute on each of these and give you a flavor for some of the activities that are going on to both each of these 4 levers, and especially how they relate to clinicians, public health folks, researchers, and communities to help begin to put some ideas on the table for how you might engage. So the first one, shift the market. A great example of this is the network that some of you may be aware of called Healthcare Without Harm, which is now well over a decade old, and it started to leverage hospitals that were and still are major contributors to the use and disposal of medical waste, hazardous chemicals. And they're also major purchasers. And so they have the potential to really influence the market with their purchasing decisions. So over at least a decade, Healthcare Without Harm has worked with hospital systems around the country. And one of the initial activities was focused on the use and disposal of plastics. And at one point, the count was that 4,000 medical waste incinerators had been closed because of the shifts in the waste stream that Healthcare Without Harm had been able to achieve. There's lots of other things that they're involved in. Kaiser Permanente is a very active member of them, and they're driving demand for food that is organically produced without carcinogens by shifting their patient meals to local and organic sourcing. And again, because they're a big purchaser, that really does drive market shift, at least at a local level. They're now also working with architects on design and hospital buildings. So a big leverage opportunity there for healthcare systems and how they purchase. The second one is change the story, and Dr. Brody did a beautiful job of describing the subtle differences in language. This is a series of bullets that I think will feel familiar, and some of them are sort of true. We are certainly making a lot of progress in treating some cancers. My husband would not be alive today if he hadn't, and so we all have enormous gratitude and investment in those treatment-focused areas of research and wouldn't want them to stop. And at the same time, when we talk about making a lot of progress in treating cancer, in the case of children, for example, the other half of the story of the steep increase in incidence rates is often not told. So we are thrilled, of course, that many more children survive cancer than used to. And it can't be the ultimate solution that more and more people get cancer and we just do a better job of treating them. So other elements of this current dominant narrative, it is possible to prevent some cancers by avoiding unhealthy behavior. That's absolutely right. And yet public health in some ways, I think, has been co-opted into focusing so much on individual behavior change that we lose track. And I think Bobby Wilding brought us back to that earlier with her comment. We lose track of the outside forces that are making concrete decisions that make it difficult for people to exercise good behavior choices. And you see the other elements here. So it's not necessarily that each one of these is wrong, it's that the overall impression of this narrative contributes to the notion that we just need to keep taking care of the people we love, who have cancer, and investing in treatment. And it really de-emphasizes the opportunity of prevention, particularly our health. So how might we change that narrative? Well, here's some ideas, and I'm not going to go into them, but we would love to have your feedback on what a different narrative can look like. And, it's something about what we know about hazardous chemicals. It's about the gene and environment comments that have been made earlier. It's about holding the fact that we really rarely know what caused an individual's cancer, but we do know that in the community, there have been lots of cancers caused by these things. And the others that are familiar from comments earlier today. That's changed the story. The third one is strengthening capacities and building influence. And this is really about connecting organizations and also sectors that are potential allies for this larger effort, some of them would be unusual suspects. So interestingly, most cancer-focused organizations do not address environmental chemicals as part of their agenda. So a very strong focus of Cancer Free Economy Network and also an allied network called the Cancer Environment Network in Southwestern Pennsylvania that I and colleagues have been very involved in helping to launch. There's a very targeted effort to engage with organizations like the Bladder Cancer Advocacy Network. We've now done fact sheets with them, webinars, engaging their members and understanding aspects of bladder cancer that are heavily influenced by environment. There's community level trainings. We've got curricula. People are interested in co-creating and adapting some of that to particular communities and helping to co-deliver that with community members. Another approach is to look really hard at particular chemicals and pollutants that are problematic in particular places that are going to be motivating people as a way to bring in small businesses, other kinds of allies who would think of as prioritizing a focus on cancer necessarily. And finally, expand the prevention agenda. And what this really means is taking cancer prevention as a field and saying, how do we integrate environmental chemicals as an important component of cancer prevention where it hasn't been before? And here again, a number of particular ideas. And there's a strong research component of this. There's a research translation component for communities and decision makers. It taps back into the change the story narrative. A lot of these things intersect with one another. Clinical practitioners and cancer support organizations, again, as I mentioned, healthcare institutions, and then cancer prevention policy. You know, we've talked a lot about policies related to pesticides, which is fabulous. It's a great one to work on at a local level in a city context, as Sarah was saying. Artificial turf, a lot of really good environmentally focused policy initiatives. But there's also the world of cancer prevention policy, which shows up, for example, in state cancer plans. And I know Mary Beth Terry's been leading an effort here in New York to have that plan really elevate what we do know about environmental chemicals and propose some concrete recommendations about how to address that problem here in the state. Cancer Free Economy Network is also working in Iowa, in California, and in Pennsylvania with cancer coalitions who are the constituents for those state cancer plans to be able to bring these issues to them as well. And then from the other direction, we've worked with the Centers for Disease Control and Prevention on a series of webinars targeted at state cancer prevention and control officials to educate them about environmental chemicals and how they could take action given their focuses and resources. And right now are developing a toolkit, which is going to be for state cancer programs to have resources, ideas, and tools about how they can integrate environmental chemicals into it. So just the last thing to say is about Cancer Moonshot. We've all been hearing about it since my current president was vice president, I imagine. And although progress is slow, it's very measurable. Julie and I and others were at a Boston regional meeting of the Cancer Moonshot back in the Obama administration. And there was nothing said about environmental chemicals. And the host was named Herbert Cancer Institute. Well, as has been referenced, last year, they hosted 3 two-hour sessions in a cancer environment forum that was just fabulous, as this one is. So real shift in public presence on these issues by a major cancer institution. And this, and also advocacy by people directly impacted and by cancer organizations, has led to the current version of the Moonshot, actually including here, you'll see the second bullet, under cancer prevention, a recognition that we can address environmental exposure to cancer. And that's really exciting progress. There's a lot of work that needs to be done to ensure that those are not just words. I've bolded elsewhere that the 3 other places where it seems to me that environmental issues show up in the Moonshot: addressing inequities, and then speeding progress in deadly rare cancers, including childhood cancers, as I mentioned this morning, the glioblastoma cases that all came together around a particular workplace exposure. So your voices in this conversation would be welcome. So last conclusions, evidence is sufficient for many environmental contaminants to act now. I think Dr. Guyton and others have made a very strong case for the science. And as others have said, if we push towards alternatives, we can let go of the need for 100% proof on all of these contaminants. So it's important to know too, that there's a lot of intersection between carcinogen list and asthmagen list, for example. So we're all not concerned just about cancer, and taking action on any of these will have other positive ripple effects. There's a need for a dramatic shift to safer technologies. Reducing environmental carcinogens and scaling safer materials should be integral. That's what I mentioned a minute ago in cancer prevention research, people practice cancer prevention policy. It's been very siloed since the establishment of the EPA, which was necessary, but all of those statutes that are regulated or implemented by environmental agencies has sort of let the health sector off the hook to some extent with the legal together. And systems thinking and collaborative action, how lives change, and everyone in this room, physical and virtual, have important roles. Thank you. Dr. Thompson, if anyone has questions, Dr. Thompson will be on the panel following. Feel free to ask them then. Our next speaker is Dr. Anna Navas-Safian. She'll be presenting new evidence on medical. Dr. Navas-Safian is professor and vice chair of research in the Department of Environmental Health Sciences at Columbia Mellon School of Public Health, and she is a physician epidemiologist. Her research investigates the health effects of environmental exposures, molecular pathways, and gene environment interactions, and effective interventions for reducing involuntary exposure and their health effects. This year, President Biden appointed Dr. Navas-Safian to the National Cancer Advisory Board, and her research goals are to contribute to the reduction of environmental health inequality in underserved and disproportionately exposed populations. Thank you so much. And sorry. That's the choice. Okay. Come in. So when the slides come, first we say this is an incredible day and effort, including all of the importance of environmental exposure to cancer. This is really inspiring, and I want to thank Terry, all the previous presenters. The presentation from Polly Hoppin was really great because she talked so much about systemic thinking, which is very important when you apply that to very specific issues. And I am going to be talking myself a little bit. I am going to go into some more specific problems, how they affect communities, what can we do, how can we address those problems, and how they provide really important opportunities for prevention and intervention. Full of energy. It's great to see many faces also of people that I met many years ago, many of you and people who that we've been working together. And some people that I am excited to meet, like Phoenix and Matthew, that we work together on a project, and lots of other people and many different faces. I don't see this thing. Yes. Can you hear me? A little closer, so I need to come closer. Perfect. Okay. Okay. So I don't see the slides in the screen myself now, but that might be fine. The only thing I don't know how to advance.
I am not the first presenter for sure of the day. Okay, what is it? So I don't see them here, but that's the one. Wonderful. So I am going to bring you some specific environmental and how we can. Yes, okay. Very good. So you've been discussing a lot about environmental and environmental council, and I wanted to bring this study from the importance of disease from WHO, because according to WHO, with the evidence that we have today, we could prevent 20% of cancer. So we eliminate all environmental exposures, not thinking of lifestyles or anything else, but the environmental exposure. It's a little bit an issue because I don't see my slide. But so we can, and if you think of the exposures that are listed there, air pollution, chemicals, radiation, and workers' protection. That's what listed according to the WHO. And if you look at the top 10 chemicals of concern, also highlighted from the WHO, most of them are established carcinogen or have some evidence for carcinogenesis. I want to share you so that, oh, yeah, that would be a little different. Okay, can you hear me now? Yes, wonderful, very good. So I wanted to share a little bit about the work I've done and my experience. This is the first paper I ever published at the time. It's a big years. It was a lot of hard work and thinking. And very effortless to leverage some amazing registries from Sweden to put together a long list of occupational exposure of chemicals to the occupational setting and related to brain cancer. And in that paper actually was extremely influential in my career. First, I learned that I really used to do exposure assessment really well. And that these powerful databases were not able to capture that, although we could see really important signals that probably were very relevant. And I don't really have the full list. I also kind of started to become very intrigued with mathematics. And all these signals that for me were totally kind of novel and fascinating at the time. And if you look at the periodic table, many of the elements in the periodic table have an organic compound. So we could really learn quite a bit about human health if we understood what these elements are actually doing, both essential and non-essential metals in our body. These are really important exposures because not only they affect specific populations like workers or hazardous sites or even smoking that contains very high levels of metals, but they could also affect these chronic low-level exposures that we've been talking about quite a bit today. To the air that we breathe, the water that the air that we breathe, the water that we drink, and the food that we eat. These are very daily basis exposure. And if you go to the issue of arsenic that I'm going to be talking more specifically, this is really a huge nationwide problem with many communities affected, both because of private wells and community water systems. And when you look at this map, I like to think of the families that are the people who are actually drinking this water every day. And it's a daily dose of an environmental toxic. Instead of taking a daily dose of something productive, you are taking a daily dose of something that is carcinogenic and highly toxic. And arsenic was actually the first carcinogen ever identified in humans. But when I mentioned that doing high quality exposure assessment is really important. And in the field of metabolomics, we are very fortunate that we actually have tools and technology that allows us to quantify those exposures really well. But even if you have the technology capacity, if you don't apply that technology to the populations that are the most affected, all of these key methods are not actually very helpful. So combining powerful technology with really high quality population-based research that can use and generate that knowledge for interventions is really critical. So this is a classical epidemiological cohort, and we are really confident in this case with the metal biomarkers, they can really integrate multiple exposure routes and sources and help us connect these exposures with disease. One population-based study that I've been very privileged to work with is the Herbert study. These are indigenous communities across the Great Plains in the Southwest in the US. And to do high quality cancer research and for us to be able to inform the WHO about the estimates and really to make sure that 20% is not a real underestimation, we really need to bring this perspective cohorts across very diverse populations and large studies so that we can measure those environmental chemicals and other environmental exposures really well. But this work is not possible without very strong community engagement. This is true here in New York City with the communities around. This is true when we work with communities that are quite remote, like in the Northern Plains, where the communities are very rural and far from each other. Unless we work and have strong partnerships with people who are local, people who are trusted, people who know what the issues are, this field is not going, and people who can actually act upon with the information that is obtained, it's not going to be really possible for us to really have meaningful change. So cancer research in indigenous communities is very limited, and there are lots of problems with the data. In the Herbert study, we are able to get this small cohort, so there are lots of limitations, but you can see from this data, the burden of cancer is really high. This is a real issue, a real problem. And because we are very interested in environmental chemicals and arsenic exposure is a key problem in the communities, we were able to look at how arsenic was associated with some of these cancers. And we found lung cancer, prostate cancer, pancreatic cancer. This is very important evidence that actually the EPA is now utilizing for their ongoing risk assessment. One of the issues with this with the study, and you can here look at the dose response, is that cancer was not originally part of the original cohort. And in the IRB, in the consent form, it was not included specifically. And the communities thought this was a study of cardiovascular disease. So that brought lots of complications, and reconsenting was needed, and additional efforts and communication was needed. And of course, the communities care about cancer, but this is a real important issue. And it was very, very important to do. I am bringing also another example of another chemical, which is cadmium. And cadmium is very important in tobacco. If you smoke, you have huge levels of cadmium in your body, and it's a chemical that you cannot eliminate. It's going to stay with you even if you stop smoking. It's going to stay in your body for decades. And very clear in the Herbert study, very clear associations between cadmium in urine, which has a very long half-life, with different types of cancer. And if you look at stratified analysis for different subgroups, if you look at the, even in the people who never smoke, you can see that there is an increased risk, even with the zero back years. And this is a small study, but this is providing important evidence that cadmium is carcinogen, as we all know from So you couldn't hear me. Now it's better. Very good. Better late than never. And so moving into action and solutions is really critical. And I am a public health preventive medicine physician. So for me, prevention is really the key, but it might not be the only strategy. And how do we move from these big problems to solutions for small specific communities? And this is always a real something that we really need to think very carefully. So in the communities in the Stockholm study where they had this arsenic in the drinking water, we had to develop this community level, participatory base, engaging tribes, do informative research, a huge effort. And when we started this work, people told me, don't do that. You are never going to be promoted. This is a waste of time. It's very difficult research. You are not going to be funded. Those were all the messages. But you cannot do this work and just say, that's it. Now I move to something else, to another exposure, to another study, to another. It was not possible. So because of the community engagement and the connection and the feeling that you could not leave that behind, we really persisted together. And we were able to do this work, which was great because actually worked, and we've been able to reduce exposure quite a bit. But it also identified that these problems are not simple, and there are many other issues going on. And of course, there are many other chemicals and not only one chemical. So because of that complexity, we were able to develop a systems approach effort, bringing together multiple disciplines to think from many different levels of perspective to try to address this issue, leveraging the opportunity that the Superfund research program provides. And in that effort, we only incorporated not only innovative technology, but also indigenous knowledge and local knowledge, traditional knowledge. And this was, again, really, really important if we want to solve these environmental problems, to bring in that local understanding of the issues and how to solve them. But prevention might not be enough. And one of the realizations for me is that engaging clinicians is particularly difficult for environmental issues. There is this idea that this is a public health policy solution, and that clinicians, maybe they don't have to do so much, except, provide some advocacy or support. But so how to engage clinicians in these environmental issues, it's important. And maybe we need to bring in and think which strategies are really appealing to the clinical world. And also to recognize that the environmental contaminants are not going to be solved only through prevention because of the pervasive effects. So other strategies are important. So I want to be here very provocative and say that maybe we have an opportunity to prevent some of the cancer related to these chemicals that accumulate in the body. So if you smoke, you have a lot of cadmium in your body, which is in your liver, in your kidneys, is continuously for years and years and years in contact, continuous contact with your lung tissues and with all your organs and systems. What if we remove all that cadmium from your body? Would that be beneficial? Could that provide a new opportunity for preventing lung cancer in people who smoke? This is, nobody had investigated that, and I'm sure people would say I'm crazy, and why would do we have to invest in that? But I am going to bring you some additional research showing that that has actually worked for cardiovascular disease prevention, which is really intriguing because there are many connections in etiology and development between cancer and cardiovascular disease. And so this is a clinical trial published in JAMA in 2013, where metal chelation in people who already have a myocardial infarction was actually beneficial and prevented the future development of cardiovascular disease. And what is interesting, the effect was stronger in people with diabetes. But what is very interesting is that the treatment was only given for a year.
but the separation of the curves persists for many years. And this suggests that you have maybe removed something that was toxic in the body. All the treatments for cardiovascular disease don't work like this. If you stop giving statins to people, immediately your curves go back. If you stop giving antihypertensive medication, your curves go back again. So this really supports that this treatment was able to do something that was permanent, a permanent benefit that persisted over decades, over years, after the treatment was given. So to me, this is very interesting, something that we should, I think, pursue. It's not going to be easy. Nobody is going to give us money right now, but I think we should think about this. And so I have a next slide. We have now a second trial, which is a replication trial of the first one. And this is the TAC2 trial. This is a study that Regina Santella here was leading the biorepository effort. All the samples have been collected from patients all around the US and Canada. And it's again a cardiovascular trial. But this trial might provide an opportunity for us to think about how can we move this idea from cardiovascular disease maybe to cancer prevention. So now I am going to end now, but this is in this figure, I put together a little bit of research that I've done for 20 years since that first paper that was so influential in my way of thinking. And I focus a lot of environmental problems with a focus on metals and in working in many cohort studies. But my second life that I didn't talk much today was all related to tobacco control, smoke-free environments, tobacco products, and also with the connection with metals. So a few, last summer, last summer, I got a message from the White House and I was very shocked because, I published my first paper in brain tumors and environmental issues, but I didn't consider myself like a cancer person. So I was surprised that President Biden had nominated me for the National Cancer Advisory Board. And I had a second of many minutes of imposter syndrome, like thinking there's so many people I can think of who deserve this more than me. But then I thought back to all the work and the communities I work with and the things that I do. And I thought, you know what? I don't care if I deserve it or not. I have a full agenda and I am just going to do the best I can to make sure the environment it's incorporated and addressed and paid as much attention as possible for research in cancer. So this is kind of my last slide and kind of the way I see my role is to represent a lot of the conversation, the discussion, the ideas that were presented here today and that are so important for the cancer and prevention and control world. So with this, I just want to thank lots of people on our team and lab and efforts, and this is a collective effort.
Thank you so much. I'm so sorry we don't have time for questions. That was an amazing presentation. Our next presenter actually submitted his presentation as a pre-recorded presentation. So it will be a short video from Dr. David Christiani on air pollution exposure and policy change. Dr. Christiani is the Elkin Blount Professor of Environmental Genetics at the Harvard School of Public Health and Professor of Medicine at Harvard Medical School. His major research interest lies in the interaction between human genes and the environment. In the emerging field of molecular epidemiology, he studies the impact of human exposure to pollutants on health, and he's very active in environmental and genetic epidemiology studies internationally. He also previously served on the National Cancer Advisory Board, so you can enjoy his presentation.
Good afternoon, all my friends and colleagues at Columbia. Sorry, I can't be there with you today. I'm happy to send along this recording. Thank the organizers for their invitation. And then, once again, wish all the person this presentation. I'm going to talk about air pollution, ambient air pollution, clean air pollution, and workplace air pollution. Let's talk about community air pollution, so-called ambient air pollution first. This is has such an impact on cancer, particularly lung cancer. So we'll focus a lot on lung cancer, where most of the data is, and then allude to some of the other cancers that air pollution is being linked to. Ambient air pollution, it kills about 4 million people per year globally. At least 1.2 million of these deaths are due to lung cancer. In the US, there are about 234,000 lung cancer cases annually. It's been estimated that at least 10% of these cases are due to air pollution and another 14% due to the combination of air pollution and smoking. Air pollution is linked to other cancers, even though I'm going to focus mostly on lung. Evidence is growing that air pollution can cause cancers at multiple sites. How does it do this? Well, absorption, metabolism, and distribution of inhaled carcinogens with access to many tissues in the body. So epidemiological associations have been described with bladder and kidney, with breast, both incidence / risk of very short survival time, brain, non-solid tumors, which is leukemia, lymphoma, and childhood cancer studies, still limited by size, suggest evidence for the relationship between occupational exposure to cancer has a special place in history. It's the first time that the connection is made between environmental carcinogen as part of human cancer. We're going now back to the late 1700s. Dr. Percival Pott, a clinician in London, Institute Commission noted that young chimneys, since they were involved with child labor, it's like they described ridiculously in the following century, who were put to work in the chimneys, had soot embedded into their scrotal folds, and were developing squamous cell carcinoma of the scrotum. We didn't know what the mechanism was. We didn't know what the exact chemical compound was that was causing this, but we knew that exposure was culprit, and we did hygiene facility in Washington, which eliminated one of the incident experiences of these appearance. Well, most of what we know about environmental exposures that cause cancer actually come from a range of occupational exposures during industrialization. These are much higher. So they were the basis of the first standards set, first consensus on carcinogens by the International Agency for Research on Cancer. These are compounds like asbestos, diesel, loss, benzene, polycyclic hydrocarbons such as co-combination, asphalt, etc. Now, air pollution, pure air pollution is a complex mixture. It's been referred to as a mixture of mixtures. It's a complex mixture of solid and liquid particles, organic and inorganic compounds suspended in the air. Air pollution as a whole has been viewed scientifically as carcinogenic to humans. Hence, it's a coupon carcinogen by the International Agency for Research on Cancer. Globally, air pollution, broadly defined, is estimated to cause about 29% of all lung cancer deaths. What are these things? What are the constituents? Well, the most common one you'll read about, and when you look at AQIs or air quality indices, it's often driven by PM, although an AQI will use the highest level of the criteria of frequency, the PM, the ozone, SO2, NOx, carbon dioxide. It's usually PM. Particulate matter of varying sizes. The smallest size, 2.5 microns or less, and per kilo, 2.5. That's what the current EPA clean air quality standard is based on. Previously, PM10 or 10 microns in mean diameter and total suspended particulates. Those are much larger, largely trapped in the upper airways, but the small particles can get to the lower airways and even alveoli. These are sulfates, metal oxides, various carbonaceous materials, organic carbon, elemental carbon. The source is overwhelmingly fossil fuel combustion, but also biomass fuel combustion, biogenic emissions, fertilizers, dust storms, and naturally occurring storms, although the storms get worse as the earth warms up and water tables drop. Ozone is a gas, as is SO2, carbon dioxide, and oxides of nitrogen, all related from combustion use. And household air pollutants can have many of these same compounds. Incomplete combustion will lead to excessive quantities of things like benzene, butadiene. Organic compound I mentioned, and metals such as mercury and lead can all take place in major air pollutants, particularly urban air pollutants. So many outdoor air agents are established or probable IR carcinogens. Established means 1, and class 2A means probable, and 2B is possible. So you can see from the list a number of these, and again, most of these came from occupational exposures first in epidemiologic studies, but we now know that these constituents occur in many community air pollutants as well. Down below, organic compounds, particularly butadiene and benzene, will be released from gasoline products and other industrial products. Ethylene oxide and formaldehyde are big in the healthcare industry, as we know, as are some halogenated compounds. But the solvents like trichloroethylene and trichloroethane are used in the industry, widely in industry and in gasoline. Polycyclic compounds such as benzene, iodine and its cousins are down below. Those are the prototype human and animal carcinogen. Mixtures can be quite complex. So you can have biomass fuels like wood and indoor air pollution from household combustion, but you can also have more intense emissions from the burning of coal and creosotes, diesel engines, etc. And of course, they have tobacco smoke and secondhand smoke, all of which are another human facility. So let's talk about this air pollution, lung cancer, mortality risk from the PM2.5 point of view. The largest study to date that was published in 2002 helped set the science stronger in terms of dose response for PM2.5 air pollution and lung cancer risk, and actually other outcomes. There were 1.2 million adults in the ACS cohort enrolled in the early 80s. 500 adults had the data linked with air pollution data, EPA data, a huge data set, and studied for 2 decades. So in this case, the average annual elevation in PM2.5 of 10 microns per cubic meter, for EPA standard, I believe it's the month from 15 to 12, for average annual. For each 10 micron elevation is associated with an 8% increase in lung cancer mortality, 6% in cardiopulmonary mortality, and 4% in all-cause mortality. This study has been not only replicated in the decades since then, but refined to look at multiple outcomes in the dose response fashion, particularly with older adults in the Medicare database and EPA database put together. There have been a number of very large studies that show morbidity and mortality. And conversely, with improvement in air quality standards, with the Clean Air Act reauthorization, with levels coming down, a reduction or an easing of the burden of all-cause mortality, cardiopulmonary mortality, in lung cancer mortality in the decades since then. Now, the global burden of disease studies were published in 2017. They, for the first time, had very granular data, 195 countries, lung cancer and COPD mortality, looked at spatial and time trends in mortality and the burden of disease attributed to PM2.5, which we have victims. The lung cancer attribution, as you can see, in 2015 was 17%, in 2017, 19%. COPD on the right being greater. These are very large attributable risks to PM2.5 air pollution. So what can physicians do? What can clinicians do? Is we want to reduce exposure to carcinogens for our patients, for ourselves, But reducing exposure is an important opportunity for cancer prevention. One thing that's good about knowing the cause of something, a causal association, is our ability to intervene and reduce or eliminate risk. And certainly we're going to reduce risk here. But the tools most familiar to clinicians, patient education, understanding steps that individuals can take are often insufficient for reducing exposure because pollution is largely beyond the control of individuals, not preventers. But there are pathways that we can embark on to reduce air pollution related cancer risks. One is inform our patients. Patients with follow air quality rates. In the last 3-4 weeks, we had major instances in the Northeast, in Boston, New York, Philadelphia, Maryland, and everywhere in between. Severe particulate air pollution and associated gases from the wildfires in Canada. The levels reached that broke records. New York had record-breaking air pollution last week in Boston. Had also record-breaking air pollution last week in the hundreds of micrograms per cubic meter. These alerts are important to patients. Patient advisories, patients particularly with underlying cardiopulmonary disease, should stay indoors and ideally indoors with an air cleaner. Obviously, we'd like to make those more affordable for people to use, but definitely indoors with an air cleaner is better than outdoors, and any exertion outdoors. Workplace controls are always important with hazardous product substitution, engineering, and personal protective equipment. And alternative transportation, walking, biking versus driving, and public transit versus driving, all reduce fossil fuel use. We also can play a role in the healthcare industry. We actually work in a dangerous industry, a certainly dirty industry. Healthcare industry in the US has been estimated to result in 27% of greenhouse gas emissions for the country, and at least 5% globally. A lot of this is, of course, as I mentioned, greenhouse gas emissions are what's mediated through pollution. So incineration of all our disposables, waste from the hospital is massive, not to mention the disposal of drugs, radioactive materials in the environment. So we can start to push our own institutions to be more cognizant and to reduce waste and to be more energy efficient in appliances and tools at hospital level, healthcare level. Recycle and reuse at the hospital and healthcare level and to help our patients do the same. Advocacy is very important. Public speaking and education policy pressures from doctors is important. We have a very important role in the community. We're held in high esteem and we should earn it. Examples of professional advocacy include the American Thoracic Society, the American Lung Association, the American Cancer Society. They've all filed a mucus brief to support Clean Air Act and stricter controls around the country at state level and national level. They will train and advise you on how to speak to the public on these issues. And you can get involved in the local branches of these associations. But public policy is key. And as physician practitioners, we can play a role. As physicians of the research, we can continue to provide science-based regulatory information. That is information and policy development that's based on a good science, such as the studies I mentioned before, that can then become a foundation for translation and action and implementation. And the need to protect the Clean Air Act. It needs to be reauthorized periodically and it's constantly under attack. In the fossil fuel industry, and we simply need to hold the fort on that. And as doctors and other healthcare professionals, we have social status and that we should raise our voices for our patients. So with that, enjoy the rest of the meeting. And
Pleased to introduce our next speaker, Dr. Dean Osgood, presenting on what we know about air pollution and cancer, science and interventions to reduce exposures. Dr. Osgood is an associate professor and the Alton Foundation Chair in Epidemiology and Population Health at the Albert Einstein College of Medicine in the Bronx. He's also the director of Global Environmental Health at the Global Health Center, co-leader of the Cancer Epidemiology Prevention and Control Program of the Einstein Cancer Center, and co-director of the PhD in clinical investigation. His research focuses on identifying associations between environmental exposures and adverse health outcomes, with an emphasis on cancer and gene-environment interaction.
Thank you very much for the introduction and the invitation. Thank you for everyone sticking it out here on a beautiful first day of summer outside. It is not lost on me that I'm one of the last few standing between you and the outside. So we're gonna, what I'm gonna do today, as my slide being loaded, I'm gonna sort of speak a little bit at a higher level, sort of what we know about air pollution and cancer. And I'll speak a little bit, touch on a little bit about the research that I've been doing internationally as well as in the Bronx. But really, we've been very fortunate just from hearing from one of the world's experts, David Christiani, about a lot of what we do know. So I'm all that I get to follow him. And so it's helpful I see my slides on this screen. So much like Anna was talking about how she spent a bunch of her research and career looking at tap water in someone's home and how that relates to their health outcomes. I've spent a lot of my career looking at how air pollution in their home as well as in their outdoor environment can be related to health outcomes. And I think what really drives me here is that because a lot of times individuals can't necessarily choose where they live. Individuals can move to a neighborhood. They can choose which apartment or which house or which state they live in. But oftentimes, most polluted areas or the similar individuals who have the lowest socioeconomic status are not able to kind of rise, but move out to a different community if they wanted to. And so, so I'll wait just a few more minutes and I think I'm in the same boat as Anna. I don't see him here, which is okay. If I can so yes, okay, great. All right. So again, I'll try to keep my comments brief. Okay, thank you. So again, I'll try to keep my comments brief, but when we think about the things that individuals are breathing in on a day-to-day basis, obviously any talk on this topic would be remiss if it didn't include tobacco smoke, active tobacco smoke, passive tobacco smoke. And we also have individuals who are susceptible who aren't even smoking or choosing to be in a smoking environment. And then we have the ambient air pollution, which you heard David speak at length about in the last last presentation, where we have combustible airborne products that are coming from incinerators and energy generation, smog from traffic in urban environments. And then, as we all know, and as we experienced in the last couple of weeks, you can also have some really heavy levels as you're walking around in the environment due to wildfires and other sources. And then there's household air pollution, something that we don't often think about in New York City, but it's true that about 3 billion people, or about half the world's population, are still reliant on burning wood and coal in their home to heat and cook. And so here's an example of a house that I was studying in rural China, where they just had a pit dug in the middle of the home, where they were burning coal with no ventilation. So as you can imagine, this leads to massive exposures. And again, these are rural, poor communities who have no say, not necessarily no say, but have no ability to change what type of fuel they're using to feed their children. And so when we quantify these exposures and we look at this across the global burden of disease, which I was involved in for the household air pollution component, we see that air pollution together is the fourth leading cause of disease or fifth leading cause of disease in the world, contributing to about 6 million deaths per year. And when we combine that with tobacco smoking, which is the number 4 leading cause, we see it's 15 million deaths per year are attributed to this. And so I know a lot of clinicians in the room, so I don't need to dwell on the facts, but when we think about what diseases could somebody be at risk for these exposures, we think of the root of exposure, and oftentimes with air pollution, based on the particle size, it will determine how deep it gets within the lung. And what we do know from emerging evidence is that not only do these particles deposit deep within the lung, which also contributes dramatically to lung cancer, as we'll talk about, they're also crossing into the blood stream. And not only are these particles crossing into the bloodstream, we now have evidence that these particles are crossing the blood-brain barrier. We have a study right now going on in Bronx, our Einstein aging study, where we're doing air monitoring on 1,000 individuals and looking at cognitive function, cognitive decline. So we are seeing that there are some mental brain impacts as well. This was mentioned earlier, again, just because we'd be remiss if we didn't talk about smoking. We've known smoking has caused lung cancer since the original report in the 1950s. Since then, there have been at least 7,000 publications of additional evidence on the relationship between smoking and lung cancer. And we know that there are interventions that we can use to reduce these exposures across our populations. But what is the evidence for our air pollution? And what we know is when we're looking at household air pollution, when we're looking at coal smoke, we look at every paper published in the world. Again, we oftentimes don't think of this in the United States, but there are some studies here in North America. We see that individuals who had coal exposure in the home have a over twofold increased risk of lung cancer associated with burning coal in the home. There is also evidence that it's about a 1.3 increased risk or 30% increased risk of individuals who are burning wood. And when we look at outdoor air pollution, looking at all the evidence across the literature, we see that, as Dr. Christiani was saying, with every 10 microgram per meter cube increase, we see about a 10% increased risk of lung cancer mortality. All of this evidence is summarized here, and I highlight the books here because if you're interested, you can download these for free from the World Health Organization's website, where the IARC ruling is that indoor air pollution from coal smoke, based on a lot of the intervention studies that we've done in China, is a group 1 lung carcinogen, and wood smoke is a probable carcinogen, meaning that there's suggestion, but there's not sufficient evidence to deem it a carcinogen. And outdoor air pollution is a group 1 carcinogen for lung cancer with a possible positive association with bladder cancer. So if we look at over time across the globe, we see some encouraging findings. We see that lung cancer attributed to tobacco smoke has decreased by 13% from 1990 to 2017. This is data from our global burning disease study. And we see that the lung cancer attributed to household air pollution has decreased by almost 60%. However, for ambient air pollution, lung cancer has increased by 17% over that same time. This is, however, is masking some of the trends that we're seeing when we look across the different economies of our countries. When we look at high-income countries, we see that most of the lung cancer is driven by tobacco smoke. However, looking at low-income countries, and particularly among females, we see that household air pollution is still the driver of lung cancer among these exposures. And it's still highly prevalent in our low, middle, and our middle-income countries. Now, one thing you will notice in all of these, no matter how we look at it, by low-income country, middle-income country, high-income country, everyone has the similar trend that lung cancer attributed to outdoor air pollution is increasing. That's the dark green, the bottom, increasing in all across our globe. So what have some of the other research been? Looking at other cancer sites, ones that have been researched but have not had sufficient evidence for there to be rulings by IARC. We see that breast cancer as the sister study, as we were hearing about earlier today. And for outdoor air pollution, we see some upper aerodigestive tract in the SCAPE study conducted in Europe. And then some work done by my group where we were looking at household air pollution and other cancer sites. We see that there's suggestions for cancer of other sites such as cervical cancer. Although, however, most of these studies were all what we would say called case control studies. So everyone had the disease before they were asked about their exposure. So these are inherently are biased. Individuals, by design, individuals when they're told they have cancer tend to think about their exposure a little differently. And so what we've established is the Household Air Pollution Consortium, where we have collected data on about 1 million participants across the globe for 14 different sites. And we have household air pollution data on individuals that are that was collected when they were healthy, and then they're followed forward for 10, 20, 30, 40, 50 years. And we are in the process of analyzing the data from these 1 million participants. And these are predominantly from rural communities in low income settings, not just in Asia, but also in North America. Sister Study is one of them. And the other advantage that we have for this consortium is we have their addresses. So we have all of the individuals' addresses. We've been able to geocode them. We're able to use satellite imagery. Here's just an example in China, where we can go to historic satellite images and we can quantify the outdoor air pollution exposures as well. That relation to cancer mortality. Given our sample size, we believe we will have sufficient power to answer the question of the additional cancer sites that may be associated with air pollution beyond lead cancer and beyond breast cancer. So I was asked to touch on some of the interventions. Some of the interventions that we know have worked in the U.S. to reduce tobacco use have been increasing the taxes on tobacco use. And down here, we see some of the advocacy campaigns that have been done in, I think this is might be New Zealand, putting images of diseases that you might incur from smoking tobacco. But what can we do to reduce the risks of air pollution? Dr. Christiani also touched on this. We're seeing this now in real time. We are seeing that individuals now are very aware of what is the air quality index. And so individuals themselves can be monitoring themselves and making their own choices on a day-to-day basis. There's also now portable air monitoring that individuals such as yourselves can wear and walk around with, or tie to a smartphone app. These are the technologies that we're using in the Einstein aging study, where we have about 1,000 individuals walking around the Bronx wearing this monitoring. And then, of course, as we know, one of the things that came out of the pandemic is everyone now has N95s in their house, and that is what happened with the spike in air pollution that we saw here in New York. I was in Pennsylvania at the time, but I was helping our chief of pulmonology. We were kind of preparing. We thought there was going to be a big spike of patients coming in with asthma exacerbation. It didn't happen. We were a little surprised, to the point where we quickly mobilized and contacted a lot of the patients and said, "How are you today?" They said, "I'm great. I stayed home and I wore N95." And so we actually didn't see as dramatic as a spike as we thought we would have seen in our hospital system. But a lot of these interventions at the individual level are oftentimes not feasible. These individuals have a lot of other things going on in their lives. And as work with my community health office at Monterey Health System, we believe that about 50% of health, involving your socioeconomic factors and your physical environment, can be tied back to your address. And that goes beyond what an individual can necessarily do with their intervention. And so what can you do at the address level? And so one thing that we're doing in the Bronx right now is we're trying to do research where we're looking at our catchment area. We have about 1.5 million patients per year, and we have their electronic health record data, we have their addresses, and we're now looking to quantify and start teasing out the influences of the air pollution relative to other environmental exposures, as well as other social determinants of health, other social needs, such as structural racism or access to care, et cetera. But things that we can be doing now outside of the research component, I just want to highlight this book, also available by the World Health Organization, for any individuals who may be able to influence different sectors. These are sort of some of the things that we can be doing for air pollution interventions at the city level: transportation, housing, industry, power generation, waste management, agriculture. A lot of these are often focused on reducing the amount of exposures that we're producing in the environments, such as trying to get power generation divested from solid fuel use, or seeking energy efficient designs and applications. And so while this is very specific to each sector, again, I just would refer people to this individual book to learn more.
Thank you so much, Dr. Osgood. Our next presentation is from Dr. Harry Sheffield, and it is also a video presentation, so hopefully we'll be able to get that up and running for everyone to enjoy. Dr. Sheffield is an associate professor in environmental medicine and public health and pediatrics at the Icahn School of Medicine at Mount Sinai in New York City. She co-directs the U.S. EPA Region 2 Pediatric Environmental Health Specialty Unit, and her research focuses on climate change sensitive health outcomes with current work exploring children's vulnerability to heat. And her presentation will be on how physicians can advocate for patients who have concerns about environmental exposures.
Is to be able to present at this Cancer and Environment CME event. My remarks will focus on clinicians as advocates for patients who have concerns about environmental exposures. And I'll use childhood cancer as a case study. You'll see I took some liberties with the talk title from the agenda to be clear that this is relevant to not just physicians, but also others, namely nurses and nurse practitioners, but really anyone working in oncology and beyond. So I work at Mount Sinai with the pediatric environment. We're also hearing from my colleagues there today. At Sinai, our team is involved in the National Pediatric Environmental Health Network and the the statewide network of children's environmental centers, children's environmental health centers called NICE. Through my work with the PACU, this year I've been part of the Childhood Cancer and Environment Project that's led by colleagues from our California-based PACU with support from the American Academy of Pediatrics. This project is an exciting new initiative supported by CDC funding from new legislation called Trevor's Law that's working to close a number of gaps in oncology, including spreading and acting on what we know about environmental contributors to childhood cancer. I have three objectives in this brief talk: provide context of our environmental understanding of children's cancer, explain the risk communication concepts that make childhood cancer a teachable moment for everyone, and explain how advocacy benefits patients and clinicians. So first, a little context. From this 2015 survey of doctors and nurses working in peds oncology, we know that the majority of pediatric oncology clinicians think that environment matters for cancer. Nurses are being the most astute. But a spoiler alert, it does matter. And we also know from this survey that a sizable proportion of clinicians are not yet aware or convinced of its importance. In that same survey, only 6% of the respondents reported taking any training on environmental history taking. And of those that did, over half asked about the parent's occupation, a little less asked about household tobacco smoke, 44% asked about any radiation, unintentional radiation exposures, and smaller numbers asked about exposure to pesticides or sun exposure or solvent use. And about a quarter of the respondents didn't ask about any specific exposures. So this is a good start, but it's woefully insufficient. Clinicians should understand the potential risks. They should assess individual risks and inform and guide families to also understand and make choices. Clinical knowledge and practice, and then translate from individual action to collective action, and we hope policy change. Over this year with the Childhood Cancer and Environment Project, we've learned that many who work in oncology have never heard or never had the chance to learn about the international agency that is the definitive body assessing carcinogenicity. IARC, or the International Agency for Research on Cancer, that is that body, and they use this group designation system you see here, with one being assigned to exposures with the clearest links to cancer. So here's an example of the gap between what we know and what we do. Benzene has been designated as a class 1 carcinogen by IARC. The chemical is a component of tobacco smoke, gasoline, car exhaust. And this CDC meta-analysis of 7 studies of children living near traffic roads showed a 50% increase in risk of childhood leukemia for those children. Benzene is also recognized as a risk for adult leukemia, specifically myeloid leukemia. So I just told you in the prior slides that few clinicians take an environmental history, and even fewer ask specifically about potential sources of benzene. These questions could have a role in general pediatrics, but also for children who already have a diagnosis of cancer as a way of reducing secondary harms, improving quality of life and survivorship, and even protecting younger or not yet born future siblings. So this is why childhood cancer is a teachable moment for it. Well, no. So why is childhood cancer a teachable moment for really for everyone, we think, involved in the care, the doctors, the nurses, the patients and their families. So the National Academy of Science defines risk communication as the interactive process of exchange of information and opinion among individuals, groups, or institutions. I like to think of it as sort of arranging the orange slices in a palatable way. And there's a number of conceptual theories that underlie risk communication. Those are things like trust determination. So the person conveying the new information matters, and clinicians are generally considered very trusted messengers. Another theory is cognitive attenuation or mental noise. That's the idea that when we're worried, we don't listen well, we don't remember well. When a child is first getting a cancer diagnosis, the mental noise for the family is incredibly high, but this wanes over time. And eventually in the journey, families will have the bandwidth to start wondering, asking questions, and engaging in dialogue. And then the third conceptual theory is risk perception. So we're gonna dive into that just a little bit deeper. Risk perception. We know that the actual risk of something doing harm to us doesn't usually determine if we perceive it as risky or scary. So factors that decrease how much we worry about something include things like the things on the left here: trust, control, familiarity. Think about the family car, right? We don't think of that as scary, and yet we know statistically motor vehicle crashes are a huge source of morbidity and mortality, particularly for young people. Factors that increase our sense of worry include a sense of something being involuntary or sinister, like human caused but not natural, having an identifiable victim, particularly things that involve children. Hence, pediatric cancer, particularly if there's a potential that chemicals or radiation played a role, are really high up there on the list. Now, what we consider dangerous, how we perceive the risk of something, can change over time. That sign on the side of the truck that's spraying DDT pesticide says harmless to humans. And we know now from science that there's many potential negative health effects and certainly environmental consequences, and then upstream health effects, endocrine disruption, subclinical health effects from a pesticide like DDT. So I don't mean to imply that just because the idea of something like corporations profiting from pollution that causes cancer in children or other health problems like DDT is enough to have families take to the streets. But I do think that understanding these linkages, these very clear linkages in many cases now, is a piece of that much bigger puzzle. And having clinicians be able to connect those dots is really key to that. So the dots I want to connect are linking how advocacy benefits both patients and clinicians. Advocacy can be an antidote to a lot of things. Ideally, it's a step toward changing something structural that's perpetuating harm, addressing something like implicit bias, reducing carbon pollution, eliminating racist housing policies. And also, advocacy can improve patient care. It can improve the rapport between clinicians and patients. And I'd also argue that potentially it can reduce clinician burnout by connecting us as clinicians more to prevention, reducing harm from the get-go, connecting us more to the bigger context and a larger purpose. The Childhood Cancer and Environment program is motivated by all these potential benefits of advocacy. So some of our work in this program is spreading understanding about the underlying science of childhood cancers, things that I'm touching on like benzene today, and the growing understanding of what role the environment plays. But we're also promoting simple mnemonics like this one, ACHU, to encourage clinicians to take an environmental history, raise everyone's awareness, even when we don't have all the answers. So ACHU stands for asking about activities, community, housing, health, occupations, oral behaviors, and other. So we have a lot to learn, but it's not too early to start equipping clinicians. And sometimes the information helps convey the complexity and really engage in some nuanced conversations with patients. For example, daycare attendance. A meta-analysis of 15 studies shown in this slide examined early exposures to large daycare settings and found that it reduces acute lymphoblastic leukemia risk over 20%. The protection factors are likely associated with immune programming that occurs in the setting of more frequent infections. But we're still teasing that apart. And as trusted messengers, clinicians can help patients navigate this sometimes confusing science and then ultimately make a decision that's right for their family. We believe that clinical knowledge and practice will translate to ability to speak out and about these topics. And I have a couple more examples of the state of science that focuses on protective factors. So breastfeeding, for example, there's several pooled and meta-analyses that confirmed that breastfeeding for a duration of 6 months or more can reduce the risk of childhood leukemia by about 15%. And in terms of diet, if we're able to get the messages to families before conception, to adults before they even are getting pregnant, our California colleagues have developed materials like this one to emphasize what we know about reducing risk of childhood leukemia, for example, before and during pregnancy. More fruits and vegetables, regular folic acid, less caffeine and alcohol, some things that have other health co-benefits that we know of as well. So to come full circle to this idea of the teachable moment, a childhood cancer diagnosis sends shockwaves through a family. And while that family may not be ready for a speech about protective factors like breastfeeding or dietary habits, while they're in the crisis mode and getting treatment, when that cognitive attenuation or that mental noise tempers a bit, many families have expressed interest in being offered resources, particularly as they move into survivorship phase, which the majority of childhood cancer patients do. So I hope that this brief talk has stirred some interest and helped frame that we're really well poised to make some real changes. So I'll close by saying that the next phase of the Childhood Cancer and the Environment project in later this year and in 2024 will be running trainings in some major cancer centers, those who commit to integrating screening and guidance into clinical care. And there are possibly some more openings for that, where those trainings will take place. So I'd be happy to push you in touch with the project leadership if you think your institution may be a good fit. Thanks very much for your attention today.
Thank you so much to all of our speakers and thank you all for your attention. We are going to move now to our third and final panel on the role of institutions to inform patients and reduce environmental exposures in the communities that we serve. Our moderator for this panel is Dr. Gary Meyer. He is the Vice Dean of Research Strategy and Innovation and Professor of Environmental Health Sciences at Columbia University Mellon School of Public Health. He's a leader in the exosome field, which strives to provide a systematic and comprehensive analysis of the non-genetic contributors to health and disease. He was the founding director of the Hercules Exposome Research Center at Emory University, the first such center in the US. And he authored the first book on the topic, The Exposome of Primates. This research focuses on the environmental drivers of neurodegeneration, and we are so glad to have you moderate this.
So allow my panelists to join me up here. I believe that we're going to have Holly and Ian. So just as people are getting up here, one of my observations here, obviously this is focused on the environment, but we often think about the genetic component of diseases, and we can think about the individual genes involved in cancer, but we're all very comfortable with the polygenic risk, the idea that multiple genes can work together in many different ways to contribute to disease. But we still talk about the environmental things as kind of one type at a time. But we have to start thinking about this sort of like a poly exposure risk. And so what are the things we can do to reduce combinations of exposures that even though they may not individually reach an IARC level, they likely are contributing to the problem. I think this is a better way of thinking about this. So what I'd like to do is very quickly, we've already met two of our speakers and spoken before, but for those that are new up here, we have Linda Mermelstein, Erica Phillips, and Maura Abbott. If they could each introduce themselves and their role at their institution. Start with Linda.
Hi, my name is Linda Mermelstein, and I'm the Associate Director for Community Outreach and Engagement at Stony Brook Cancer Center on Long Island. Hi, I'm Herbert Phillips. I am an Associate Professor of Clinical Medicine at Cornell and also the Associate Director of Community Outreach and Engagement for the Meyer Cancer Center.
Hi, everybody. I'm Maura Abbott. I'm an associate professor here in the Institute of Affairs at Columbia School of Nursing. I'm an oncology and pediatric nurse practitioner, and here at Columbia, I run the oncology department here.
And then we also have Anna has joined us, but you also introduced her already. So what I'd like to do, can you hear me okay? I switched mics. So is thinking again of this institutional level. And I was thinking about posing questions like, how can our institutions act to inform information on these risks and do something about it? But I want to make this a bit more actually. What will we do? And actually, what individually, what will we do when we leave this conference to do this? So in thinking about this and thinking about the dissemination of the information, but then actually what we can do at our own institutions, as was pointed out, between 8 or 20% of the emissions that contribute to climate change come from the healthcare industry. And so there's things that we should be able to do better. But we also have to protect our communities who we are working with very closely. And so one, on the tithing issue, we're going to be only 10 minutes over at the end of all this because Mary Beth and Regina have assured that their comments are very close, very tight, and so we'll have 20 minutes for this discussion with them. But my understanding is that Linda is on a timeline, so I'm going to turn to Linda first.
Okay, well, first of all, I guess I would just like to say that an institution is many parts. So there's the administrative part, the clinical part, the research part. So each has a role to play in disseminating information about environmental harms. And so I'm going to take it from a couple of different positions. And actually, a lot of the things that I'm going to talk about have been covered. So for example, if you have an electronic health record and you take care of patients, does your electronic health record support taking clinical decision support that would sort of lead you to taking that history that you need to take to addressing education for your patients, and to providing information and making an accurate assessment. So things like knowing what the problems are in your community. If you're a healthcare practitioner, did you know that radon is a problem in houses in your community? Did you know that you live in a community where you have an underground water aquifer source? So anything that goes into the ground is going into the ground. So do you know that that might be a concern? Do you know what the problems are in your community so that you can make sure that you address those things? And then as an institution, are you making sure that you're providing education for that to your practitioners? If you have a medical school or nursing school or any kind of health professional school, again, are you covering those topics in your curriculum? So all of those things help to let you know sort of the community of the institution that you work in. Another thing is to promote research. So are you promoting research in that area? For example, Stony Brook at our cancer center, we work very closely with the School of Marine and Atmospheric Sciences. There's experts there on climate change. There's experts there again on environmental exposures. So we work with them to support their research, and they work with us to support our research on environmental cancer. So those are the kinds of things you can do. Of course, there's also talking to the community. So in our office of community outreach and engagement, things like this presentation that we have it, and participate in the New York State Cancer Coalition and the New York State Environmental Carcinogen Action Team. And so as part of that activity, I'm collaborating with other institutions about environmental exposures, and then we're bringing the message out to the community. This is bringing the message to both the community and to practitioners and professionals. So the other thing is to know what the resources are, making sure that your entire providers, everybody in the institution knows where to look for information or resources to assist.
So it sounds like Stony Brook is doing a lot of things well. What do you think they could do better in these areas?
I don't know. Honestly, I've only been there since 2019. So I don't have a lot of I've found that everyone is really supportive, and we have funding. We have really the ability to collaborate. So I haven't myself experienced roadblocks per se. I guess the only thing I can say is that there's competition. Some of the resources for getting the word out to the community. There's so many different kinds of academic university that maybe it's first where services to
coordination with the community is always one of the challenges.
we're more boots on the ground. We have our staff working with people trying to reach different groups rather than relying on social media and to get there's less staff.
Yeah.
So I wanted to take a step back from just the cancer perspective. Sometimes when we silo diseases, the problem that we run into is that people are privileged enough to live with just one particular health condition, conditions. And so, especially when we think about environmental change, especially something like climate, I think we just had a whole clouds of smoke that touched New York more than a week ago. It's, I think from an institution standpoint, what we can do is better bring together all of the groups who work in particular areas. A lot of climate change, especially heat, has an impact on cardiovascular disease. But we find that cancer and cardiovascular disease often stay in silos separate from each other in terms of efforts. And so I think from an institutional standpoint, I think one thing that we can do better is to actually look at how these things overlap, recognizing that the competing information delivered to individuals, whether it be patient or community members, actually creates greater discordance rather than concordance in terms of effort. So I think that's what we want to do, which is to really look at risk factors, not just living in one health condition, but whether people in the overarching health conditions that that
rather than just. One of my follow-up questions was going to be about aligning with other diseases because there's not any disease I'm aware of where we encourage more exposure to air pollution and toxic chemicals. Right, so we should be working together on this aligning because all of these things and practices improve the health of the population. And again, multiple diseases and things. So it is something where there's limited resources, the we can work together. I think it's definitely a good answer.
So a lot, I think that I was going to say has been said, but I think the one thing that we can really do, and I think you know, right before this, I was taught how to do an environmental history when I was a practitioner. So I'm going to play on that survey. So that was interesting to me. And I think as an institution and as an oncology provider, one of the things that our biggest resources that we're lacking is time. And I think that institutions can allow for time because time is it's not just money, but time, right? It's access for patients getting in the door. But we need to take the time to train our clinicians, whether they be physicians, PAs, nurse practitioners, RNs. We need to be able to take the time to have training for people to learn how to take an environmental health history and understand that it does impact future cancer patients. I think in oncology, we are so focused on the patient in front of us and getting them into treatment and getting them, coordinated for therapy and addressing whether or not they can afford copays or be out of work to get them there. And we're focusing on all those logistics without actually stopping and thinking, how do we stop this? And I think we need to help in terms of, in addition to like concrete training on how to do things like environmental health, but also having people time to their daily say, let's see how we can put this and reframe how they're thinking so that they think that's. I have never been told that somebody couldn't hear my mouth in my entire career, so I will.
We'll all try to speak up some more. Dean, Donna,
Sure. I mean, I think everyone's highlighted a lot of important things. One thing that I'll say that Montefiore and Einstein Cancer Center, what we're doing in the Bronx, is in the way I describe it to individuals before we do one of these activities. It's listen, 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 respond, and then listen some more. So I've spent the last 2 years going out into the community and asking them, what in your day-to-day lives is of concern to you? It could be environmental pollution, other social needs. And then what we're able to do is sort of respond in terms of, well, we can collaborate in terms of research, but also we have community health workers that can then go out and help those individuals get navigated through the right clinical systems. And so I think it's kind of that, for lack of a better phrase, that bi-direction, helping the community members in terms of their needs, whether it be medical or not, as well as them having the trust and overcoming a lot of mistrust in the research community to be willing to participate in studies.
have you found yourself helping them with advocacy, like the politicians and things, providing the technical expertise to help them advocate for themselves?
Me personally, I have not. But what we are seeing is a lot of the needs are having to do around food security and housing safety. And so that's where our community health workers in that instance, they're not linking them to someone in our clinical system, but linking them to local advocacy groups in the Bronx to have those resources.
Thinking of this idea that for genetics, we have this science that is so strong and powerful, and for environment, it seems that we are always lagging behind. But I want to believe that the 21st century, at least what we have remaining, is going to be the century of the environment. And institutions can do a lot to put those messages out, allowing us for flexibility. I think it's important. We have systems that help so much interact, work across institutions, disciplines, parts, not only the medical field, but many other disciplines, the system science. I think it's really important. And also, but at the same time, while you allow for this consortia and groups, big efforts come together, still we can room for creativity and
young people to come in and bringing ideas. And so I think all of that is very important. And I think it's really an exciting time in many ways. I think we have tools and technology and a power from the community side, bringing in ideas and messages that I think that combination is quite unique. And I feel that hopefully we can leverage it. So I am excited for the years to come.
Thank you. Well, I'm not part of one of the New York-based institutions, so this is going to be easy for me to say. Now, a little more broadly, just to encourage institutions to be bold in the leadership that they take, and disseminating information in communities and all that we talked about is really important. And there's influences that institutions can have on their fellow institutions. For example, we would love to see a third annual Cancer Environment Forum sponsored by another major cancer center next year. So to start to move into a place where you're really claiming that these issues are of importance and being willing to project that. And for example, the shifts that are happening in the moonshot is because powerful institutions have stated that this is really important for them. And just to recognize how much of a lot of shift in our understanding of the severity of the climate crisis came from leadership by institutions, healthcare institutions, and clinicians. That moment of starting to really talk about it in health terms was really a demonstrated tipping point. So get out in front on that. And then just one other thing, which is think about the purchasing power, as we've discussed in a few different settings, as also an opportunity for education. So for example, if you've got waiting rooms where children are playing while their siblings are being treated for cancer, what an opportunity to put, flooring in there that is non-toxic, to put toys in there that are non-toxic, et cetera. And then to have plaques in those rooms that draw families into gentle learning about this. This is being done in other places, and it's really powerful. So sort of putting it forward that you're as an institution making these changes physically, but then seeing that really is an opportunity for education as well. And then just thinking systematically about settings that are influential. The Cancer Advisory Board now that Anna's sitting on is great. The Moonshot, others, many different forums like that, which you could sort of look at proactively, decide where you could take leadership.
It is interesting to the point about in the genetics community, they have a very strong lobby, and they have pharma always ready for their discoveries. Whereas we're approaching industries and creating financial challenges for them, which is a big deal. So it is something we have to overcome, but I think we even need to have more collaboration because of what we're up against. One of my observations too, when you think about the 70 or 80,000 chemicals in commerce, is we regulate one chemical at a time. And so in a way, the companies are incentivized to put more chemicals in the environment. It makes it harder to identify individual compounds that are being involved in it. And I think PFAS will be one of these places where we'll see it has to be by chemical effects, because you can't regulate on individual chemicals when there's 8,000 different types of thornated compounds that are out there. So I think there are going to be some changes on some of the regulatory things. Interesting, talking about IR, which came up several times here. I think this might be my closing comments with this one, because I was in a meeting with Chris Weill, the director of IR, and we were talking about the millions and millions of dollars that geneticists spend looking at the missing heritability. Well, when you're thinking about the environment, it's the missing everything else, which is much more what the genetics do. I think this is something I hope the next century is exactly what we do, because these are the moving parts that we can use to figure out. And I think all our institutions have a key role in that. So with that, I will turn it over to you. Or Mary Beth.
Thank you so much to Dr. Miller. This is on, right? Yeah. And to all the panelists. Stay here one quick second, Dr. Phillips. Come up here. I'm going to do the thank yous very quickly, and then I'm going to introduce Dr. Regina Santella, who's going to give the closing comments. As Dr. Miller said, we will finish in 10 minutes, we promise, because we do have a reception upstairs. For anyone online, if you can make it here, please come and visit us. Again, we're sorry for going over, but you can tell we're very passionate about these topics, and we didn't want to leave a single speaker out. And so we apologize for being over. Everything is recorded. Everything will be put on a website so you can listen, share any of the videos with anyone in your network. We also will respond to any questions that we couldn't get to today. We have your contact information through your registration. And so I wanted to just thank you for participating in the first ever New York City one of these types of forum. I want to excite you, Polly, and respond because our Cancer Center director said that he's happy to host this every year for the New York City group. So we can continue that tradition. And thank you for your leadership, and also for Julia Brody and Ruth Ann Riddell for running the first one. And so thank you for that. So this morning I thanked all the different institutions, but I wanted to personally thank Dr. Phillips because she and her leadership at Cornell partnered very closely with co-sponsoring this. So you weren't here this morning, so I wanted to give you a special thank you. And thank you to Cornell. Cornell and Columbia are the two medical schools that make up the New York Presbyterian Hospital Systems. So I want to thank you for your leadership on it. Great. And I also want to thank the Planning Committee, Julia Brody, Ruth Ann Riddell, Regina Santella, Polly Hoffman, Cynthia McKeon, Phoenix Matthews, Andrea Baccarelli, and Laura Yasso. And I especially want to thank, I know I got a lot of thanks today that I totally didn't deserve, because the people who deserve it are the people up front here. If you can just stand up or raise your, please stand up. Kimberly Burke, Ivory, please. Andrea, come on, please. Azim, please stand up. Yeah, please. Okay, Polly, please. Yeah, please. Yeah, thank you so much to the entire group who made this really a wonderful event for all of us. And thank you for all of that. Thank you to all the facilities. It was very complicated, but you made a very wonderful day. And thank you again for all of you for attending. So then very quickly, we wanted to just wrap up. And so I thought the best person to provide perspective on all of this was well, I shouldn't say was, she continues to be my mentor, but is the person who got me into environmental health sciences when I was a doctoral student. And that's Dr. Regina Santella, who's a professor of environmental health sciences here at Columbia University. And she is one of the leaders in environmental health sciences and cancer. And has developed the most rigorous tests to use in large population studies to really understand how the environment does cause cancer. And so I know she's mentored a whole generation of scientists and has really led the nation in providing evidence for liver cancer, lung cancer, and breast cancer. So thank you so much. And after her concluding remarks, please join us upstairs.
Okay, I had 10 minutes, now it's down to 1 or 2 minutes. No, it's not going to be that long. So just to remind you what our learning objectives were this morning, we were going to learn how we get evidence about which chemicals cause cancer, what policy and system level changes were needed, and then the role of healthcare professionals. So hopefully you now understand how we get information about how the chemicals are related to cancer. We learned about a lot of the data comes from human epidemiologic studies. We learned that a lot of data comes from animal studies. It doesn't include the human carcinogen, but it gives us a lot of information about what we should look out for. And then that we study mechanisms. There are multiple mechanisms by which chemicals cause cancer, DNA damage, oxidative stress, inflammation. And so we can use studies that look at the effects of chemicals on these different mechanisms. And that's one way that an identification has been made about a whole bunch of chemicals that might be disrupting. So that's the way we identify the information. We also talked a lot about primary prevention, secondary prevention. So obviously the primary prevention, we want to eliminate the exposure. Clearly that's not always possible. So we talked about masks,
We talk about industry being able to regulate within their environment by process changes to reduce the exposure, for example, of fluoride levels. And so that's a primary prevention. But we also discussed screening. And so screening is useful for a number of cancers. An interesting concept that I hadn't thought about before was relating frequency and starting a screening based on your environmental exposures. And so we need to think about that when we set up our screening guidelines. I don't think that's really looked at. We also now know there's a lot about the relationship between gene and environmental exposure. It's important in terms of the time, the windows of susceptibility, the time frame in which you are exposed to difference. And so all of these different aspects of understanding the mechanism of carcinogenesis can lead us to better regulate them. Hopefully, we do understand that there are problems in terms of policy that certain regulations are not going to be enforced. That was brought up, but that one of the roles of everyone here is that was one of the issues important addressing these issues, and it is everyone. So us as researchers developing information, community groups, but we all need to be involved in the regulation of the promotion of the guidelines and the laws that regulate environmental exposures. We need to make sure that those regulations are enforced, that there's no political backsliding in terms of these regulations. And so I think there's not anything else that we want to mention. There was a lot of very important information given here. I hope you digested that you go away invigorated in terms of the work that we do, and that all do want to make have an important impact on the cancer risk of our friends, neighbors, ourselves, our children. And so with that comment, go have some wine, whether it impacts against risk is a little but maybe it's ready to celebrate. And thank you for staying to the end.